Hey everyone! Amazon Web Services or AWS is the world's leading cloud computing platform with a market share of over 30%. It offers a broad range of cloud services that helps businesses manage challenges and meet their organizational goals with over 200 fully featured services and a global infrastructure that spans 77 availability zones in 24 regions. AWS enables businesses of all sizes to innovate fast, reduce cost, and increase agility. But what exactly is AWS? And how can it benefit your business? Well, that's what we are here to discuss. In this AWS full course, we'll take you through all the key concepts and components of AWS and show you the value of AWS for your business. In this full course, you'll start by learning the basics of AWS, including its architecture and console. We'll then delve into the various AWS services and components such as Amazon EC2, Amazon S3, Amazon RDS, Amazon VPC, Route 53, CloudFront, and more, with hands-on demonstrations to help you better understand how they exactly work. You'll also learn about AWS Security and Compliance's features, which are critical for businesses that handle sensitive data. We'll cover AWS Identity and Access Management, Amazon Inspector, AWS Configuration, and other tools that help you maintain a secure and compliant cloud environment. Towards the end of the course, we'll compare AWS with other cloud computing platforms like Azure and GCP so you can better understand the unique advantages and disadvantages of each platform. And after that, we will see some popular AWS certifications and how to prepare for them, including eligibility criteria, roles, and responsibilities. So throughout the course, we'll be joined by our experienced AWS specialists, Sam and Rahul, who will guide you through the keynotes and answer any questions you may have. By the end of this video, you'll have a clear understanding of AWS and its benefits, and you'll be ready to take the next step in your cloud journey. So let's dive into the exciting world of AWS. Also, don't forget to subscribe to our YouTube channel and hit the bell icon for more updates on our latest videos. So let's get started.
Meet Rob. He runs an online shopping portal. The portal started with a modest number of users, but has recently been seeing a surge in the number of visitors. On Black Friday and other holidays, the portal saw so many visitors that the servers were unable to handle the traffic and crashed. Is there a way to improve performance without having to invest in a new server? Wondered Rob. A way to upscale or downscale capacity, depending on the number of users visiting the website at any given point? Well, there is. Amazon Web Services, one of the leaders in the cloud computing market. Before we see how AWS can solve Rob's problem, let's have a look at how AWS reached the position it is at now. AWS was first introduced in 2002 as a means to provide tools and services to developers to incorporate features of Amazon.com to their website. In 2006, its first cloud services offering was introduced. In 2016, AWS surpassed its $10 billion revenue target. And now, AWS offers more than 100 cloud services that span a wide range of domains. Thanks to this, the AWS Cloud Service Platform is now used by more than 45% of the global market. Now, let's talk about what is AWS. AWS, or Amazon Web Service, is a secure cloud computing platform that provides computing power, database, networking, content storage, and much more. The platform also works with a pay-as-you-go pricing model, which means you only pay for how much of the services offered by AWS you use. Some of the other advantages of AWS are security. AWS provides a secure and durable platform that offers end-to-end privacy and security. Experience. You can benefit from the infrastructure management practices born from Amazon's years of experience. Flexible. It allows users to select the OS, language, database, and other services. Easy to use. Users can host applications quickly and securely. Scalable. Depending on user requirements, applications can be scaled up or down. AWS provides a wide range of services across various domains. What if Rob wanted to create an application for his online portal? AWS provides compute services that can support the app development process from start to finish. From developing, deploying, running, to scaling the application, up or down based on the requirements. The popular services include EC2, AWS Lambda, Amazon Lightsail, and Elastic Beanstalk. For storing website data, Rob could use AWS storage services that would enable him to store, access, govern, and analyze data to ensure that costs are reduced, agility is improved, and innovation accelerated. Popular services within this domain include Amazon S3, EBS, S3 Glacier, and Elastic File Storage. Rob can also store the user data in a database with AWS services, which he can then optimize and manage. Popular services in this domain include Amazon RDS, DynamoDB, and Redshift. If Rob's businesses took off and he wanted to separate his cloud infrastructure or scale up his work requests and much more, he would be able to do so with the networking services provided by AWS. Some of the popular networking services include Amazon VPC, Amazon Route 53, and Elastic Load Balancing. Other domains that AWS provides services in are analytics, blockchain, containers, machine learning, Internet of Things, and so on. And there you go. That's AWS for you in a nutshell.
Amazon uses decentralized or distributed IT infrastructure to make several IT resources available on demand. Since the 1990s, it has invested millions of dollars in building and managing large-scale distributed and efficient IT infrastructure. Amazon launched AWS, a cloud computing platform to allow other organizations to take advantage of this reliable IT infrastructure. There are many scenarios in which AWS is an efficient option for running web applications or organization portals. Let's explore a few AWS use cases. A small manufacturing organization can use its expertise in expanding its business through quality production while leaving IT management to AWS. A large enterprise spread across the globe can utilize AWS to deliver training to its distributed workforce. An architecture consulting company can use AWS to get high compute rendering of its construction prototypes. A media company can use AWS to provide different types of content, such as videos, ebooks, and audio files to its worldwide customers. Based on the concept of pay-as-you-go, AWS provides a suite of services that customers can use when required and without any long-term commitments or upfront expenditure. The platform enables customers to procure service such as computing, programming models, database storage, networking, and development platforms in minutes. This allows the customers to enjoy the benefit of low operational overheads. The distributed IT infrastructure provided through AWS has evolved with time through the lessons learned from over 16 years of experience. AWS diligently listens to its customer feedback. This enables the AWS team to efficiently deliver creative features and services. Even today, AWS continues to hone its operational expertise continually to retain lasting reliability by employing its own advances and industry best practices into its cloud infrastructure. As a result, the customers tend to benefit significantly from AWS. These benefits include the following: flexibility, cost-effectiveness, scalability and elasticity, security. Flexibility is the major benefit of using AWS when compared with the traditional IT infrastructure. This benefit is realized in different ways. First, you get more time for core business tasks through the instant availability of new features and services. The traditional IT infrastructure requires a lot of time in planning, designing, procuring, hiring, and managing resources. Second, you enjoy effortless hosting of legacy applications. AWS does not require rewriting legacy applications or learning new technologies. Migrating legacy applications to AWS gives the benefits of advanced computing as well as efficient storage. Last, you get a choice in running services and applications. AWS is flexible enough to run services and applications separately or together as a platform. You can even choose to run a part of your IT infrastructure in AWS and the remaining part in your data centers. Large organizations usually prefer this method of operation. AWS requires no upfront investment, long-term commitment, or minimum expense. This is its significant advantage when compared to the traditional IT infrastructure. Owning and operating one's own infrastructure requires huge investments in IT hardware, power, bandwidth, and human resources. Through AWS, techniques such as auto-scaling and elastic load balancing can automatically scale resources. They scale up the required resources to fulfill a sudden demand and then scale them down when the demand falls without affecting speed and performance. The AWS techniques are ideal for dealing with unpredictable and variable loads. As a result, the organization enjoys the benefits of reduced cost and increased user satisfaction. AWS delivers end-to-end security and privacy to its customers. Its virtual infrastructure offers optimum availability while managing full privacy for customers and isolation of their operations. Customers can expect high physical security, and this is due to Amazon's several years of experience in designing, developing, and running large-scale IT operation centers. AWS ensures confidentiality, integrity, and availability of the user's data. The purpose of AWS compliance is to enable you to understand its powerful controls in action and maintain security and data protection. AWS provides security to their global infrastructure, along with a variety of features for securing critical data in the cloud. Let's explore some of the security highlights. AWS sternly controls, supervises, and audits physical access to their data centers and network. As a customer, you can manage credentials, allowing access to your AWS account. Access Control List, or ACL, type permissions on critical data, as well as encrypted while in storage. Configure a virtual private cloud, or VPC, a virtual network logically isolated in AWS from other virtual networks. Configure and control the operating system on your own Amazon Web Services virtual server. Configure a security group as a virtual firewall to keep an eye on the incoming and outgoing traffic for your virtual servers in AWS. State a key pair at the time of introducing your virtual server in AWS. This key pair is then used to encrypt login information. The AWS IT infrastructure is designed and managed according to the best security practices, certifications, and IT security standards. These certifications include Service Organization Control, or SOC1, SOC2, and SOC3, Federal Information Security Management Act, or FISMA, Department of Defense, or DoD Information Assurance Certification and Accreditation Process, or DIACAP, Federal Risk and Authorization Management Program, or FedRAMP, DoD Cloud Computing Security Requirements Guide, or SRG, Criminal Justice Information Services, or CJIS, National Institute of Standards and Technology, or NIST, Payment Card Industry, or PCI Data Security Standard DSS Level 1. International Organization for Standardization, or ISO 9001 and ISO 27001, U.S. International Traffic in Arms Regulations, or ITAR, Section 508, Voluntary Product Accessibility Template, or VPAT, Federal Information Processing Standard, or FIPS Publication 140-2. The industry-specific standards for customers to deploy their solutions include Health Insurance Portability and Accountability Act, or HIPAA, the Family Educational Rights and Privacy Act, or FERPA, Cloud Security Alliance, or CSA, Motion Picture Association of America, or MPAA.
Today we're going to talk about AWS in 10 minutes. Let's look at the agenda here. let's talk about what AWS is, why it's such a big hit. We'll have a look at the overview of the services. We'll see how much it costs, how big it is, and what the future of AWS is. So, what is AWS? Everyone is talking about Amazon Web Services, but let's have a look at what it is. It's basically a global cloud platform, which allows you to host and manage services on the internet. It's used by almost 80% of Fortune 500 companies to host their infrastructure, and it has a lot of services which it provides to its customers. There's infrastructure service, which means they provide bare servers as a service, so you don't need to manage the backup and the power supply of the service. They provide platform of the service. You can get Java, Ruby, PHP as a service so that you don't have to manage the binaries of these applications. You get software as a service, wherein you get email sending capabilities like SES. You get queuing services like SQS, and it's a cloud storage platform wherein you have a lot of storage options including EBS and S3. So all in all, AWS is a hosting provider, which gives you a lot of services, wherein you can run your applications on the cloud. Now, let's take a look at why it's such a big hit. So everyone is trying to use AWS. Everyone is trying to put their applications on the cloud. So what's the reason that AWS is the top provider and the top choice for doing anything on the cloud? One of the biggest reasons is the billing. So the billing is very clear. You get a per hour billing. Every instance or every service has a micro billing. So, be it instances on EC2, you get per hour billing rate, which is very transparent. Even S3 buckets are charged on a per GB basis, although it is a storage service, but still, there is micro billing available there. The sign-up process is easy. You don't need to sign any agreement, nothing. You just go, sign up with an email ID, add a credit card, and you're good to go. You can go from 0 to 100 in just 2 minutes. You can launch your servers, big machines, without buying hardware. Without procuring any hardware, you can just be up and running in minutes. So, their billing dashboard is also very simple. They give you an integrated billing dashboard, which gives you reports. You can pull out reports every month. You can pull out reports based on services, based on various parameters. For the cloud provider to be a hit, you need it to be stable. It has to be a trusted thing. So their services are quite stable. In the last 7 or 8 years, they have seen some 3 or 4 major outages, but those have been only region specific. So that means out of the 12 or 13 regions in which they operate, the outages have been region specific in a particular country or continent, and those also have not been more than 2 or 3 hours and have not affected all of their customers. It's a trusted vendor. So when we talk about AWS, it comes up as something which is used by everyone in the industry. From small startups to big enterprises, everyone sees Amazon as a trusted advisor. Now, let's have an overview of the most commonly used services. So the first and the most commonly used service is EC2, which is Elastic Compute Cloud. This is the service which gives you bare servers. So this service will give you a machine which you can launch and you can run your software on those. You can get small or big machines based on your requirements. The second choice is VPC. So Amazon will not allow you full control of their cloud. Instead, they give you chunks of their cloud, which is VPC, or the Virtual Private Cloud. So VPC lets you create networks in the cloud and then run your servers in those networks. The next one is S3, which is Simple Storage Service. So S3 gives you the opportunity to upload and share files. So it is mostly a file storage and sharing service. Then you've got RDS, which is Relational Database Service. So this RDS allows you to run and manage databases on the cloud. So they've got almost all the major flavors of databases, right from SQL Server to Oracle and MySQL, PostgreSQL. They have recently launched another one, which is called Aurora, which claims to be a very high-performance database. Then, Route 53 is there for DNS. So, they've got a managed DNS service wherein you can point your DNS to Amazon and they take care of the stuff. So, it's a global DNS service, it's a scalable DNS service, so it scales according to demand. There's also Elastic Load Balancer. The ELB is a service which gives you the opportunity to load balance incoming traffic to multiple machines. So this way, you can scale up your web applications to any number of users. You've got auto-scaling, which adds capacity on the fly to Elastic Load Balancers, so that your website or your application is never down due to a load. How much does it cost? This per hour billing is already mentioned for everything. If it's something like a storage thing, again, there's a per hour or per GB month storage. So I think there is region-specific pricing. So Virginia is the cheapest region out of all of them. So the region-specific pricing is because they have got some regions which they have got good hold of, and they are the headquarters. So Oregon and Virginia are the cheapest actually. They also give you services based on the term. So if you sign up for something for a year, it would be cheaper for you rather than signing up for something on an on-demand basis. So they've got reserved instances which are very cheap as compared to the on-demand ones. You can get discounts from 20% to almost 60% if you sign up for a 3-year term. They are spot resources. Examples of these are spot instances. So this is like a bidding market base, where you can bid for a price. The only downside of this kind of pricing is that your machine might be terminated or your resources might be terminated if someone bids higher. People use these kind of things for doing some ad hoc in-search or some ad hoc tasks, which are really not critical. How big is it? They have got 15 regions across major countries of the world. They've got regions in the US, Europe, Asia Pacific. They've got a global footprint. So in today's world, if you are anywhere in the world, you would have a region within 1,000 miles of your location. They've got massive data centers. So each of their region has got multiple availability zones. So one availability zone can be thought of as a big data center. The data centers have anywhere from 300,000 to 500,000 servers. What is the future of AWS? So they currently have 64 services, which span across infrastructural service, software as a service, platform as a service. They are launching new services in all demands every day. Right now, they are focusing on machine learning. So recently, they've launched a couple of services, which focus exclusively on machine learning. And they are focusing on software as a service product, wherein they want to take control of the service you want to utilize. They don't want you to do it. They want you to upload it to them. And every now and then, they keep on reducing the costs. So you would hear it in the blog that, okay, the price of EC2 machines has been reduced. And this is because of their scale. So they scale up and they give the cost benefit to the customer. That's all for today, guys, with just a quick intro of the Amazon Web Services Cloud.
Talk about AWS here. By the way, I'm Sam. I work as a cloud architect and technical author with Simplilearn. In this section, we're going to talk about what is cloud computing and how things were before AWS. And we're going to talk about what is AWS and the benefits of AWS and the products and services that Amazon offers as of now. And then finally, we're going to end this session with a project that is going to help us understand how to create a Jenkins build server for continuous integration. And in this project, we will learn about how to deploy and host Jenkins, an open source automation software predominantly used for CI/CD, otherwise continuous integration and continuous development. So what is cloud computing? Cloud computing is the on-demand delivery of compute resources through a cloud platform accessed via the internet, and it's also a pay-as-you-go service. Be it compute capacity or database or storage in cloud, we access them through the internet, and that too on a pay-as-you-go pricing model. Let's talk about how things were before AWS existed. Expedia, as we know as the people logistic company, or the company that helps people move around the world with ease, has a certain problem before they decided to migrate to AWS. And migrating to AWS was a solution to their problem. Back then, booking ticket was an unpleasant experience compared to what it is now. It generally would take a long time to book a ticket. And sometimes it would time out if there is a promotion or if a huge sale announced, and if the environment is not scaled up to meet the demand. And sometimes it would time out if there is a promotion or if a huge sale announced and they could not scale up the environment and keep up with the speed of the promotion. That's when they got introduced to AWS, and with the AWS power to increase the capacity of the environment on the fly, solved their scaling issue. Instead of waiting on the new hardware to arrive and wondering what to do with the hardware when the promotion is over, with AWS we can quickly scale up the environment when there is a need and scale down the environment during lull periods. Now, that being said, let's talk about what is AWS. Amazon Web Services, or in short AWS, is a secure cloud service platform offering compute power, database, content delivery, and other functionality that you would need to help your business scale and grow. AWS is a very secure cloud platform, and such security cannot be imagined in on-premises without spending a fortune. Almost any type of applications can be created and deployed in the cloud, which includes the latest IoT applications, machine learning, artificial intelligence, and so on. And the best part is we can avail this service from anywhere as long as we have an active internet. And all this is availed on pay-as-you-go subscription. Now let's talk about the benefits of AWS. AWS Cloud Platform is very easy to use. One needs no complicated programming or compute knowledge to access and use this environment. Even with less programming and compute knowledge, one could become a pro in accessing and maintaining the cloud. The products and services offered are very flexible in nature, and that provides room for us to easily integrate the service to other services in AWS and services outside AWS. Cloud in general is a very reliable service, and AWS in specific is very reliable. Cloud in general is very reliable, and when we talk about AWS, it's very true. A statistic says that about 95% of the cloud computing in the whole world is run on AWS due to AWS reliable nature. The services in AWS are scalable by nature, and most of the services provide click button scaling. Services in AWS are very cost effective, and it becomes very true when you start using more. Services in AWS are very cost effective, and it becomes very true when you start using more services in AWS are very cost effective, and it becomes more true when we start using more, since when we start using more service, the per unit price drops down even further. Security in the cloud is at its highest with encryption and multi-factor authentications and being able to audit the logs. One can be sure that when one hosts a service in AWS, they are hosting it in an environment which has been built with enterprise security in mind. Alright, let's now talk briefly about the different products and services available in the cloud. Some of the products and services available in the cloud are compute, storage, database, migration services, networking and content delivery, developer tools and services available for managing the AWS environment, tools needed for machine learning development, analytic tools needed for security and identity compliance, tools needed for mobile application services, tools needed for IoT and gaming development are some of the products that are available in AWS. Alright, let's first talk about compute service. Now, compute service, it enables us to develop, deploy, run and scale our applications and workloads on the cloud. You might agree with me that compute service is the fundamental of any applications, and AWS provides many options to use those compute services in the cloud, starting from EC2, which is a VM in the cloud, to Lambda, which is serverless computing in the cloud, to compute service, Compute service also includes container services and services that help batch processing and deploying applications and load balancing the request when we run our applications on multiple servers, and services that help batch processing and developing applications and load balancing the request when we run our applications in multiple servers. We're going to talk about two compute products in specific. Let's talk about EC2. EC2 is a service with a resizable compute capacity in the cloud that allows business subscribers to run application programs in the computing environment. And the best part here is EC2 is resizable. Anytime there is more demand, I can simply resize my computer to meet the demand. On the other hand, Lambda is a serverless compute service used to execute backend codes. It really helps us to focus on the core competencies like application building the code. Let's talk about storage service for a while. AWS storage is known for its durability and availability, with S3 being the object storage for the internet, where users or application can directly upload and download the content from the internet, and EBS being a durable block storage that gets attached to the EC2 instance, and Glacier being the archival solution in the cloud, and Storage Gateway being the gateway for storing data locally and having a backup in the cloud in case of disaster. Let's talk about two important storage service products in the cloud, which is S3. Now, S3 is an web-based cloud storage service. It's designed for online backup and archiving of data. And the best part about S3 is that it provides 11.9 durability, which means once we store the data in S3, the chances of losing the data is nearly zero. EBS, on the other hand, provides persistent and resizable and migratable storage to the VMs or EC2s that we can run in the cloud. Now let's talk about the database offerings in the cloud, beginning with RDS for SQL and DynamoDB for NoSQL and ElastiCache for web caching services and Amazon Redshift for petabyte scale data warehousing services. AWS Database Service provides all the database service needs we might have. Let's talk about two database services in specific. RDS. RDS is an web service that is designed to simplify the setup, operation, and scaling of the relational database in the cloud. And DynamoDB is a fast and flexible NoSQL database service which is well known for its low latency and scalability performance. Network and Content Delivery Service contributes to the infrastructure as a service side of the cloud. It provides a secure cloud infrastructure and connects our physical network to our private virtual network with low latency and high transfer speeds. And under Networking and Content Delivery Services, VPC is Virtual Private Cloud Networking in the cloud. Route 53 is the DNS service in the cloud. And Direct Connect is a service that connects our on-premises with AWS environment through point-to-point cables. And CloudFront is Content Delivery Network or caching service throughout the world. Let's talk about VPC for a while. VPC, it enables us to launch AWS resources into a virtual network that we define in the cloud. VPC resembles very similar to our office network with subnets, firewalls, private zones, public or DMZ zones, and a lot more. We can also create a VPN connection between on-premises and cloud environment through this VPC. And Route 53, it is a scalable and highly available domain name system web service that helps to route the end users to the internet application. Now, AWS is a domain registrar as well, and here we can buy domain names for our organization and use them to mask the IP addresses behind it. And by the way, if you didn't know already, DNS is the one that translates human readable names like www.xyz.com into the numeric IP address. Let's talk about developer tool services. Now, developer tool services in Amazon provides services where developers can store an application source code and automatically build, test, and deploy applications on AWS, out of which AWS CodeStar enables us to quickly develop, build, and deploy applications in AWS. And Code Build is a fully managed build service that compiles source code, runs tests, and produces software packages that are ready to deploy. And Code Deploy, on the other hand, is a service that automates software developments to a variety of compute services, including Amazon EC2, Amazon Lambda, and even instances running on premises. An AWS Code Pipeline is a continuous integration and continuous delivery service for fast and reliable application and infrastructure updates. Let's talk about CodeStar. CodeStar is a service designed for developers where they can quickly deploy, build, and develop applications on AWS. AWS CodeStar provides a unified user interface enabling us to easily manage our software development activities in one place. With AWS CodeStar, we can set up our entire continuous delivery toolchain in minutes, allowing us to start releasing codes faster. And not only that, AWS CodeStar makes it easy for you or your whole team to work together securely, allowing you to easily manage access and add owners, contributors, and viewers to our project. And not only that, AWS CodeStar project comes with a project management dashboard, including an integrated issue tracking capabilities provided by Jira software. With the AWS CodeStar project dashboard, we can easily track progress across our entire software development process, from our backlog of work items to teams' recent code deployments, so on and so forth. AWS Code Build, on the other hand, is an cloud service that enables an IT developer to build and test code with continuous scaling. Now here, you pay only for the build time that you have used. Now, Code Build is a fully managed service that helps compiling source codes and run tests and produce software packages that are ready to deploy. With AWS Code Build, there is no need for us to provision, manage, and scale our own build servers. Code Build scales continuously and processes multiple builds concurrently. So our builds are not left waiting in the queue because it's processed concurrently. Let's talk about security, identity, and compliance services available in Amazon. In general, the security, identity, and compliance services in Amazon helps us to maintain a secure environment in Amazon by providing services for user authentication, for limiting the access to certain set of users on the AWS environment. Out of which IAM, or Identity and Access Management, it's a product that enables us to manage access to AWS services and resources, that enables us to manage access to AWS resources and services in a secure fashion. Using IAM, we can create and manage AWS users and groups and use permissions to allow and deny their access to AWS resources. On the other hand, KMS, or Key Management Service, is a managed service that makes it easy for us to create and control the encryption keys used to encrypt our data. And Cognito, it lets us to add user sign up, sign in, and access control to our web and mobile apps quickly and easily. And WAF, or Web Application Firewall, helps us to protect our web applications from common web exploits that could affect application availability, that could compromise security or consume excessive resources. And WAF, it gives us good control over which traffic to allow or block to our applications by sort of defining customizable web security rules. We can use WAF to create custom rules that block common attack patterns such as SQL injections or cross-site scripting, and we can also create rules that are designed for our specific application. Out of all the four, Identity and Access Management, it helps us to control access to AWS services and resources for our users. With the Identity and Access Management, I can restrict user access, or I can give a user complete access to the environment. If it's an admin, I can assign complete access, and if it is a user, I can provide some privileged access or less or degraded or no access depending on the role that the user plays in the organization. And KMS is a service that helps us to create and control the encryption keys used to encrypt the data. And also we can use hardware security model, HSM, to protect the security of our data in the cloud. Also, we can use hardware security model to protect the security of the key itself. And let's talk about the management tools and services available in Amazon. Management tools and services, it helps us to manage, monitor, and automate all the resources running in the AWS infrastructure, beginning with CloudWatch, a service which monitors the environment by receiving logs and creating a dashboard and sending alerts as needed, and CloudFormation, a service through which we can deploy new environments using just templates, and auto-scaling, a product that lets us to handle the dynamic traffic with ease by dynamically scaling up and scaling down the environment as needed. And CloudTrail is another product or another monitoring tool that helps us to monitor or collect the logs of all the API calls to our environment and provides a searchable tool based on keywords and timestamps. Let's talk about CloudWatch a bit more detail. Now, CloudWatch is a monitoring service for AWS. With CloudWatch, we can collect, we can track the metrics, we can collect and monitor log files. We can also enable CloudWatch to set alarms and automatically react to changes in the AWS environment. CloudWatch can also monitor AWS resources such as EC2 instances, DynamoDB tables, Amazon RDS instances, as well as custom metrics generated by your application and services and any log files your applications would generate. Now, we can use CloudWatch to get a system-wide visibility into resource utilization, application performance, and operational health. We can use these insights to react and keep your applications running smoothly. And CloudFormation, on the other hand, provides a common language for us to describe and provision all the infrastructure resources in our cloud environment. Now, CloudFormation allows us to set up and model all our AWS resources so that we can spend less time in managing those resources and more time on our application. Now, CloudFormation is really an infrastructure as a code service where I can build an infrastructure based on the portable template I might be carrying. Alright, in this demo session, we'll talk about how to install Jenkins on Amazon Linux EC2 instance. And before that, let's talk about what is Jenkins and what is the purpose of it, why it is used, and all that stuff. Now, what is Jenkins? Now, Jenkins is an open source automation server, and it provides a lot of inbuilt plugins for deploying and automating any project. In short, it's an continuous integration server, and it is used for many purposes. Used for tasks that take care of continuous deployment and delivery, and it provides these advantages like the developer now will not have to focus on fixing errors because errors are automatically handled by Jenkins, and because of that it leads to faster development environment. Alright, so how do we go about doing it? Let's get started. The first thing is to go to our console and launch an EC2 instance. Actually, let me walk you through the steps through the PPT and then I'll show it in the console. So let me first walk you through the steps in installing a Jenkins server. In this lab, we're going to launch an VM or a virtual application server to host our Jenkins installation, and then we are going to deploy Jenkins on top of it and then configure it as an build server. And for this, we will need an AWS account to begin with, and then a bit of experience in Jenkins, and then some familiarity on EC2 and how EC2 gets connected to VPC, stuff like that. So when we're all done, this is how the architect is going to look like. Users, they get connected to EC2 instance, which is a Jenkins server, and then there are slaves, build slaves that can be monitored, that can be used in deployment by the Jenkins server. So let's see how it is done. Alright, so let's first launch a server. Let it be an Amazon Linux instance. I'm going to pick T2 Micro because of the free eligibility, and because this is a lab, that should be more than enough. And I'm going to keep this as default. I'm going to stick with the default VPC, and I'm going to keep all the settings as defaults. And then I'm not going to add a storage. I'm going to keep the storage limited with the root volume. And then for security group, because we're going to access it through the internet, I would like port 80. In fact, since this is a lab environment and since I'll be tearing it down right after the lab is over, we're going to use all IP, or we're going to use anywhere, all traffic anywhere. View and launch. And I already have a key pair that I have created. If you're not familiar with creating key pair, launching EC2 instance, you might need to spend some time watching the AWS EC2 video. That would help. So I already have a key pair that's attached to this account in this region. So I'm using that key pair to launch the instance. Alright, and that's my Jenkins server. Alright, so once that is installed, let's log into it. Since this being an Linux instance, I'm going to use putty to log in, and then use the key pair that we have downloaded to log in. And the key pair was right here. Alright, now I'm connected to it. As first thing, we will have to install the Java environment. I'm going to show some commands towards the end. So if you're planning to do labs yourself, you can use those commands. They will be very handy. In fact, I can show it right now as we speak. So these commands are to install Java environment. And it has two versions as we speak, and I've chosen the latest version. So I've typed 2 and I've chosen the latest version in installing Java environment. The second is to install Apache Maven. Let me show you some commands that's used to install Apache Maven. And these commands vary from Linux version to Linux version. So if you're using a different Linux version, just be sure that you're using commands which are respective to that particular version. All right, let's install Apache Maven. Looks like some of them are already installed and it's throwing error for some, but anyway, it's considered an successful installation. And then let's install Jenkins. And the commands to install Jenkins is right here. So these are to install Jenkins and to download the software and install it, and then start the Jenkins and make sure the Jenkins stays running even after a reboot. So let's run these commands. Alright, now Jenkins should be ready, or the Jenkins server is installed in our EC2 instance and it is ready for us to access. And the default port is port 8080. So let me go to the URL or IP. Let me go to that and then try accessing it using port 8080. There you go. So at the moment it's locked. It requires admin password to log in, and the admin password is present in this particular folder and this particular file in the Linux instance. So let me get that. Okay, one moment. Looks like the admin password is not present. Just give me one quick moment. Okay, it's just a permission issue. Let me check the password in that folder again with the elevated permissions. There you go. There's my password. Alright, once we're logged in, we can install all the suggested plugins. Now that's going to take some time to run and install all the default plugins needed to run a Jenkins server. Alright, it's done. Now, as next thing, it's going to ask for the admin username and password. You can choose as an existing administrator, or you can also create another admin user. In this case, I'm going to create another admin user. Alright, so the Jenkins server is installed. We can use the similar but slightly different procedure on the Jenkins nodes or the slave servers to make them Jenkins slave and respond to the builds that we push, or receive the builds or receive the jobs that we push through this Jenkins server. So we have built this Jenkins server on Amazon EC2. A similar and slightly different procedures can be followed to build Jenkins build servers that can contact Jenkins server to receive jobs and start working. Thank you for watching. I believe you enjoyed the session. I'll meet you.
When we talk about networking in AWS, essentially we talk about how you can isolate your resources in the cloud. That's something that is a key concern or key requirement for all the organizations that are moving their workload to the cloud. How do I do that? And you can do it using VPC, the Virtual Private Cloud. We'll take a look at Virtual Private Cloud as well. Then you have something called Elastic Load Balancing, where you can say, I have many applications and I want you to do a load balancing for those applications. And AWS gives you out-of-the-box functionality, a managed service called ELB, Elastic Load Balancing, which will do just that. AWS also has something called Route 53. This is a fully managed, highly available cloud DNS service, and what it does is it basically acts like a phone directory. So you put your IP address and put your website address, and it converts that to the IP address and then brings you to your source, which could be the S3 bucket or your load balance or really anything. Let's go to console and then take a look at this thing. Right now, I am in EC2, and then I am at the load balancers. If I click on the load balancer, I can have two types of load balancer where I have an application load balancer. So think about this. If I am a retail website and I have something like apparel, I have sports, outdoors, all of these sections, and I have a social section as well on my website, and I want load for all these sections to be managed separately. And then what I can do, I can come over here and I can set up some target groups, and then I can distribute my load for all these sections of my website. So essentially, I want to change the load of my traffic, and I want to divert that traffic, and I can do that all from here. And this again is available for HTTP and HTTPS. If you want to do a load balancing at a network LAN like a TCP or SSL, then I'm going to choose the classic load balancer. VPC, or Virtual Private Cloud, again is a place where you can isolate your resources in cloud. This is one of the places where you can use a VPN connection to create an encrypted IPsec tunnel to talk between your data center and your resources and clouds. So your VPC can talk to your resources in your data center, and you can do that by using a customer gateway at your end, your data center end. Then use a virtual private gateway at your cloud end. There are firewalls that you can set up, which are called network access control lists. You have subnets, which is a logical grouping of your resources. So you would have resources who would talk to the internet. You would put that in your public subnet by using internet gateway attached to that. Or you can have subnets that would not be talking to the internet, but would be talking in. Compute is one of the foundation services of AWS. In fact, I was attending one of the trainings at AWS, and they told us that 73% of total revenue of AWS is through EC2. That's a server in the cloud, a compute in the cloud. So let's look at 4 offerings among many that compute gives us. So the first one is Lightsail. And there are people who love to build their servers, have their databases put on the firewall settings, and then install a lot of things. But then, on the other hand, there are people who simply want something out of the box, and they don't want to provision a server to do everything on end. And they want it for a monthly small price. For all those use cases, we have something called Lightsail, which is one of the newest services launched by AWS, and the plan starts at about $5 a month. And it involves the VM, the storage, the data transfer. You can access search it from the console, and you can have a static IP or DNS management right from the console, and you don't need to worry about it. We'll take a look at it in our demo section. Then we have EC2. So this is where you install any application that you would want. This is essentially the compute in the cloud where they have virtualized your services, and then you can access it anywhere from the world using the internet. They have multiple pricing options: on demand, on reserve, on the spot. So if you have your workload, which you know is going to run for a very long time, 1 year, 2 years, 3 years, you can go ahead, pay up front, reserve that thing, and get 75% off. They have something called Spot Option, where all of the unused capacity that AWS has for compute, they put it on auction. And then you can put your price over there, and then you can probably get close to 90% off. And then it is used for large workloads with huge, huge, huge capacity. If you want to run microservices, you know that is a native support for Docker in the cloud, then ECS is the service that does that. You don't have to install it. You can operate and scale your own cluster in the cloud, and it's all a managed service open to you. Now, let's say you are focused only on writing code. You are a developer, or you want your team to focus only on writing code. You do not want to worry about the infrastructure part of your application. then AWS Lambda is the service that is the function as a service. So you don't have to worry about the infrastructure at all. AWS simply tells you that you give me the code, you tell me how much memory you are going to need, and all I'm going to bill you for is the time your function is going to take to run in the cloud, and I think it's an amazing thing. If you've heard about the term serverless, this is what serverless is. So we are going to take a look at the demo of this service as well. So let's go back to console and see if we can take a look at EC2. So here I am on the EC2 console, and if you see here, this is my region, and I am in US East, not in Virginia region. Now we are at EC2 dashboard, and let's look at how we can launch an instance. Now before we start, let's take a look at the regions. So I am in US East Northern Virginian region, and these are all the regions that you can choose from. And this is where I'm going to launch my EC2 instance. The first thing that I'm going to do when I'm going to launch my instance on the server in cloud is choose an image, which is known as Amazon Machine Image, AMI. And this is nothing but the software package. So I'll go ahead and I'll choose the default option that I get over here. And you can see that it has the command line tools, Python, Ruby, Perl, Java, Docker, PHP, MySQL. So you could have anything that you want. And then I'll go ahead and I'll select this. Once I have selected this, I'm going to choose my instance type on hardware. And you can see that right now I have a T2.micro, which simply is 3-tier eligible. And the network performance is kind of low to moderate. But if I scroll down, you can see the network performance and everything else goes way up. And then I can go and have a different purpose, compute, memory, FPGA, the graphics, anything that I want. And this is the variety of services you get with AWS. Next step is to configure my install details so I could have one or more instances. This is my networking. So essentially, where do I want to put it? Do I want to put it in my network or the VPC that I have created? Or do you want it in another VPC? VPC is nothing but your isolated cloud, your network inside the cloud. Apart from that, I can put something called advanced details, which is nothing but boot up, JavaScript. So if you want something to run when your EC2 instance is provisioned, when it starts, this is where you are going to put that. So for the purpose of the demo, I'll keep it where it is and move on to the next step, which is storage. So essentially your hard drive. The root volume is nothing. It is the hard drive where your OS is installed, and then I can add any more hard drives that I want, and then I can change the size of it. If I want it to be encrypted, I can do that as well. So let's keep it simple and move to the next step, which is tags. Now, tags are used for identification purposes. Let's say you have many teams. There's a Java team, a darknet team, and you want to keep track of who is using all the resources. So this is where you can add tags that say name equals darknet team. And this is how you are going to identify who has launched this thing. Next up, we have security groups. These are instance level firewalls. So firewalls for your server. So typically, if you want to allow an SSH, if you want to allow an HTTPS access, this is where you are going to go to add the firewall rules. And you can put the source as anywhere, which means anyone from the internet can access this thing. Now, I do not want SSH access for everybody, so I just keep it HTTP and HTTPS. The SSH access will be essentially for my people that I want, and that's about it. I go and I'll say review and launch, and we can review all of the settings that we have here over here, and we will simply launch. And now it's going to ask for my keypad. This is now something that is required of me to SSH into this particular instance. And I'll simply say that, yes, I have access to this thing, and it will launch the instance. That's about it. It's as simple as that to launch your EC2 instance in cloud. And if I come on the dashboard, I can see that my instance is being provisioned, and I have all the information I need over here. Then, if I want more information, I can click over here, and I can get all of the information that I want over here. Moreover, I have these status checks. So there are two types of status checks that check the health of the instance. So it will make sure that everything, all of the AWS resources that are required to keep this resource up and running, are running fine. And it will also see if I have something that is not required in my instance. It is also there to make it up and running. Now that our instance is up and running, I can click on it and I can connect using the console. So I don't have to use a command prompt. I can click on the console itself and I can do whatever I want. On the other hand, if I take the IP address and if I go here, there it is. Out of the box, I see my WordPress site up and running. I don't have to do anything. It is right there for me to use, and I can just customize it any which way that I want. Let's see if I can have the SSH window open here, and I can just use the login credentials that I have. There it is. I can simply log into this and start playing around with it. I can also see all the metrics, I can see the networking, I can take a snapshot, I can do pretty much whatever I want. This is something that if you have your own virtual private server in the cloud with all the resources that you need, you can run your small applications on it, you can run your WordPress site on it, you can do so many things. There are so many use cases that you can use Lightsail for. It is one of the most popular compute services that was recently launched. Let's look at Lambda. So we come to compute and then we click on Lambda. This essentially functions as a service. You can see that I already have something that is already there, so let's create a Lambda function. We'll take something that is provided out of the box for us. You just click on this and then we click on an SNS message. So this is like the messaging service of AWS. Simple notification services. And we can enable trigger. The SNS topic is incident response, and let's click on it. Now you can see I can type my function name, so I'll simply say my Lambda function. And the language that I'm choosing, Edge Node.js. I can also have C#, Java, Python, etc. And this is my simple code. And then I have environment variables I can use. I will create a new role, and then I will name my new role my Lambda SNS role. I'll keep everything as it is, and that I would simply say go next. Then I'll create a function. Now, this function would be using some memory, and this function will take some amount of time to execute. That amount of time is what AWS is going to charge me for. I do not get charged for anything else. So here, my Lambda function is ready, and if I click on test, then I can simply say there it is, SNS. Say and test. And it should give me something that says hello from SNS. Let's look at this function, at the detail that we got. If you see here, that is the duration. So it ran for 2.84 milliseconds. And then the billing duration, or the build duration, is 100 milliseconds. The resources configure. So I said that I needed 128 MB of RAM to run this thing, and the maximum memory that I actually used, that this function actually used, was 90 megabytes. So that is all I need to do. I need to upload my code, and then I need to say how much memory I'm going to use, and it can be up to 512 MB. There's only one more limitation that says that our function should not run for more than 5 minutes. Essentially, a microservice would not necessarily run for 5 minutes. If it's running for more than 5 minutes, then it's probably the best idea to break it down into several more functions. We get billed by milliseconds, and the best part is in the first year, you get something like 1 billion milliseconds available in the first year. Go and test this thing. This is one of the most interesting things that you will find. As a developer, as an organization, you want your people to focus on the code. You know how easily you can push your code to production to the customers, and you don't want to worry about infrastructure. So this is one service that is really worth exploring. Let's take a closer look at Lightsail, the newest addition to Compute. Now, this is one of those things which will give you a complete package. It starts at less than $5 a month. So let's create an instance. And right now I am in the Mumbai region, and I can change my region. So let's put it into Virginia. We can pick up our instance image. If I want only OS operating system, I can do that. If I want apps and OS, I can do that as well. So I'll keep it to WordPress. I want to make a WordPress website on my server. I can add any script that I want to fire at the bootstrap. I can also have the SSH keypad that I will use to log in from the console for Lightsail. And then, depending on how many resources I need, I can choose my instance plan. And it goes all the way from $5 a month to $80 a month if I'm running some really heavy-duty application on it. But because I'm only running my WordPress website, I simply need the basic one. Then I am very good with 512 MB RAM, 1 CPU, and 1 terabyte of data transfer. Then I want to name my instance, and I'll keep it the way it is. And here I can change the quantity as well. If I click on it, then that's about it. That's about all I need to do to have my instance up and running. Right now, it is in a pending state. Now, this is something that is really good for the virtual private server. I don't have to worry about EC2 instance. I don't have to worry about security patches. I don't have to worry about the firewalls. It's all available to me in one small box. So all I do is come here, I click a few things, and Let's talk about databases in AWS. There are a host of options to store your data by using multiple database services in AWS. So quickly speaking, you have RDS, the relational database service that supports many engines. Then there's an offering from AWS that is known as Aurora. It is a fully managed MySQL compatible relational database service. Then you have a NoSQL service offered from AWS that is a fully managed service as well. It is called DynamoDB. We are going to take a look at that. Then you have Redshift. That is a petabyte level data warehousing service. Again, it is a fully managed service. Then you have Elasticache. That supports in-memory cache. Two very popular engines such as Memcached and Redis. Then you have a very cool service called Database Migration Service that basically allows you to migrate your database from Oracle to Aurora. You can use the service and then there is no downtime at all when you use this service. So let's take a look at RDS, DynamoDB, Elasticache, and Redshift. So once you're in AWS console, you can see that this is the RDS, and it is a management service, which essentially means that batch upgrade, operating systems installation are all taken care of by AWS. Then what we are responsible for is when we store our data, we have to provide permissions to set up the firewall settings and to allow access for everything. Then, of course, we are responsible for setting up the databases, but the engine is provided by AWS. Then if I click on this thing, let's say, for example, I want to fire my SQL instance, and if I click on this thing, I'll just show you how the high availability as well as the backup is taken care of by AWS. So I'll select my server, my hardware that's based on my workload, and then I can do something called multi-AZ deployment. When I do this, it basically asks if you want to have a master save configuration, a high availability configuration, and when I do that, then yes, I do get copies of my database in the multiple availability zones within the region. And these are synchronized, replicated copies, so in the event of failure, I will automatically be switched on to the other availability zone that has the same copy of my database. So let's quickly add the DB identifier and the username and password. So I'll just call it MySQL for the sake of simplicity. Let me just copy and paste all these. Okay, it doesn't like that. Okay, so it doesn't like my SQL database. And let us copy it all over. And then let's go to the next step. Now, when we go to advanced settings, I'll show you that they have something called backup. And then this backup is automatically provisioned by AWS. And you can see here that there is a maintenance window as well. If I want, I can give a window, then this is where you should take my backup, and the same thing for the maintenance. Now, these are all the things that are taken care of by AWS. And in a traditional environment, we have to do all these things ourselves. So this is the beauty of using AWS, that we don't have to worry about the patches. We don't have to worry about the backup. We don't have to worry about the high availability. It's just configured, and all we have to do is set some security rules, some firewall rules, and some accessibility rules for the users. Coming back to the NoSQL offering of AWS. So this is Amazon DynamoDB. Again, it is a very fast and flexible NoSQL database. So for all of your IoT platforms, for your mobile, for your gaming, this is the AWS service that you are going to use because it is a schemaless database, essentially, where you can have a keypad value and you don't have to worry about whether I'm going to store one value or do I have to store values in all columns as well. It deals in something called read capacity unit and write capacity unit for your read requirement and for your write requirement, and that's how it works. You don't have to worry about the provisioning of resources. It scales automatically. Redshift is a petabyte scale data warehousing solution. And again, it is a managed service, so you don't have to worry about, the OS level or the patches. The same thing goes with Elasticache as well. It supports the very popular Memcache and Redis engines. And it is a fully managed service, so you don't have to worry about management or scaling of all of the memory in these engines. Now, let's look at storage services that AWS offers. Now, storage makes up a very big part of the services that AWS offers in the cloud. They are heavily used by multiple organizations, individuals, consumers around the world. So let's go and look at a few things. So EBS is essentially your block storage, your hard drives. They are low latency, and all of your web servers and your database servers, your analytics engines, they all use EBS, Elastic Block Storage. Let's say you have a requirement to have shared file storage. That is where you are going to use Elastic File Storage. And again, it provides high fault tolerance with consistent latencies, and you pay only for what you use, so you do not have to pre-provision it. Just in the case of EBS, you need to pre-provision it. Then you have S3, a simple storage service and one of the most popular services of AWS, launched way back in 2006. It is secure, it has 11.9's durability, and it scales past tens of trillions of objects, and it has many, many use cases. Most importantly, for storage, backup, and recovery. Tiered archiver, we're going to look at a demo of that thing, and it also acts like a data link for big data analytics. Now, if we have something called cold data that we want to keep for our audit records or some archival records, AWS has something called Glacier that is very, very economical archival service. The rates start as low as like 4 cents a gigabyte, which is very, very cheap. You also have something called Storage Gateway, where you apply this virtual device to your data center, and then you can store all data through this storage gateway in the cloud. This is one of the very popular services in the hybrid environment, where you want to keep some data in the cloud and some data in your data center. There are a host of data transfer services which help you move your data to cloud, and it can go from a small amount of data that you can transfer over the internet to exabytes of data that you can transfer through truck to AWS storage services. So you have something called Data Connect, where you connect directly to AWS regional data transfer. You bypass the internet, and then your network is connected. Then you have something called Snowball, which is like a box where you migrate petabytes of data in batches to the cloud. Then you have something called Snowmobile, where you migrate exabytes of data in batches to the cloud. And they will simply send a truck to your data center, you plug it in, the truck will roll into AWS data center, and then they will put data anywhere you want. So let's also take a look at Kinesis Firehose as well. So you have these Kinesis streams, and you have ingestion process, streaming data, your IoT data, your mobile data, your Twitter feed, the clickstream data. These are the things you can use Kinesis to store and process all of that data. This is where you would come in AWS services, AWS console to request Snowball. These are all the things that AWS gives you to transfer your data. Again, your data is secure, it's encrypted, it's addressed in transit, and you can access it anywhere using the internet. Let's look at S3 in AWS Management Console. S3 is a place which is used for data leaks, for any sort of data that you would want to upload in cloud. I can very easily go and I can create a bucket, so let's create a bucket. Bucket is where you are going to store your data. All right, so I have created Albert Simplilearn Lab Bucket, and if I click on it, I can do so many things over here. I can upload any data that I want over here. I can send the permissions of who all can access this data by default. In AWS, it's a shared responsibility model. So I can upload the data and I can choose who can access this data in S3. There are so many things that I can do with this bucket. That is my folder in the cloud, S3. That is Simple Storage Service. I can enable versioning, so I can keep all the versions of my objects over here. I can set up logging. I can set up a static website hosting. We will have a demo for this static website hosting as well, but we don't have to worry about this killing the load balancing, etc. It just scales automatically. I did mention that it's a great tool for disaster recovery, and what you can do is you can set up your backups, your snapshots in S3. You can put all your data in S3. You can simply enable the cross-region replication. So what happens is that, let's say you are in US East 1 or Northern Virginia region, and you want to set the cross-region replication to Oregon or maybe somewhere in Europe. You can just come over here and you can enable the cross-region replications. So what happens is AWS will automatically replicate your data from one region to another of your choice. You decide where you want your data to be replicated. AWS will not do so on its own. There are so many types of things that you can do. You can tag everything. You can give permissions to all your people. There are so many types of permissions that you can give. There is an access control list. You can set up a bucket policy. It's also tightly integrated with identity and access management, so you can very easily command who is able to access your bucket. Apart from that, there are some really interesting things. There is something called lifecycle. Now, this is a tiered storage. So normally, whenever you get data, typically that data is going to be very hot. So you would define the data or classify the data as a hot data, warm data, or cold, depending on how frequently it is accessed. Then you would normally have a tiered storage. So S3 has 4 classes. That's standard storage, and infrequent access storage, reduced redundancy storage, where you would put normally reproducible data, and archival storage, that is Glacier. So what you normally do whenever you get some data, you would keep it in a standard, and you would know over a period of time you would want to move that into an infrequent storage, like over here. So I will say that move this data into infrequent storage, which offers the same security, same durability, but it's a lot cheaper. Okay, and then after that, I can also add a data that I want to move into archive, which is Glacier, after some time. So we can add it to Glacier after 60 days, and if I just click on Next, this is where I will see it. And then I can also delete that object after whatever the amount of time that I would want, and I click on it. You see here that I have set up a transition rule that says that for the current version of the object, anything that I add to this S3 bucket, I want to transition all those objects automatically to standard infrequent access class. And then I will be charged lesser than what I've been charged now. And then I also want to transition to Amazon Glacier. That is my archival service after 60 days. I do not want to delete them ever. So these are the things that you can do with the S3. You also have a lot of analytics tools, which allow you to see who is accessing your data, what data you have, who is adding a lot of data, and these are all available to you at a very economical rate. All these services are tightly integrated with each other, so you can plug them in with an EC2 instance or IAM, and you can get all the information at your fingertips. So let's talk about static website hosting on S3. And this is one of the very, very powerful features of S3, where we can actually host a website. And it's static and some part dynamic as well. So you do not need a web server to host your website. I have this bucket over here, AWS Agile.n. I click on it, and you can see that I have a couple of HTML pages, error.html and index.html, and then my code. My HTML, CSS files, my image, my video files are inside the folder. So I come over here, I click on the properties, and you can see that the bucket hosting is enabled. So if I click on it, all I need is 2 documents, then whatever I want inside my website. If I simply click on this thing, this is what I get. Now, these are the things that I have inside my website, my folder, and the beauty of it is that you do not need any web servers. You do not need any load balancer. You don't need any firewalls. You can simply give this URL, and then you can map it to your DNS, the domain name service, and then anybody will type your website name or your blog name, and then they are going to land on this page. And it's scalable, it is load balanced, and you can scale it to any number of people. You can have millions of hits coming in, and this is one of the very, very, very popular services.
Let's look at AWS Marketplace. AWS Marketplace is an online store where you can buy software that runs on Amazon Web Services. We've gone through a lot of services, and you must be wondering, where do I get help? Where do I buy some software that integrates with all these services? AWS Marketplace is the buying and selling platform where you can either buy or sell software that integrate with AWS services. They are open source, commercial, these are for businesses, enterprises, and they're also for developers. And they are available in a range of categories, such as OS, security, networking, storage, business intelligence, DevOps, databases, monitoring, logging, etc. So, let's take a look at AWS Marketplace.
So once you come over here, you can see that you will have something called AMI. That is a machine image. And you can also have something for software as a service. Let's look at the DevOps. Most of these are offered as a free trial as well. And if you want to see just the free versions, you can click on the pricing plan, and then you can see that you get these images of software, of Amazon Machine Image, the AMI. And you can just install it on your hardware that you provision from AWS. And that is how you start using these things. And as you can see here, there are a lot of developers' tools, infrastructure, business software. If you want to make some dashboards, if you want to run some analytics, you can do many of those things and more right over here. So come over here, explore the things you want to do, whether it's security, databases, networking, or anything else.
In the topic, How to Design Cloud Services, we will take a look at the AWS Well-Architected Framework. And we'll take a deeper look at the 4 pillars which make up the framework. And these are security, reliability, performance efficiency, and cost optimization. We'll then take a look at where you can find more information about designing cloud services for Amazon. And we will look at the AWS Quick Start reference deployments, and where you can find out real-life examples about how real businesses are using Amazon Web Services. So let's start by looking at the AWS Well-Architected Framework. Now this was introduced because building cloud infrastructure services is vastly different to what you're used to with on-premise infrastructure. So AWS created this framework to help you understand the pros and cons of decisions you make while building systems on AWS. The AWS framework documents a set of foundation questions that allow you to understand if a specific architecture aligns well with cloud best practices. And there's 5 principles it helps you with. The first of which is stop guessing your capacity needs, test systems at production scale, lower the risk of architecture change, automate to make architecture experimentation easier, and allow for evolutionary architectures. And we'll take a look at each of these in greater detail. So firstly, let's take a look at stop guessing your capacity needs. Now, imagine you're designing a brand new application for your business. All the infrastructure decisions you will make are made using estimates, which are basically guesses. If you overestimate, you might end up buying too much hardware and have a fleet of expensive idle resources. Conversely, you might underestimate and have to deal with the performance implications of limited capacity. With cloud computing, these problems go away, as AWS helps you eliminate the guesswork in your infrastructure capacity needs. You can use as much or as little capacity as you need and scale up and down automatically depending on your demand. The cloud allows you to test systems at production scale. Traditionally, in a non-cloud environment, it's usually very difficult to fully test new products or services in development
as it's cost prohibitive to have like-for-like environments, or you just don't have the resources available. Personally, I've lost count how many projects I've worked on when things have gone wrong as soon as the product's gone live due to insufficient testing. With the cloud, you can duplicate environments on demand, and when you've completed your testing, just shut them down, and you only have to pay for the time the test environment was up and running, so you can test fully before you go live in production. AWS allows you to lower the risk of architecture change, as you can automate the creation of test environments. So you can emulate your production configurations and carry out testing against comparable environments. You can also remove testing bottlenecks where various teams are lining up to use your test environments. As with AWS, you can cheaply spin up as many test environments as you need and ensure that all the production changes have been sufficiently tested. You can automate to make architecture experimentation easier. If you need to make a change to production but not sure what the impact will be, well, you can automate the creation and replication of your systems at low cost and low effort to test these changes. You can then audit the impact, and then, if necessary, you can revert the changes and try again. With AWS, you can allow for evolutionary architectures. In a traditional environment, architecture decisions are often implemented as a static, one-time event that you have to live with during the lifetime of a system. But with the cloud, the capability exists to automate and test on demand to lower the risk of design changes. So you can implement new innovations and features easily. What this means is you aren't stuck with last year's technology, and you can implement new technology as soon as it comes out. As mentioned earlier, the well-architected framework is based on 4 pillars: security, reliability, performance efficiency, and cost optimization. So in the coming slides, we're going to take a further look at these 4 pillars, starting with security. So Amazon defines security as the ability to protect information, systems, and assets while delivering businesses value through risk assessments and mitigation strategies. What this means is you can apply security at all layers. So rather than just running minimal security, like firewalls, at the edge of your infrastructure, you can use firewalls and other security controls on all of your resources. For example, security groups on EC2 instances allow you to define who and what can access that specific resource, rather than just defining it at a global infrastructure level. You can enable traceability, so you can log and audit all changes to your environment. You can automate responses to security events, so you can monitor and automatically trigger alerts depending on your needs. You can focus on sharing your system. The AWS Shared Responsibility model allows you to focus on securing your application, data, and operating systems, whilst AWS secures your infrastructure and services. And you can automate security best practices. AWS allows you to create and save a custom baseline image of a virtual server, and then you can use that image to automatically launch new servers. This way you can ensure that all new resources adhere to your security standards. So I just briefly mentioned the AWS Shared Responsibility model. Now we take a look at this in more depth in a later lesson. But what it means is that the AWS Shared Responsibility model allows AWS customers to focus on using services to accomplish their security and compliance goals, because AWS physically secures the infrastructure that supports your cloud services. So if you look at this diagram, you can see it split into 2. Security measures that the cloud service provider implements and operates is the security of the cloud, and that's the responsibility of AWS. Then there's the security measures that the customer implements and operates, and this is related to the security of customer content and applications that make use of the AWS services. And this is security in the cloud, and this is the responsibility of you. So let's take a look at security in the cloud. And this is composed of 4 areas: data protection, privilege management, infrastructure protection, and detective controls. Let's start with data protection. Before architecting any system, practices that ensure security should be in place. With data protection, these are categorizing data based on levels of sensitivity, granting least privilege while still allowing users to perform their work, and encryption to protect your sensitive data. If you're storing customer credit card data, obviously this needs to be categorized as sensitive and it needs to be encrypted. But log files from a daily maintenance task wouldn't need this level of security. Now there's a number of tools AWS offers to assist you with this. AWS makes it easy to encrypt data and manage keys and key rotation using IAM and Key Management Service. You can perform detailed logging using CloudTrail. And AWS offers resilient storage systems like Amazon S3, which has 11 nines of durability. Now 11 nines of durability means that if you store 10,000 objects with Amazon S3, on average, you can expect to incur a loss of a single object once every 10 million years. So in other words, you're not going to lose many files. And finally, AWS offers versioning and lifecycle management, again with S3, so you can protect against accidental deletes or file overwrites. Now, a central part of any information security program is privilege management, so that you can ensure that only authorized and authenticated users are able to access your resources, and that they can only access them in a way that is acceptable. For example, if a user needs access to a resource, don't just give them admin or read-write permissions by default, because they might actually only need read-only access. Now, to control your privilege management, you need to have a few things in place. The first of which is an access control list. And this is a document that needs to be maintained which lists access permissions attached to an object. So if you have some particular documents, you need to define what access is allowed to it. Then you have role-based access controls, and this defines the permissions for a particular end user's role or function. So an administrator would obviously need administrator access to various resources, but a regular end user might only need read-only access. So you need to define which roles have which permissions. Then there's password management, and this includes complexity requirements and change intervals. So you define how often people need to change their passwords and how complex they need to be. Now Amazon helps you with all this with the Identity and Access Management, or IAM, service. And this is the primary service used to control access to AWS services and resources. We cover IAM in huge detail in a later lesson, but briefly, it allows you to apply granular policies which assign permissions to users, groups, roles, or resources. And you can also control the password strength using this, as well as federation with your existing directory services, such as Microsoft Active Directory. You also need to protect your infrastructure, and to do this it's recommended to have multiple layers of defense and also multi-factor authentication to meet best practices with industry or regulatory obligations. Now, Amazon allows you to do this by implementing stateful or stateless packet inspection, either using AWS native technologies or by using partner products and services available through the AWS Marketplace. Amazon Virtual Cloud, VPC, enforces boundary protection and monitoring points of ingress and egress, and then there's CloudTrail and CloudWatch, which provides comprehensive logging, monitoring, and alerting. You should always have detective controls in place so you can detect or identify security breaches. This needs to happen so you can provide both a quality support process and meet compliance obligation. And by a quality support process, I mean one in which when you have a problem, you're committed to finding out the root cause and actually resolving the issue rather than just saying, oh, we think it was that. Let's hope it doesn't happen again. I mean, I know I've worked for some places like that, and it's certainly not a quality support process. AWS helps you with your detective controls by providing these services. AWS CloudTrail is a service that logs API calls, so you can find out the identity of callers, the time of calls, source IP addresses, and things like that, so you can find out who is doing what and when. Amazon CloudWatch is a monitoring service for AWS resources, so you can log EC2 CPU usage or network activity, and you can use CloudWatch with many different services like RDS, EBS, and more. You can also set up alarms, so you can be notified when certain things happen. AWS Config is an inventory and configuration history service that provides information about the configurations and changes in infrastructure over time. With Amazon S3, you can see data access auditing. So you can find out who's been accessing your S3 data and when they did it and when. And Amazon Glacier, you can use the Vault Lock feature to preserve mission-critical data with compliance controls that are designed to be auditable for long-term retention. The next pillar is reliability, and Amazon defines this as the ability of a system to recover from infrastructure or service failures, dynamically acquire computing resources to meet demand, and mitigate disruptions such as misconfigurations or transient network issues. With reliability in the cloud, there's a number of things to look at. Firstly, you can test recovery procedures. Cloud infrastructure means you can test how your system fails, and you can validate your recovery strategy. Places I've worked at in the past, disaster recovery was a big event. It was only done annually, it took months of preparation, it involved working a whole weekend and then some, and was also incredibly disruptive to the business. Imagine being able to duplicate your production environment and test failure and failover whenever you want. You can automatically recover from failure with the cloud. Monitoring a system for a key performance indicator, or KPI, you can automatically trigger automated recovery processes when a threshold is breached. You can scale horizontally to increase aggregate system availability. Using multiple small resources instead of one large resource will reduce your single points of failure. And also, you can stop guessing capacity. Gone are the days of using lack of memory or not enough CPU as a failure for a resource. With the cloud, you can scale as and when you need to, so you can't blame badly estimated capacity as the reason for reliability issues. Now, reliability in the cloud is composed of three areas. These are foundations, change management, and failure management. To achieve reliability, a system must have a well-planned foundation and monitoring in place, plus systems for handling changes in demand or requirements is also required. In an ideal world, your system would be designed to detect failure and automatically heal itself. Before architecting any system, you should have foundations in place so that your reliability is not impacted. You should have sufficient network bandwidth to your data center. You should have sufficient compute capacity. Your staff should be trained in the areas they need to be, and you should have support contracts with your vendors. With AWS, network bandwidth and compute capacity is already taken care of. AWS also offers a range of support contracts to help you with issues and a range of training courses for your staff. Change management is a critical part. Being aware of how a change affects the system allows you to plan proactively, and monitoring allows you to quickly identify trends that could lead to capacity issues or SLA breaches. With AWS, you can monitor the behavior of a system and automate the response to KPIs. For example, you can add additional servers as a system gains more users. So you can control who has permissions to make system changes and audit the history of these changes. Unfortunately, it's a given that failures will occur, so you need to have some failure management in place. It's good practice to understand why things failed so you can prevent it from happening again. No one wants to work for a company that, when things go wrong, they just get it working again with no understanding of why. A key to managing failure is frequent and automated testing of systems to failure and through recovery. Ideally, you do this on a regular schedule and also after you've made significant system changes. Now, Amazon allows you to do this with a few products. Firstly, AWS CloudFormation. This allows you to launch temporary copies of whole systems at very low cost, so you can use automated testing to verify your recovery processes. You can use CloudWatch to set up automation to react to monitoring data that indicates a failure. And you can store all your data on Amazon S3 buckets for future use. The next pillar is performance efficiency, and Amazon defines this as the ability to use computing resources efficiently to meet system requirements and to maintain that efficiency as demand changes and technologies evolve. So what does this mean? Well, performance efficiency in the cloud means you can democratize advanced technologies. AWS provides products such as NoSQL or media transcoding or even machine learning as a service. So rather than your IT team having to learn how to host and run these new technologies, AWS does it for you. You can go global in minutes. AWS allows you to easily deploy your systems in multiple regions around the world with just a few clicks of your mouse, so this leads to lower latency for your customers. You can use serverless architectures in the cloud, which remove the need for you to run and maintain servers to carry out traditional compute activities. For example, storage services can act as static websites, which remove the need for web servers. And you can also use serverless technologies such as Lambda or Elastic Beanstalk. And you can also experiment more often. With virtual and automatable resources, you can quickly carry out comparative testing using different types of instances, storage, or configuration. So performance efficiency in the cloud is composed of 4 areas: compute, storage, database, and something called space-time trade-off. And let's take a look at each of these. With the cloud, finding the optimal server configuration for a product will vary based on application design, usage patterns, and configuration settings. Traditional IT infrastructure requires making estimates in advance, which can lead to incorrect server configurations and lower performance efficiency. AWS is virtualized, so you can quickly change the EC2 server configuration to increase its performance efficiency. It may be optimal to run serverless computing. For example, AWS Lambda allows you to execute code without running an instance, and Elastic Beanstalk allows you to run web applications in a similar manner. From an operational standpoint, you should have monitoring in place to notify you of any degradation in performance. The optimal storage solution for a particular system will vary based on whether you need block, file, or object storage, the type of throughput required, frequency of access, and availability and durability constraints. Well-architected systems use multiple storage solutions and enable different features to improve performance. In AWS, storage is virtualized and is available in a number of different types. This makes it easier to match your storage methods more closely with your needs, and also offers storage options that are not easily achievable with on-premise infrastructure. For example, Amazon S3 is designed for 11 nines durability and provides a variety of storage classes for your different data categories, like Glacier for archived data. EBS and EFS offer numerous options for your EC2 instances based on the level of performance you require from your storage. The optimal database solution for a particular system can vary based on requirements for consistency, availability, partition tolerance, and latency. Many systems use different database solutions for various subsystems and enable different features to improve performance. Selecting the wrong database solution and features for a system can lead to much lower performance efficiency. Now, for database usage, you need to be able to monitor them, test them, and also you need to have some database platform knowledge. But Amazon makes this much easier for you, as it provides a suite of Amazon relational database services, which are fully managed relational databases. For example, Amazon DynamoDB is a fully managed NoSQL database that provides single-digit millisecond latency at any scale. Amazon Redshift is a managed petabyte-scale data warehouse that allows you to change the number or type of nodes as your performance or capacity needs change. You can also make use of Aurora or AMIs, where you install your own databases from templates. So what is the space-time trade-off? Well, you can think of space as memory or storage, and you can think of time as the processing time or the compute time to complete a task. So when you're architecting solutions, there's always a series of trade-offs, where it might be better to have more memory or storage to reduce the processing time, or maybe you're happy to sacrifice the processing time in order to reduce your memory or storage requirements. AWS gives you the option to maximize one or the other. For example, you could launch your systems globally, so you're increasing space and memory, so that they're closer to the end users in order to reduce latency, or the time. But whatever resource you use, you need to have monitoring in place to notify you of any degradation in performance. And the final pillar of the well-architected framework is cost optimization. This is defined as the ability to avoid or eliminate unneeded cost or suboptimal resources. AWS Cloud has a number of ways you can provide cost optimization. Firstly, you can transparently attribute expenditure, as the cloud makes it easy to identify the costs of a system and attribute IT costs of individual business owners, so those owners will have an incentive to optimize their resources and reduce costs. You can use managed services to remove the operational burden of maintaining servers for tasks such as sending email or managing databases. You can trade capital expense for operating expense. Instead of investing heavily in data centers and servers before you know how you're going to use them, with AWS, you pay only for the computing resources you consume when you consume them. Also, AWS allows you to achieve higher economies of scale because they can buy way more servers and hardware than you could ever imagine, so it's much cheaper to use their hardware than buy your own. You should also stop spending money on data center operations. AWS has the heavy lifting of racking, stacking and powering servers, so you can focus on your customers and business projects rather than on your IT infrastructure. Cost optimization in the cloud is composed of 4 areas: match supply and demand, cost-effective resources, expenditure awareness, and optimizing over time. Matching supply to demand will deliver the lowest costs for a system, but you'll need to be able to provide sufficient extra capacity to cope with demand and failures. In AWS, you can automatically provision resources to match demand. Auto-scaling, time-based and event-driven and queue-based approaches allow you to add and remove resources as needed. Monitoring tools and regular benchmarking can help you achieve much greater utilization of your resources. Using the appropriate instances and resources for your system is key to cost savings. For example, a reporting process might take 5 hours to run on a smaller server, but a larger server that is twice as expensive might be able to do it in just 1 hour. Both jobs give you the same outcome, but the smaller server will incur more costs over time. But to be able to find out these things, you need to have monitoring of expenditure in place and also regular benchmarking. AWS helps you with this. AWS Trusted Advisor goes through your resources and tells you where you can make savings. You can use on-demand instances, so you only pay for compute capacity by the hour with no minimum commitments required. Or you could use reserved instances, which allow you to reserve capacity and offer savings of up to 75% off on-demand pricing. And with spot instances, you can bid on unused EC2 capacity at significant discounts. You can also take advantage of managed AWS services, such as RDS or DynamoDB, which can also lower your costs. AWS and its virtually unlimited on-demand capacity requires a new way of thinking about expenditures. So you need to have a different way of budgeting, and you need to understand your business unit's usage. To do this, you can use cost allocation tags to categorize and track your AWS costs for AWS resources, such as EC2 or Amazon S3. And AWS generates a cost allocation report with your usage and costs aggregated by your tags. So you can set up tags for each of your business categories and units. This increased visibility of costs makes it easier to identify resources or projects that are no longer generating value and should be decommissioned. Billing alerts can be set up to notify you of predicted overspend, and the AWS Simple Monthly Calculator allows you to calculate data transfer costs. And you can set up SNS alerts so you can be notified when certain resources or cost breaches occur. Optimizing over time is an important strategy to reduce your costs associated with your cloud environment. AWS is always releasing new products and services. As such, you need to reassess your existing setup to see if it's the most cost-effective. For example, rather than running a database on an EC2 instance, it might be cheaper to run an Amazon RDS database. Or Lambda might be more cost-effective than EC2. But where do you find out more information about these new products and services from Amazon? Well, the first place to look for any new architecture guide is the AWS Architecture Center. This is a resource that provides you with the guidance and application architecture best practices to build highly scalable and reliable applications in the cloud. Here you'll find the AWS Reference Architectures. The AWS Reference Architecture datasheets provide architectural guidance to help you build an application on the AWS cloud, you'll find datasheets that include a description of how each service is used, plus visual representations of the application architecture. For example, web application hosting, or large-scale processing and huge datasets, or even building elastic web front ends for an e-commerce website. AWS white papers provide a comprehensive list of technical AWS white papers that cover all Amazon-related topics, such as architecture, security, and economics. There are new white papers being released all the time and are written by some of the most knowledgeable AWS people around. AWS Quick Start reference deployments use AWS CloudFormation templates to rapidly deploy a fully functional environment for a variety of enterprise software applications. Supplementary deployment guides describe the architecture and implementation in detail. In this course, we'll deploy things manually, step by step, so you can see how it works. But with CloudFormation templates, you can do several hours work with just the click of a button. Examples of CloudFormation templates are SharePoint, RD Gateway, or even SQL Server on Windows Server failover clusters. And finally, case studies. AWS maintains a large list of case studies and success stories from their clients. You can check to see how some of the largest and most successful companies on the planet use AWS for their business. You'll learn how the AWS well-architected framework is used in planning and designing. We'll take a look at scaling and all the different versions. We'll look at the importance of loose coupling, how you can build redundancy into your cloud infrastructure, how you can save money by cost optimization. We'll look at automation and how it can make management of an IT environment easier. And also we'll take a look at security and how you can secure your cloud resources. So let's start with scalability. In the past, you would have to estimate the peak load of your systems and purchase your hardware accordingly. So perhaps you were setting up a new website and you were estimating that you were going to get 1 million people per month hitting your website. So you buy the hardware accordingly. But then you find out that only 50,000 people are hitting it, or 10 million people are hitting it. So your hardware is inappropriate for the work. Cloud computing provides virtually unlimited on-demand capacity, so you can scale whenever you need to. To do this, your designs need to be able to seamlessly take advantage of these resources. And there are two ways to scale, vertically and horizontally. Vertical scaling means increasing the specifications of an individual resource. For example, increasing the memory or the number of CPUs on a server. With AWS, this is easily achieved with a restart of your virtual server, so that it resizes to a larger or smaller instance type. The advantage of this approach is that it's very easy and requires little thought in the short term. However, this type of scaling can eventually hit a limit and sometimes be cost inefficient, especially if you scale up to some very, very large instances. Horizontal scaling means increasing the number of resources rather than the specifications of each individual resource. For example, adding additional web servers to help spread the load of traffic hitting your application. This is a great way to build applications that leverage the elasticity of cloud computing. However, not all architectures can distribute their workload to multiple resources. A stateless application is one that needs no knowledge of previous interaction and stores no session information. An example of this would be a web server that provides the same web page to any end user. A stateless application can scale horizontally as any request from any end user can be serviced by any of the available compute resources. You can add more resources as required and then remove them when the capacity is no longer available. Stateless applications do not need to be aware of their peers. All that is required is a way to distribute the end user sessions to them. And there are two ways to distribute load to multiple nodes. The first of these is the push model. A load balancer, such as the AWS Elastic Load Balancer, is a popular way to distribute a workload across multiple resources. An alternative, but less recommended approach, is to implement a DNS round robin using Amazon Route 53, where DNS responses return an IP address from a list of valid hosts in a round robin fashion. This is an easy to set up option, but it can cause issues if DNS records are cached. The alternative to the push model is the pull model. Tasks that need to be performed can be stored as messages in a queue, and multiple compute resources can pull and process the messages in a distributed fashion. Examples of this are big data processing scenarios, where many servers work to analyze data and return results, or media file conversion processes, where multiple servers convert the files as they arrive. Amazon SQS or Amazon Kinesis are services that can provide pull model load balancing. Most applications need to maintain some kind of state information. For example, an automated multi-step process will also need to track previous activity to decide what its next action should be. You can make components in your architecture stateless by not storing anything on the local file system, and instead storing user or session-based information in a database, like DynamoDB or MySQL, or on shared storage, like Amazon S3 or EFS. Additionally, Amazon SWF can be used to centrally store execution history and make your workload stateless. So the opposite of stateless applications are stateful applications, as it's not possible to turn some layers of your architecture into stateless components. For example, databases, which are stateful by definition, or applications that were designed to run on a single server. Providing multiple users a consistent view of the database or application is much simpler when your components are not distributed. Distributing the load is possible, though, through session affinity. This means that all transactions of a session are bound to a specific compute resource. However, this means that existing sessions would not be able to utilize newly introduced compute nodes. And also, if a node is shut down or becomes unavailable, users bound to that session will be disconnected. For situations when you need to process large amounts of data, it's always beneficial to see if a distributed processing approach can be used. Imagine a task that requires a huge amount of data processing. If it was to run on a single compute resource, it would max out the resources and take a long time to complete. If you can divide the task into smaller fragments of work, then each of the tasks can be executed across a larger set of compute resources. Examples of this are the AWS Elastic MapReduce service, which allows you to run Hadoop workloads across multiple EC2 instances, or Amazon Kinesis allows you to run multiple shards of data on EC2 or Lambda resources for real-time processing of streaming data. The concept of disposable resources is completely new with cloud computing, as cloud computing completely changes the mindset of an IT infrastructure environment. Traditional environments involve purchasing hardware up front and required manual configuration of the software, network, etc. Whereas with cloud computing, all infrastructure is temporary or disposable. You can launch new instances when you need them and get rid of them when you are done. Automate compute resource initiation is a way to speed up the creation of new environments. AWS has plenty of features to make new environment creation an automated and repeatable process, and there's 3 options available which we'll look at in the coming slides: bootstrapping, golden images, and a hybrid approach. Bootstrapping means you can take a newly launched AWS resource with its default configuration and then execute automated scripts to install software or copy data to bring that resource to a required state. So you could launch an EC2 instance and copy data on so that it becomes a web server. Scripts can be parameterized so that different environments, production or development, can be initiated easily. With AWS, bootstrapping can be achieved with your own scripts, Chef or Puppet, ops work, lifecycle events, or CloudFormation. Golden images mean you take snapshots of your EC2 instances or RDS instances or even EBS volumes, and they can be used to launch new instances. These EC2 instances can also be customized and saved as AMIs, Amazon Machine Images, and then you can launch as many instances as you want from this template. If you have an on-premise virtualized environment, you can also use AWS VM import-export to create your own AWS AMIs. The hybrid approach makes use of both bootstrapping and golden images. You can launch new instances from a golden image, but then bootstrap to configure other actions. Basically, with AWS, you are only restricted by your imagination or coding skills. AWS assets are programmable, so you can apply all these techniques and principles that we've just talked about to entire environments and not just individual resources, so you can completely rethink the way you work your IT infrastructure. Automation is a big part of planning and designing cloud infrastructure. AWS allows you to reduce the level of manual interaction in your environment. Using automation, you can react to a variety of events without having to do anything. Let's take a look at some examples. AWS Elastic Beanstalk. Developers can upload their code and the Beanstalk service automatically handles resource provisioning, auto-scaling, load balancing, and monitoring. EC2 Auto Recovery. In some situations, you can use auto recovery to automatically recover an EC2 instance if it becomes impaired. The recovered instance is identical to the original, instance name, IP address, metadata, etc. Auto-scaling. You can automatically add resources to cope with demand spikes and decrease again during quiet times. CloudWatch alarms and events. CloudWatch can send SNS notifications to alert when a particular event occurs. For example, CPU usage is too high. The notifications can be used to perform follow-up actions, like run a Lambda function. OpsWorks lifecycle events. You can continually update your instance's configuration to adapt to environment changes. For example, if a new database instance is added to your environment, then an event can automatically trigger a chef recipe that points existing applications to the new server. Loose coupling is an important concept. Applications should be designed so that they're broken into smaller, loosely coupled components. The desired outcome is that a failure in one component should not cause other components to fail. This is achieved through a variety of measures. Firstly, well-defined interfaces. By ensuring that all components only interact with each other through specific technology-agnostic interfaces, for example RESTful APIs, will result in being able to modify resources without affecting other components. Amazon API Gateway is a fully managed service for APIs, which you can do this with. Loose coupling needs services to be able to interact with each other without having any prior knowledge of their existence. For example, imagine two servers communicating on hard-coded IP addresses. Then the addition or modification of resources will result in manual interaction to update the configuration. However, loosely coupled infrastructure is an essential ingredient in making the most of cloud computing elasticity. The easiest way to achieve this is to use an elastic load balancer service to provide a stable endpoint for all your services. This way, they don't have to worry about each other, the elastic load balancer does that for them. Rather than use synchronous integration, where server A completes an action and passes it to server B, which then passes it to server C, asynchronous integration involves the use of an intermediate storage area, like an SQS queue. This approach means that when a server A completes its action, it sends a notification to SQS. This way the compute resources are decoupled and not directly linked to each other. This means you can easily add or remove resources without having to update the configuration of the existing compute resources. Designing applications to fail gracefully allows other resources to continue a service without causing a complete outage. Examples of this would be if your primary website fails, the Route 53 DNS failover feature points your users to a backup site hosted on a static website on Amazon S3. The idea is to continue to provide a service, even if it isn't the full experience. Traditional IT infrastructure involves developing, managing, and operating applications with a wide variety of underlying technology components. AWS isn't just about EC2 instances. There are a suite of products to do everything mentioned and a lot more besides, to help you lower your IT costs and allow you to move faster as an organization. For example, managed services. AWS provides many services that are fully managed: databases, machine learning, analytics, search, email, etc. This lessens the burden on your IT infrastructure department. RDS databases mean you don't have to worry about backups, fault tolerance for your simple databases. S3 allows you to store as much data as you need without having to concern yourself with capacity management. Serverless architectures. You can reduce operational complexity of your applications through the use of serverless architectures. Tools such as the Internet of Things, Lambda, S3, Beanstalk all allow you to run your applications without paying for any server infrastructure. In a traditional IT environment, the type of database in use is typically restricted by constraints on licensing, support capabilities, hardware availability, and things like that. AWS provides you with multiple managed database server options that remove these constraints, meaning that you can choose exactly the right database for your needs rather than making use of what is available to you. AWS offers fully managed, easy scalable services for relational databases, NoSQL, data warehouses, and search functions that provide fully managed, easily scalable services that can create synchronously replicated standby instances in different availability zones. And they'll also automatically fail over without the need for manual intervention. We'll cover databases in a whole lesson later on in this course. Now we'll take a look at redundancy. Introducing redundancy will ensure your systems are highly available so they can withstand the failure of individual or multiple components, for example hard disks, servers, or network links. Introducing redundancy will remove single points of failure from your systems. This is achieved by having multiple resources for the same tasks in either standby or active mode. Standby redundancy is often used for stateful components like databases. The standby resource becomes the primary resource by it failing over to it. The standby resource can be brought online only when required to save cost, or it can already be running to speed up the failover process and minimize the outage. Active redundancy is where multiple redundant compute resources share requests and are able to absorb the loss of one or more of the instances failing. Examples of this would be multiple web servers sitting behind a load balancer. Automatic failure detection allows you to react to an outage automatically without the need for manual intervention. Services like Elastic Load Balancer and Route 53 let you configure health checks so you can automatically route traffic to healthy resources. For example, setting up a health check to test for a HTTP 200 response, which means OK, would allow AWS to know if a node is healthy or not. Services such as OpsWorks, Elastic Load Balancer, and EC2 Auto Recovery will let you replace unhealthy resources with brand new healthy ones. Durable data storage is an important part of planning your cloud resources. Replicating your data to other sites or resources will protect its availability and integrity. There's 3 ways you can replicate your data: synchronously, asynchronously, or quorum-based. Synchronous replication ensures that your data has been durably stored on both the primary and replication locations. Any write operation will only be acknowledged as complete when this has taken place. This should only be used on low latency network connections where absolutely necessary to try to ensure maximum performance. Asynchronous replication decouples the primary node from the replicate so that a write operation doesn't have to wait for any acknowledgement. This can introduce a replication lag but does not impact performance. And from personal experience, I've seen the difference between synchronous and asynchronous replication changing performance as much as 100%. Quorum-based replication is a mix of both synchronous and asynchronous replication. Replication to multiple nodes is controlled by defining the minimum number of nodes that must participate in a successful write operation. So if you have a cluster of 4 replicas, you can say, I need confirmation from at least 2 of them before the acknowledgement is sent back to the end user. A traditional data center failover scenario involves failing over all your resources to a secondary distant data center. Because of the long distances between the 2 data centers, synchronous replication is often impractical, slow, and usually involves data loss and isn't tested very often. However, it does protect against low probability scenarios such as a natural disaster. So if your main data center was in New York and your secondary was in, say, Washington, if New York had a massive outage, you could fail over to Washington, but it's going to be slow and practical and take some time. A more likely scenario is a shorter interruption in your data center, which isn't predicted to be too long. In this situation, your choice is to sit it out and wait, or initiate the complex failover procedure. AWS data centers are configured to provide multiple availability zones in a region, with low latency network connectivity. This means you can replicate your data across data centers in a synchronous manner, and as a result, failover becomes much simpler. Also, this concept is baked into many AWS services, such as RDS and S3. Active redundancy is great for disaster recovery situations or balancing traffic, but what if all the requests to your resources were harmful? For example, if a particular request caused a bug and it resulted in multiple instances crashing. A practice called shuffle sharding means only sending some of the requests to some of your resources. This way, if one shard of resources is infected or down, the other shard of resources will be up and running. In the example shown here, if request 2 is bad, then at least one set of resources is still protected. AWS economies of scale offer organizations huge opportunities to make cost savings. By making further use of AWS capabilities, there's even more scope to create cost-optimized cloud architectures. Right-sizing is one such approach. In stark contrast to traditional IT infrastructure, cloud computing means you can select the most cost-effective resource and configuration to fit your requirements. EC2, RDS, Redshift and Elasticsearch give you a wide variety of instance types to choose from. Through benchmarking, you can determine the optimal configuration for your workload. In some cases, it might be optimal to select many of the cheapest instance type available. In others, it might be more beneficial to select fewer instances, but of a larger instance type. AWS Storage offers the same level of right-sizing opportunities. Amazon S3 offers many different storage classes to suit your needs. EBS also comes in a variety of different volume types, all of which will be covered in later lessons. AWS offers many elasticity options to help you save money. You can auto-scale your EC2 workloads horizontally or vertically. You can turn off production workloads when you don't need them. And where possible, you can use Lambda compute workloads so you never have to pay for idle resources. EC2 on-demand instance pricing means you only pay for what you use with no long-term commitments. However, there are two more ways to pay for EC2 instances. One of these is reserved capacity. By committing to a defined period of between 12 to 36 months, you can receive significantly discounted hourly rates compared to on-demand pricing. AWS Trusted Advisor, or AWS EC2 usage reports, identify the resources that would benefit from reserved capacity. There is technically no difference between on-demand and reserved instances. The only difference is the way you pay for it. This concept also exists for Redshift, RDS, DynamoDB, and CloudFront. EC2 spot instances are ideal for workloads that have flexible start and end times, as you are allowed to bid on spare EC2 computing capacity, and spot instances are often available at significant discounts compared to on-demand pricing. Your EC2 spot instance is launched when your bid exceeds the current spot market price, and it will continue to run until either you terminate it or the spot market price exceeds your bid. When the latter happens, your instance is terminated, and you'll not be charged for the partial hour that it was running. So there's three strategies to use for spot instances. There's the one we've just discussed, which is bidding. You could bid much higher than the spot market price for as long as the instance runs. This way, even if the market price spikes occasionally, you'll still make a saving overall. The mix strategy. AWS recommends designing applications that use a mixture of reserved, on-demand, and spot instances. This way you can combine predictable capacity with opportunistic access to cheaper additional compute resources. And then finally, there's spot blocks. AWS allows you to bid for fixed duration spot instances. These have a different hourly pricing, but allow you to define a duration requirement. If your bid is accepted, your instance will run until you terminate it or the duration ends. Now let's take a look at caching. Caching data means storing previously calculated data for future use, so you don't have to recalculate it again. There's two approaches. Application caching. You can design applications to store and retrieve information from fast managed in-memory caches. This way, an application can look for results in the cache first, and if the data isn't there, it can then calculate it or retrieve the data and store it in the cache for subsequent requests. This approach improves user response times and reduces load on your resources. An example of this is Amazon Elasticache, which is a service that provides an in-memory cache in the cloud suitable for use with web services. Edge caching uses Amazon CloudFront, so you can cache static content such as images or video and dynamic content such as live video around the world using edge locations. This way users can be served the content that is closest to them, and resulting in low latency response times. The principle applies to both download and upload with edge caching. And finally, security. It's important to have security built into your plans and designs for AWS infrastructure. AWS allows you to take most of the security tools and techniques that you already know and improve them by formalizing security control design into your AWS platform. This simplifies the system for administrators and auditors alike. Now, we're not going to cover too much here because this is all covered in the IAM lesson, but there's things like defense in depth, which allows you to add multiple layers of protection to your resources, reduced privileged access to only give people the access they require. Security as a code lets you capture security requirements in one script that you can use to deploy new environments. And real-time auditing. AWS has multiple services to ensure you can test and audit your environment in real time. AWS offers a wide and deep set of functionality that allows you to integrate your existing network, security, data, lifecycle management, and resource management capabilities with the cloud. AWS allows you to extend your existing on-premise network configuration onto your AWS virtual private clouds, so that your AWS resources will operate as if they're part of your existing network. You can do this using Amazon Virtual Private Cloud, VPC, which is a logistically isolated network in the Amazon cloud that gives you complete control over your virtual networking environment. You can choose your own IP range, subnets, route tables, network, etc. Then there's Direct Connect. Rather than use internet-based connections between your on-site resources and the Amazon cloud, Direct Connect lets you establish a dedicated network connection between the two to provide lower costs and a higher level of service. You can use AWS to reliably and cost-effectively back up and secure your data. AWS allows you to replicate your data across geographical regions, manage the lifecycle of the data, or even synchronously replicate your data to a local AWS data center. AWS Storage Gateway is a VM that you install in your data center and configure to be associated with your AWS account. Then you can either use Gateway Cached, which lets you use Amazon S3 storage as your primary data storage, while retaining frequently accessed data locally in your storage gateway, or Gateway Stored. Gateway Stored volumes let you store your primary data locally and asynchronously back that up to AWS. Amazon Simple Storage Service S3 offers a practically unlimited storage that's available for backing up and archiving your critical data, and Amazon Glacier is extremely low-cost storage for infrequently accessed data, for which recovery intervals of several hours are suitable. AWS Security and Access Control is easily managed using IAM or Microsoft Active Directory services. AWS Identity and Access Management is the service that enables you to securely control user access to all your AWS services and resources. An AWS Directory Service is a managed service that allows you to connect your AWS resources with an existing on-premise Microsoft Active Directory, or you can set up a new standalone directory in the AWS cloud. AWS Security and Access Control is easily managed using IAM or Microsoft Active Directory services. AWS Identity and Access Management is the service that enables you to securely control user access to all your AWS services and resources. An AWS Directory Service is a managed service that allows you to connect your AWS resources with an existing on-premise Microsoft Active Directory, or you can set up a new standalone directory in the AWS cloud. And there's three flavors of Active Directory. There's Microsoft AD, which is a fully blown managed Microsoft Active Directory service that supports up to 50,000 users. There's Simple AD, which is a standalone managed directory that's available in two sizes, small and large. Small is for up to 500 users, and large supports up to 5,000 users. Or this AD connector, and this is a directory gateway that allows you to proxy directory requests to your on-premise Microsoft Active Directory. And this also comes in two sizes, small and large. A small AD connector is designed for small organizations of up to 500 users, and a large AD connector is designed for larger organizations for up to 5,000 users. You can also use integrated resource and deployment management tools in your hybrid environment. AWS provides monitoring and management tools with robust APIs, so you can easily integrate your AWS resources with on-site tools. And most major software vendors already support AWS, like Microsoft, VMware, and BMC. Tools such as AWS OpsWorks allow you to deploy and operate applications in the AWS cloud or in your own data center. You can use templates or build your own tasks to specify an application's architecture. AWS Code Deploy automates code deployments to instances in your existing data center or in the AWS cloud. AWS Code Deploy simplifies the code deployment.
The main purpose of configuration management is to quickly spin up new resources whenever required. You may need to quickly spin up resources to upgrade to new instance types, to replace a failed instance or underperforming instance, for disaster recovery, for auto-scaling. You may also need to deploy configuration changes to a fleet of existing and running instances. Logging into each virtual machine and updating the same configuration files can take a ridiculous amount of time. So the deployment of the instances must be automated and repeatable to make the process easy and convenient. AWS supports a number of technologies for configuring and deploying Amazon EC2 instances and other AWS infrastructure. User data, Amazon Machine Images or AMIs, configuration management tools. User data is basically a command sequence that is executed at the first launch of the instance. When you launch an instance in Amazon EC2, you have the option of passing user data to the instance that can be used to perform common automated configuration tasks and even run scripts after the instance starts. You can pass two types of user data to Amazon EC2, shell scripts and cloud init directives. You can also pass this data into the launch wizard as plain text file for launching instances via the command line tools, or as base64 encoded text for API calls. The AMI provides the information required to launch an instance, which is a virtual server in the cloud. You can specify an AMI when you launch an instance, and you can launch as many instances from the AMI as you need. You can customize the instance that you launch from a public AMI and then save that configuration as a custom AMI for your own use. Instances that you launch from your AMI can use all the customizations that you've made. AWS also offers a variety of its own configuration management tools and services, which allow you to configure new instances using reusable templates and update configuration dynamically in response to change. In this lesson, we'll review some of these tools, such as AWS CloudFormation and AWS OpsWorks, and discuss strategies for combining these technologies into a comprehensive configuration and deployment strategy. AWS CloudFormation enables customers to create and modify collections of AWS resources using predefined reusable infrastructure templates. The CloudFormation templates provide EC2 bootstrapping features to help automate the initial installation and configuration of the OS and application stack. Templates can also be versioned, enabling customers to apply versioning logic to their AWS infrastructure the same way they do with software. AWS OpsWorks is a fully managed application stack management service that includes provisioning and configuration of Amazon EC2 instances, auto-scaling, application deployment, and application health monitoring. It also provides the ability to integrate with additional AWS services, such as Elastic Load Balancing and Amazon RDS instances. Your organization may have decided that it wants a base set of software included on all instances launched within its cloud. This may include homegrown utilities, in-house tools for using AWS services, and advanced software for enterprise-scale activities, such as monitoring and intrusion detection, among other possibilities. In this circumstance, consider using the base AMI approach. With this approach, you can pre-configure all of the software your organization requires on an Amazon EC2 instance, and then create an AMI from that instance. The new AMI would then become the AMI used to create all new instances within the organization. Organizationally, you could enforce use of the base AMI in a couple of ways. Create a custom toolset that becomes the gateway toolset for creating AWS resources, and that forces creation of instances from the pool of custom AMIs. Create processes that scan the running Amazon EC2 instances in your account and terminate any instances that are not using the standard AMIs. Third-party configuration tools, such as Chef and Puppet, are used by many AWS customers to start new Amazon EC2 instances in an automated and repeatable manner. The flexibility of these environments enables the implementation of a complete configuration management system. This screen illustrates one way in which configuration software can be integrated within an AWS architecture. Let's assume that you want to use configuration software to initialize a set of Amazon EC2 instances as web servers. The scenario breaks down as follows. The administrator sets up a configuration server. This usually is a standalone Amazon EC2 instance that will contain a set of templates which describe all of the applications, files, and configuration that a server needs to initialize itself. For example, a web server might instruct an instance to install Apache HTTPD, configure Apache's HTTPD config file, install all necessary programming language environments such as PHP, Ruby, and create a directory and file structure for web server content. A configuration server will likely contain a number of recipes for configuring dozens of different types of machines, including MySQL Server, NAT Server, Windows IIS Server, and so on. The administrator will create configuration templates, publish them to the configuration server, and check them into a source control system for version management and change tracking. The administrator will use custom scripting, CloudFormation, OpsWorks, or similar products to describe and create a full AWS cloud deployment environment. These tools may also specify what custom applications will be hosted in these environments, on which instances they should be hosted, and how they ought to be configured on each instance. For each Amazon EC2 instance that is deployed, the administrator will instruct the instance on how to configure itself as a configuration client of the configuration server. The administrator will also supply the name of the templates to be downloaded and executed on that machine. When an Amazon EC2 instance is deployed using a deployment technology, such as a script or CloudFormation, it will configure itself as a configuration client, download the appropriate template, and execute it. Various customers use different combinations of the technologies discussed in this topic to manage their AMIs. The solution adopted by your organization will depend on several factors, including your production workflow and your organizational standards. None of these techniques are mutually exclusive. They can all be used in tandem to craft a strategy that's right for your company. In general, placing software in AMIs is best reserved for foundational, slow-changing components that are truly required as standards throughout your organization. To create an Amazon EBS-backed Linux AMI, start from an instance you've launched from an existing Amazon EBS-backed Linux AMI. After you've customized the instance to suit your needs, create and register a new AMI, which you can use to launch new instances with these customizations. Ensure data integrity by stopping the instance before you create an AMI, then create the image. When you create an Amazon EBS-backed AMI, it's automatically registered for you. Amazon EC2 powers down the instance before creating the AMI to ensure that everything on the instance is stopped and in a consistent state during the creation process. Some file systems, such as XFS, can freeze and unfreeze activity, making it safe to create the image without rebooting the instance. When you need to automate the creation of an AMI, you can use the AWS EC2 Create Image command as displayed on the screen. During the AMI creation process, Amazon EC2 creates snapshots of your instance's root volume and any other EBS volumes attached to your instance. If any volumes attached to the instance are encrypted, the new AMI will only launch successfully on instances that support Amazon EBS encryption. Depending on the size of the volumes, it can take several minutes for the AMI creation process to complete, sometimes up to 24 hours. You may find it more efficient to create snapshots of your volumes prior to creating your AMI. This way, only small, incremental snapshots need to be created when the AMI is created, and the process completes quickly, though the total time for snapshot creation remains the same. After the process completes, you have a new AMI and snapshot created from the root volume of the instance. When you launch an instance using the new AMI, a new EBS volume for its root volume is created using the snapshot. Both the AMI and the snapshot will accrue charges to your account until you delete them. You can copy an AMI within or across an AWS region using the AWS Management Console, the command line, or the Amazon EC2 API, all of which support the copy image action. Both Amazon EBS-backed AMIs and instance store-backed AMIs can be copied. You can't copy an encrypted AMI between accounts. Instead, if the underlying snapshot and encryption key have been shared with you, you can copy the snapshot to another account while re-encrypting it with a key of your own, and then register this privately owned snapshot as a new AMI. Copying a source AMI results in an identical but distinct target AMI with its own unique identifier. In the case of an Amazon EBS-backed AMI, each of its backing snapshots is, by default, copied to an identical but distinct target snapshot. The exception is when you choose to encrypt the snapshot. The source AMI can be changed or deregistered with no effect on the target AMI. The reverse is also true. AWS does not copy launch permissions, user-defined tags, or Amazon S3 bucket permissions from the source AMI to the new AMI. After the copy operation is complete, you can apply launch permissions, user-defined tags, and Amazon S3 bucket permissions to the new AMI. The AMI creation process is different for instance store-backed AMIs. First, launch an instance from an AMI that's similar to the AMI that you'd like to create. You can connect to your instance and customize it. When the instance is set up the way you want it, you can bundle it. It takes several minutes for the bundling process to complete. After the process completes, you have a bundle, which consists of an image manifest and files that contain a template for the root volume. Next, you upload the bundle to your Amazon S3 bucket and then register your AMI. When you launch an instance using the new AMI, we create the root volume for the instance using the bundle that you uploaded to Amazon S3. The storage space used by the bundle in Amazon S3 incurs charges to your account until you delete it. You can convert an instance store-backed Linux AMI that you own to an Amazon EBS-backed Linux AMI. This involves creating a bundle, but the bundle is then downloaded onto a new Amazon EBS volume. After that, you need to snapshot the volume and create your new AMI from the snapshot. Please note you cannot convert an instance store-backed Windows AMI to an Amazon EBS-backed Windows AMI, and you cannot convert an AMI that you do not own. Using a configuration server can simplify many common administrative tasks. The most common example is provisioning and deprovisioning user access to Amazon EC2 instances. Say that Joe, an engineer, has been given access to multiple Amazon EC2 instances across the fleet, meaning Joe has a private key that enables him to log in with his unique user ID and perform administrative tasks on these instances. But what happens when Joe leaves the company? Without a configuration server, deprovisioning Joe's access to these machines can be a manual nightmare. Using a configuration server, however, a system administrator can easily change Joe's status in the system and roll this change out to all instances in the fleet with a few simple commands. One of the advantages of using a configuration server, such as Chef, Puppet, or Ansible, is that configuration is idempotent. Resources that are created or configured by a configuration server are configured or created only once. If manual modifications are made to the configuration of an instance, the configuration server detects them and rolls them back. This ensures that the integrity of the instance isn't compromised by an accidental change. Most configuration software supports a single machine or standalone model, which means that it is typically capable of managing 1 to hundreds of servers from a central controller machine, hence the server orchestration term. In a typical environment, you can have a single administrator machine on which you create and edit the configuration templates, store them in the source control system, for example, Git, and use the configuration management tools to orchestrate your infrastructure. We'll now review some typical failures that might occur during the launch of the instances. Automated scripts or CloudFormation templates fail to create instances in different regions. Here, you need to check the AMI IDs. Keep in mind that in different regions, you always have different AMI IDs, so you need to make sure that you set the correct ones in your configuration. Another issue that you might come across is when the instance is marked ready, but the configuration is not complete. Keep in mind that the configuration readiness is separate from instance readiness. You need to take additional measures to check readiness of your configuration. For example, your configuration scripts can send an alert when the instance is fully configured. Another common issue is when the Windows images take a long time to boot from the AMI. The Microsoft System Preparation, or SysPrep tool, simplifies the process of duplicating a customized installation of Windows, but it can't extend the time it takes for an image to boot. For instance, readiness. Note that if you are using CloudFormation templates to deploy infrastructure, CloudFormation provides an object called waitCondition that can be used by user data scripts to signal to CloudFormation when configuration has completed successfully. The cloud offers you lots of possibilities, but it also brings a lot of questions about how to manage its power and flexibility. How do you update servers that have already been deployed into a production environment? How do you consistently deploy an infrastructure to multiple regions in disparate geographical locations? How do you roll back a deployment that didn't execute according to plan? In other words, how do you reclaim the resources that were already created? How do you test and debug a deployment before rolling it out to production? How do you manage dependencies, not only on systems and technologies, but on entire subsystems? The most commonly used technologies for automated, repeatable deployments include custom scripts and applications in which you can use AWS command line interface commands or AWS API to automate deployments in a variety of languages. AWS CloudFormation is a building block service that enables customers to provision and manage almost any AWS resource via a JSON-based domain-specific language. AWS CloudFormation focuses on providing foundational capabilities for the full breadth of AWS, without prescribing a particular model for development and operations. Customers define templates and use them to provision and manage AWS resources, operating systems, and application code. AWS OpsWorks focuses on providing highly productive and reliable DevOps experiences for IT administrators and ops-minded developers. To achieve this, AWS OpsWorks employs a configuration management model based on concepts such as stacks and layers, and provides integrated experiences for key activities like deployment, monitoring, autoscaling, and automation. Compared to AWS CloudFormation, AWS OpsWorks supports a narrower range of application-oriented AWS resource types, including Amazon EC2 instances, Amazon EBS volumes, Elastic IPs, and Amazon CloudWatch metrics. The cloud simplifies the migration of systems by making it easier to create parallel environments. There is no need to buy additional hardware to stand up a pilot version of your new environment. You can simply create the resources that you need. However, you still need to figure out how to ramp users off the existing system and onto a new one, a task that is much more challenging than a so-called greenfield or initial deployment. Some common patterns used to bring new systems online in a cloud environment include blue or green deployment. A parallel or green system is deployed by autoscaling alongside an existing or blue system. The traffic is gradually shifted onto the green system. We'll discuss this model in depth a little later. Red or black deployment. This is a variation on the blue or green method used by Netflix. In this model, the existing or the red system exists in parallel to the new system. Once the new system is fully initialized and running, the infrastructure is considered to be in a red state. Next, the traffic is cut off to the existing system, putting it in a black state. The system is now in red-black mode. The old system is no longer receiving requests, and all new traffic is going to the new system. The black system is kept up and running while existing connections are completed to ensure that the red system is operating without incident. Engineers can bring the black system online if required. Dark launch. Used mainly for testing, a dark launch brings new features into a system without enabling the new feature in the user interface. Dark launches are used to ensure that a new feature works correctly in production and can handle the load associated with a company's existing user base. On this screen, an example of a blue or green deployment is displayed. In this model, a parallel environment with its own load balancer and auto-scaling configurations is brought up side by side with the existing environment. A feature of Amazon Route 53 called weighted routing can be used to begin shifting users over from the existing or blue environment to the new or green environment. Technologies such as CloudWatch and CloudWatch logs can be used to monitor the green environment. If problems are found in the new environment, weighted routing can be deployed to shift users back to the running blue servers. Once the new green environment is fully up and running without issues, the blue environment can gradually be shut down. Due to the potential latency of DNS records, a full shutdown of the blue environment can take anywhere between 1 day and 1 week. As discussed earlier, one of the challenges faced while deploying in cloud is implementing version upgrades. You can solve this problem with the help of autoscaling. There are multiple approaches. Use the oldest launch configuration termination policy to drain old instances. Old instances will be replaced with the newer ones, launched using the latest version of launch configuration. Bring up 2 separate auto-scaling groups and use Amazon Route 53 and weighted routing to drive different percentages of incoming traffic to the 2 groups. You can start creating new instances and use AWS autoscaling attach instances to bring new instances into group, and use the AWS autoscaling detach instances policy to remove existing ones. AWS CloudFormation enables you to create and provision AWS infrastructure deployments predictably and repeatedly. It helps you leverage AWS products such as Amazon Elastic Compute Cloud, Amazon Elastic Block Store, Amazon Simple Notification Service, Elastic Load Balancing, and Autoscaling to build highly reliable, highly scalable, cost-effective applications without worrying about creating and configuring the underlying AWS infrastructure. AWS CloudFormation enables you to use a template file to create and delete a collection of resources together as a single unit or a stack. The two major concepts in AWS CloudFormation are templates and stacks. A template is a specification of the AWS resources to be provisioned. A stack is a collection of AWS resources that has been created from a template. You may provision or create a stack numerous times. When a stack is provisioned, the AWS resources specified by its template are created. Any charges incurred from using these services will start occurring as they are created as part of the AWS CloudFormation stack. When a stack is deleted, the resources associated with that stack are also deleted. The order of deletion is determined by AWS CloudFormation. You do not have to direct control over what gets deleted when. First, we'll be creating an Amazon S3 bucket for using the CloudFormation template. You need to decide in which region you want to create the template. For this demonstration, we'll create the template in the Mumbai region. Go to the CloudFormation service under the Management Tools section. Click Create New Stack. On this page, you get various options for designing or selecting a template. We already have a JSON code ready for this template. So let's select the Upload a Template to Amazon S3 option. Click Choose File to upload the file from your system. Select the file from your system to upload it. It's a simple JSON file that creates an Amazon S3 bucket. Click Next. Provide a stack name. Click Next. We'll keep all the values as default and click Next. On this page, you can review the template URL and the stack name. Click Create. Under the Events tab, you can observe the progression of the events related to stack creation. As you can see, the status is being shown as in progress. Click the refresh icon to view the progression of the steps in the stack creation process. Click the refresh icon again to refresh the view. As you can see, now stack has been created. Refresh the page again. Now you can see the status also displays that the stack has been created, which means that the stack is ready to use the resources. Click the Resources tab to view the bucket that has been created. As you can see, Amazon has provided a physical ID for the bucket. Let's now check out the bucket and see it has been created correctly. Let's go back to the console. Click S3 under the Storage and Content Delivery section. As you can see, our bucket is available. Click the bucket name. As you can see, the bucket is empty. Click the Properties button to view the properties of the bucket. As you can see, it has been created in the Mumbai region. Let's now go back to the Management Console and click CloudFormation under the Management Tools section. We'll now go and delete the stack. Once the stack is deleted, this bucket will be automatically deleted. Select the stack, click Actions, and select the Delete Stack option. Click the Yes Delete button to confirm your action. Under the Events tab, you can view all the events related to the deletion process. Click the refresh icon to get the updated view every time. As you can see, the stack and the bucket have been deleted. You have learned how to create an AWS CloudFormation template.
Security is one of the key concerns for all those who would want to come onto the cloud. It could be an enterprise, it could be a startup, it could be a small business, and they all worry about that data. How secure is the data? So let's spend some time talking about security on AWS. Security at AWS is job zero. That is what AWS talks about. That is everybody's responsibility. And it starts right from the infrastructure. We spoke about regions. We spoke about availability zones. So availability zones are the physical data centers, and they are designed to be fault tolerant. They are designed to be highly available. So they are always in a group of 2 or more. So that way, if one goes down for any reason, we will still have the services running from the second data center. AWS has something called a shared security responsibility model, where they say that whatever happens to the underlying infrastructure, they are responsible for securing that infrastructure, such as the regions, the availability zones, the edge location. They are responsible for that underlying infrastructure. The customers are responsible for everything that they put on top of that infrastructure. So the data, the application, the access, the firewall rules. The customer is responsible for configuring access to anybody on that infrastructure. By default, AWS provides all the tools, and they do not provide any access to firewalls that we create, any user that we create, or any object that we upload to the cloud. By default, it will be private, so we have to explicitly make it public for any user. We have to give them permission to do something. Otherwise, they will not be able to do anything. Whenever we add any data, then it is addressed. We have to tell them who can access it. AWS gives you a whole set of services to secure your data, to secure your applications, to secure your resources, such as servers in the cloud. We will also talk a little bit about the compliance that you need for your application to be PCI DSS compliant, or if your application deals with the healthcare industry and must be HIPAA compliant, and you need all those documents that say that your infrastructure is HIPAA compliant. There's a place to go, and it's a shared service. So you go, and you request something, and you get it. Take a look at all that AWS has to offer when it comes to security. It all starts from the identity and access management. At the heart of it, you would have who is accessing your system, and then what they are allowed to do in that system. So we are talking about authentication, and we are talking about authorization. So AWS gives you so many options to create users. You can create rules. You can manage the credentials on your own. Or you can have something called identity federation. So you don't have to create a login for everybody if you already have their credentials in your Active Directory. Or if you want to have them connect with Facebook ID, or Gmail ID, or LinkedIn ID, or Twitter ID, they should be able to do that. This is known as identity federation, and it allows you to do just that. They also have something called roles, where the credentials are managed by AWS and they are rotated internally, so you don't have to worry about managing credentials or storing them in the servers or passing them to the API request. They also have something called security tokens, which are nothing but temporary credentials, and you can allow somebody to access your application or system for a few minutes, maybe 60 minutes, maybe up to a few hours, and then these tokens would automatically expire. They also have something called multi-factor authentication. You can have all your users use this hardware or software device to authenticate themselves. You can have the MFA set up on their phones, and you'll be sure that anybody who is logging in should be in possession of that phone in order to log in. Similarly, for your application, they have something called AWS WAF. That is a web application firewall, and it's simply to protect your application. You can configure it to the best of your choices, and it will simply protect you from any unwanted traffic that you don't want to hit your application. In similar fashion, they have something called AWS Shield. That is the service to mitigate all DDoS attacks. It comes in two versions, a standard version and an advanced version, and the standard version is free of cost. So, it will block most known DDoS and other attacks, and you can configure it to protect your hardware or your resources from any known attacks. Let's say you know you have a lot of resources in the cloud, and you want to monitor them continuously against any security threat. There's a service called Amazon Inspector, where you simply install an agent, and this agent will keep running, will keep producing reports for you on a monthly basis. So the bill is per agent per month, and it is really very economical when you compare it with other services, which are either paid or open source and not managed. And there's something called AWS Certificate Manager. That is a service that simply manages your SSL and TLS certificate. So you can bring your own certificate and upload it, or you can buy that certificate from AWS. And in both ways, you can simply manage those certificates in one location. AWS gives you that capacity, so you don't have this hassle of managing those services. Now this is a very interesting AWS artifact that we spoke about. So, let's say you need a compliance certificate that says that the infrastructure that you're running on is PCI certified because you are running an application that takes credit card information or does some credit card transactions. You could simply come here, and then you can request the artifact that you want. So you have something like FedRAMP Partner Package, you have ISO certification, and you can simply request that certification, and you are going to get that certification over here. So these are the suite of services that AWS has to offer for security. Apart from that, there are firewalls at your instance level, at your server level, firewalls at your subnet level. There are encryption services. You can ask AWS to do their own encryption, or you can run your own encryption algorithms. There are several kinds of credentials for accessing different services. And I like to think about it like this. There was once a time when people would not go on the cloud because of security. And now, people, organizations, banks, government agencies, they're moving towards cloud because their data, their network, is much more secure than what they could have on their own.
Let's see the steps to create an AWS account. The first step is to open the AWS web page. Then, click Create a Free Account to display the sign-in or Create an AWS Account page. In this page, click I am a new user. Enter your email ID or mobile number in the email or mobile number box, and then click Sign in using Secure Server. The AWS servers verify if an account already exists with the entered email ID. If yes, it displays an error message, else displays the login credentials page. In the Login Credentials page, enter the name. Re-enter the previously entered email ID and the password for your account. Then, click Create Account to display the contact information page. This page gives you the option to create a company account or a personal AWS account. For this demonstration, we will create personal AWS account. Then enter your full name and address in the displayed fields. Next, enter the CAPTCHA characters from the displayed security image. An important step is to open the AWS agreement and read it thoroughly. Then select the AWS Customer Agreement checkbox. Selecting the checkbox indicates that you have read the AWS agreement and you agree to it. Then, click Create Account and continue to display Payment Information page. In this page, enter the credit card details, and then click Verify Card and continue to display the Identity Verification page. Before displaying the Identity Verification page, the AWS servers verify the entered credit or debit card details by performing a reversible transaction of a small amount. This page displays your entered mobile number and is used to verify and confirm your identity. As you click Call Me Now, the AWS system calls you on the displayed number and your computer screen displays a 4-digit verification PIN. Enter the displayed 4-digit PIN in your phone using the keypad. Once the verification is successful, the page displays a message, Identity Verification Complete. Simply click Continue to select your support plan to display the support plan page. This page displays and explains about the 3 support plans: Basic, Developer, and Business. For this demonstration, we will select the free or basic plan, and then click Continue to display the welcome page of the AWS services. Congratulations! You have successfully created an AWS account.
Let's talk about the economics of cloud. How much does it cost to be on cloud? What happens if I move some of my resources from my data center to cloud? How long is it going to take? And if I have to pay monthly, what will my monthly bill be? How do I know that? AWS gives you a lot of tools to manage your cost before you hop onto AWS Cloud or after you have made the move to cloud. Then, once you have been on cloud for a while, and we'll take a look at all of these things. So at the very beginning, at a very basic level, it is the pay-as-you-go model. It is not a CAPEX model. That is capital expenditure model. It is an OPEX model. So you pay only for what you use. You do not have to pay a fee or anything, and you can get a volume discount as well. So if you are a large organization and you have multiple teams and multiple accounts for AWS, you can have a billing option where you will have one person, one account that is going to pay the bill for all of the accounts in the organization. And the benefit you get from doing this is a volume discount. There are 3 tools that we are going to look at now. One is known as the AWS Cost Calculator. And what the AWS Cost Calculator does for you is it tells you how much you'll be charged for each service for all the resources that you are going to use. It will calculate and tell you your monthly bill. So, in this scenario, we are looking at a very simple implementation where we have a dev environment, a QA environment, and a broad environment. In dev and QA, we have one server each that we are choosing as G2.medium. And in broad, we have 2 servers. We know that broad is going to run for a very long time, so we are using the billing option of a 1-year partial payment, and then we get a lot of discounts. If we know that this workload is going to be required for up to 3 years, then we can select this option, and we'll get up to a 75% discount now. This is only for servers. Down below, we have used EBS volumes, which are just hard drives. And then I also selected 3 volumes, one each for dev, QA, and production. And then I also added how much snapshot data I'm going to have every month. If you see on the top of here that I get the monthly bill now, this is something only for EC2. I could use the same thing for my database as well, so I will have some databases as well, and I can add all the databases I need. Apart from this, if I scroll down here, there are so many services on your left that you can see that if you want to use all these services, and it will just let me know what the monthly charge is for all of these things. So this is something you can do before you hop on to AWS. There are servers I have at my disposal in my data center, and then I'm going to transfer my workload, my application, all my data to the cloud, how much am I going to pay, and this is a tool that is used day in and day out by pre-salespersons, by solutions architects, by executives who want to know beforehand how much they're going to pay. On the same line, we have something called TCO Calculator. That is the Total Cost of Ownership Calculator. Now here, we can also add the manual labor that we have, the personnel that we have, the power that we have, and it goes into more granular details of the resources that we have. It just gives you a total cost of ownership, and this is why these two things are very, very beautiful things. If you want to know beforehand what will happen if you move some of your workload to cloud, and you get a very, very, very good idea of the cost that you are going to spend in cloud on a monthly basis. Coming back to AWS Console. Within the console, there's a tool called AWS Trusted Advisor that essentially checks your implementations. So once you are on the cloud, once you have added all the sources on the cloud from your databases, your servers, your storage, your cache, everything, then the AWS Trusted Advisor checks all that you have done, and then it gives you recommendations on 4 different things. Among those 4 things are the cost optimization, which will tell you that if you are using these workloads for production, you might want to convert them into a reserve pricing option. So there are on-demand pricing options, there is a reserve pricing option, and then there's a spot pricing option. Reserve is the one that you use if you know you are going to run this workload for a period of 1 year, 2 years, or 3 years. Then you can buy that capacity in advance from AWS. And you don't have to necessarily pay all the money up front. You can do a partial payment for 1 year, and you still get up to 40% of the discount, which is really beautiful. Apart from your cost, AWS Trusted Advisor also gives you recommendation on performance, on security, and fault tolerance. So, if you know some of your firewall routes are not as stringent as they should be, it is going to scream at you, please don't do this. If you can see here, I have some of my security groups that have instance-level firewalls, or they have unrestricted access, so I have kept it open for the entire world, and I really shouldn't be doing that. So, these are the things that AWS provides for cost optimization and for cost management in cloud. So, even before you are into the cloud, or when you have been in the cloud for a while, you can use these tools to optimize your costs on a regular basis.
A scientist has a lab far in the woods, and at one day he stumbled on a calculation that he had trouble solving, and he was very certain that his computer can handle it. And he asked his computer to do the math or the calculation for him, and the computer thought about it for a while, then took a couple of hours in trying to process the data, and eventually at one point it gave up and died due to low memory. And this old scientist is now clueless about how he was going to finish the task and complete his invention and let the whole world know about it. And that's when he was introduced to this new friend AWS, as you see on the screen. AWS was very handy in replacing his old machines, and it was able to give him the service that he wanted at that moment. AWS has been around for a while helping people with their computer needs, and now this new scientist friend in need is welcomed by the new and trendy IT technology AWS, and sure enough, his new AWS friend welcomed and walked him through the new way of computing. And this new happy-faced AWS friend talked to this scientist about AWS EC2 in specific and walked him through about all the new innovations in IT and in cloud that he had been missing all these days. So his new friend AWS started the conversation about explaining how there is no need for any hardware units, no managing hardware or provisioning in AWS. And secondly, it explained increasing and decreasing the capacity as per the demand is just a click away. And the best part here is that there is no upfront commitment and we only pay for what we have used, just like we pay electricity and water bills. And all this comes with complete control from our side. In other words, the whole key for this infrastructure is with us. And as if this was not enough, all this comes with enterprise-grade security that's beyond imagination in on-premises. And if this still does not excite you, then this definitely would. You can work from anywhere in the world. Now this really made the scientist to get excited, especially when he thought about working from home. Working from home, there is nothing like it, isn't it? Now this scientist is not tied up to a particular environment. He can work from home, work on the fly, work from anywhere. Still, the data and everything else in his IT environment is secure and safe. Now let's move to the next level of discussion. Let's talk about what is EC2 and some of the use cases of EC2. And this use case we're going to talk about, or this architecture we're going to talk about, it notifies a group of users about a new letter. And the components or resources this architecture would need be first EC2 instance, then SNS, a simple notification service, and coupling EC2 and S3 service together. That's all it would require to get an architecture that notifies a group of users about a new newsletter. And now I think it would be a good time to talk about what EC2 is. AWS offers plenty of services offered under different domains like compute, storage, database, migration, network, management tools, media services, security, business productivity, application integration, machine learning, game development, and a lot more coming up, out of which EC2 falls under the compute capacity. So what is EC2? EC2 is a web service which aims to make life easier for developers for providing secure and resizable compute capacity in the cloud. With EC2, it is very easy to scale up or scale down our infrastructure based on the demand. And not only that, this EC2 service can be integrated well with almost all the services in Amazon. And out of all this, the best part could be we only pay for what we use. Alright, let's talk about this use case. A use case here is that a successful business owner has a bunch of users and a successful product that's running, and now he has developed a few more products that he thinks will be very successful, that he thinks his customers are going to like. Now, how can he advertise his product to his new and prospective customers? Or the solution for this question can be addressed by AWS. In AWS, we can use services like Simple Notification Service, SNS, and EC2 for compute and S3 for storage. We can, in a way, integrate them all and achieve this business use case. And that sort of got this business owner very cheered up, and now he wants to use the service and he wants to get benefited from the service. He wants to advertise or he wants to notify his users every time the company creates a newsletter. Alright, so let's talk about what it would take to get this environment up and running, or what it would take to connect the environment and put the applications on top of it. Firstly, we would require an AWS account, and then for compute capacity, we would require an EC2 instance. And here's how we go about doing it. The first thing is to create an AMI, which is Amazon Mission Image. That's really the softwares and the application packages we would need to run our application. And the second is to choose the hardware. In here it's the instance type. Depending on the workload, we would be choosing the hardware, and depending on the intents of the workload, we will be choosing the size of the hardware. And finally, we would configure the instances. How many instances do I want? Which subnet do I want them in? And what's going to be the stop or terminate behavior of the instance, and do I want to update any patches when the instance starts running. All those pieces of information go in here when we configure the instance. And then the first 3 steps is really about the OS volume and the basic hardware. Now it's time to add additional storage to the EC2 instance. That would be step 4. Here we add additional storage to the EC2 instance. And then tags, we use tags, or we would configure tags to easily identify an EC2 instance at a later point. We give it some meaningful names so we can identify, like which team it belongs to, which billing department it belongs to, what's the purpose behind launching this instance, stuff like that. In an environment where we run 700 to 800 or even more instances, identifying an instance and trying to understand who owns the resource, for what purpose we created, it could be an full-time work. So tagging comes to our rescue at that time. After tagging, as step 6, we would configure the firewall, which is also called security group, for the EC2 instance. And this is where we would allow or deny connection from external world to this particular EC2 instance. Well, it works both ways, from outside and from inside out. This firewall blocks the connection based on port number and IP address. And finally, as step 7, we review all the configurations that you have done, and we make sure that the configurations is what we wanted, and finally click on submit. That's going to launch an EC2 instance. Alright, this was just an overview of how to create an EC2 instance. Now let's talk about each and every step in detail. So to begin with, let's talk about how to create an AMI. Well, the AMI is just a template that's used to create a new instance or a new computer or a new VM or a new machine based on the user requirement. The things that go into an AMI are the software, the operating system, the additional applications that get installed in it, stuff like that. The AMI will also contain software information, information about operating system, information about access permission, information about volumes. They all compact in the AMI. Again, the AMI is of 2 types. One is predefined AMIs, or called Amazon provided AMIs. The other one would be custom AMIs, the AMIs that we create. And if you're looking at a particular AMI that you don't want to create but still want to get it from Amazon, there is a place or a portal called AMI Marketplace. There we get like thousands of AMIs in there available for us to shop and use them on a pay-as-you-go business model, and use them as pay-as-you-go billing. So there you can search AMI that you're looking for. Most probably you'll be able to get it there. Now let's talk about choosing the instance type. The instance type is basically the hardware specification that's required for a machine that we're trying to build. And the instance types is categorized into 5 main families. They are, to begin with, it's compute optimized. Now compute optimized gives us lots of compute power or lots of processing power. So if my application is going to require a lot of processing power, I should be picking compute optimized instance. And the second one is memory optimized. Now this is very good for applications that require in-memory caching. There are some applications that performs well with cache or through cache, or the application would create a lot of data that it wants to keep in cache for rereading or for processing, for lengthy processing, stuff like that. For those type of application, this memory optimized instance that comes with in-memory cache is a very good use case. And the third one is the instance that comes with GPU, otherwise called GPU optimized. GPU stands for graphical process unit, and this is very good for application that deals with gaming. This is very good for application that's going to require large graphical requirements. And storage optimized is the fourth option. Just like the name says, this is a very good use case for storage servers. And the fifth family type is general purpose. Just like the name says, it's for general purpose. If you're not particular about the family, then you generally would end up picking the general purpose, because here the server services are sort of equally balanced. You'll find a balance between the virtual CPU and the memory and the storage and the network performance. It's sort of balanced. All the components, all the features that needs to go in a computer are sort of balanced in general purpose. Now these instance types are fixed and they cannot be altered because it's hardware based. We buy hardware. We do not have much control on the hardware that's being used. Well, we have options, but we do not have control on the hardware. And these instance types are divided into 5 main families. They are compute optimized, memory optimized, GPU enabled, storage optimized, and general purpose. Then as third thing, we have to configure the instance. Now here is where I have a lot of options about purchasing. What type of purchasing do I want to do? Do I want to go for a spot instance? Do I want to go for a reserved instance? Do I want to go for an on-demand instance? These are different billing options available, and that's available under configure instance. Not only that, here's where I'm going to put the EC2 instance. Do I want an public IP address assigned to it? Do I want an IAM role attached to it? IAM role is authentication. Or what kind of authentication am I going to provide? And the shutdown behavior. The shutdown behaviors include, do I want to stop the instance when the user shuts down the machine from the desktop, or do I want to simply terminate the instance when the user shuts down the instance from the desktop? So those things go in here, just like the name says, configure instance. A lot of instance configuration options comes in here. That's the third step. And not only that, under the advanced details or advanced tab under configure instance, I can bootstrap the instance with some scripts. Now bootstrap is nothing but the scripts that you want to be run in the instance before it actually comes online. Let's say you're provisioning the instance for somebody else. Instead of you launching the instance and then logging in and running some commands and then handing it over to the other person, you can create bootstrap shell scripts and paste it in a console option available under configure instance, and Amazon is going to take those commands, run it on the instance before it hands over to the user that initially requested for that instance. Now it could be a different user or just you. It sort of automates software installation procedures in the instance that we will be launching. And not only that, there are multiple payment options available under configure instance. The user can pick an instance under normal price, and that instance would apply normal rates applied to it. And there are also options like reserved instance, where the user can pay for an instance upfront before a year or before months, for a span of year or a span of months, and that way they can pay less per hour for using that instance. Not only that, you can also go for spot instance, like bidding for those instances. Whoever bids more, they get the instance for that particular time. Well, these instances are a lot cheaper than on-demand instances. And through bidding and buying, you can keep the instance as long as your bid price doesn't exceed the price that Amazon is proposing. And as the fourth step, we will have to add storage to the instance that we are about to launch. And here we have a bunch of storage options. I can go for ephemeral storage, which is free, or I can go for an external elastic block storage, also called EBS, which is paid and it's a permanent storage, or else I can integrate my EC2 instance with S3 for its storage needs. And the best part about storage is free subscription users, they get to use 30 gigabit of SSD storage or magnetic storage for the whole year. In this page where we are ready to add storage, we will have to mention or provide the size in gigabit and the volume type. Is it going to be an provisioned volume? Is it going to be an general purpose volume? Is it going to be a magnetic volume? Stuff like that. They are volume types. And we also need to give inputs about where the disk will be mounted and whether this volume needs to be encrypted or not. So all these options or all these inputs are received from us under the adding storage section. And then the fifth option would be adding tags. Like we discussed some time back, tags are very helpful to identify a machine in an environment where we have 700 or 1000 VMs running. And security groups are the actual firewall that sits in front of EC2 instance, and it protects that EC2 instance from unintended inbound and outbound traffic. Now here is where I can fine tune the access to my EC2 instance based on port numbers and based on IP address from which it can be accessed. And finally, we get to review the whole changes or the whole configurations that we have made to find out whether they are intact with the requirement, and then click on submit. That's going to launch an EC2 instance. But hold on, we're not done yet. When we're about to launch, or before the Amazon console actually launches the EC2 instance, it's going to give us an option to create a key pair. Remember, I said it's key pair. Key pair is two things. One is public and private. The private key is downloaded by the user and is kept with the user, and the public key is used by Amazon to confirm the identity of the user. So just go ahead and download the private key and keep it for yourself. And this private key gets downloaded as a .pem file. It's a format of the file, and it gets downloaded as .pem file. And our next step is to access the EC2 instance. And because the instance that we have launched in this example, let's assume it's a Linux instance, and that's going to require a tool called PuTTY to be able to access it. And this PuTTY tool is really needed when we are trying to access an Linux instance from Windows instance. Most of the time, Windows instance will have PuTTY installed in them, but in some rare cases, they do not come with PuTTY. In those cases, we can go ahead and download PuTTY and PuTTY generator, and we can start using it to access the Linux instance. Now you might ask, well, I understand PuTTY, what's PuTTY generator? Now the file that we have downloaded is in .pem format, but unfortunately PuTTY does not accept .pem format as input. It has to be converted into a different format called ppk. And PuTTY gen is a tool that helps us to convert the .pem file into ppk file. So the quick way to do it is download generator, open it up, click on conversion, and insert the .pem key that we have downloaded and save the private key. And this, when we save the private key, it gets saved as a .ppk type private key. And when that's done, the next very step is to open PuTTY and try to log in. And the way to log in is to open PuTTY, put that IP address here, and then click on auth. This is where we would input the file that we have created. So click on auth and then click on browse and find the .ppk file that we have converted and stored, browse it and upload it, and then click on open. Now that's going to open up a login screen for us. And the AMIs comes with a default username. Depending on the AMI that we have picked, the username might differ. In our case, we have picked an AMI for which the username is EC2-user, and this is the default, by the way. Let's put the username EC2-user and hit enter, and that's going to open up the Linux instance using CLI. There are a few other things that we can do with the terminal that we'll explain it a little later. Alright, so we have successfully launched an EC2 instance, and give yourself a pat on your back. Launching an instance was just one part of the solution. So let's actually talk about how we can notify our customers. SNS, or Simple Notification Service, is a service or a product in Amazon that helps us to notify customers through email. So navigate to SNS in your account and create a topic. And we're going to use this topic for public notification. So let's make it public and then add subscribers to it. Now these subscribers are the people who you want to be notified about the newsletter. So we already have the email database in there. Add them to the subscribers list, and then they will start getting new newsletters as and when we post them to the topic. And as next step, create a bucket in S3 where you can store content, and in that bucket create an event that triggers a notification to Simple Notification Service. So this is how it will be set up. A notification will be sent to our subscribers anytime we put something in our S3 bucket. So S3 bucket is going to create an event for the notification, and the notification is going to make sure that it's delivered to your end customer because they're already subscribed to the topic as subscribers. And finally, let's connect the S3 with EC2, so the bucket and the AWS instance are in sync. So we put some content in the S3 bucket, our email system notifies our customers, and the customers can go online to a website that's hosted in EC2, and because S3 and EC2 are in sync, the items that we put in S3 will also show up in EC2. See how this is all connected and it's working together. And once this is all connected, our subscribers will regularly be informed anytime we put new content in the S3 bucket, and the same content will be made available in EC2 instance through the website. So what are we going to learn? We're going to learn about what is cloud storage in general, and then the types of storage available in general in the cloud, and how things were before anybody adopted using S3. That's something we're going to learn. And then we're going to immediately dive into what is S3, and then the benefits of using S3 over other storage. And then we're going to do a couple of labs or console walkthroughs about what is object and how to add an object, what is bucket, how to create a bucket, stuff like that. And then we're going to talk about how Amazon S3 generally works. Now, it comes with a lot of features, it comes with a lot of promise. How does this all work? How does Amazon able to keep up with the promise? We're going to talk about that. And then we will talk about some features, add-on features that comes along with Amazon S3. So what is cloud storage in general? Cloud storage is a service that provides web services where we can store our data. And not only that, the data can be easily accessed and the data can be easily backed up, everything over the internet. In short, if you could store your data, if you could access the data, if you could back up your data, everything you do through the internet, then that's a good definition for cloud storage. And additional definitions are, in cloud storage we only pay for what we use. No commitment, no pre-provisioning, is pay as you go type subscription. And the best part is we pay on a monthly basis. We don't rent a hardware for the year, or we don't give commitment for the whole year. It's pay as you go and pay on a monthly basis. And these cloud storages are very reliable, meaning once you put the data in it, it's never going to get lost. And these cloud storages are scalable. Assuming I have a requirement to store 100 times of what my actual data size is, and I want it now, it's available in the cloud. And these storages are secure as well, because we're talking about data virginity. They need to be secure, and Amazon provides tools and technologies through which we can secure our data, and these are generally not found in the on-premises storage system. So let's talk about the different types of storage in general. So S3 is cloud storage in AWS, and then we have Elastic Block Store. Now, Elastic Block Store is actually the SSD hard drives that gets attached to our EC2 instance. It's like the C drive, it's like the D drive, it's like the E drive that gets attached to our instances. Now, EFS is Elastic File System. The underlying technology is kind of the same, but it differs from EBS in a way that EBS can be accessed only by the system that's attached to it, meaning the E volumes and the D volumes we spoke about. They can be accessed only if there is an instance connected to it. But these EFS are actually shared file systems, Elastic File System. Alright, they are shared systems. They can be accessed by multiple systems. They can be accessed from inside the Amazon environment. It can be accessed from on-premises equipment as well. Glacier is actually the archiving solution in the cloud. If you want to dump a data and try to keep them in the low cost as possible, then Glacier is the product we should be using. And then we have Storage Gateway. If I want to safely move my data from my local environment to the cloud environment, and also want to keep a copy of the data locally, so users locally can access them, and cloud users or internet users can access the data from the cloud. If that's your requirement, then Storage Gateway is the one we would be using. And then we have Snowball. Snowball is really an data import and export system, but it is actually an hardware that gets shipped to our premises, where we can copy our data into it and then ship it back to Amazon, and Amazon would copy the data into whatever destination we give them in our account. And if the data is really huge, then I can call for a snowmobile, which is actually a data center on a truck, where Amazon would send me a truck loaded with a data center, as you see, that has compute capacity, lots and lots of storage capacity, and electricity, AC, and a lot more. So they get come parked near our data center, and cables run into our data center. We can copy data into it, send it back to Amazon, and they would copy it to our account in whatever storage that we advise them. So if the data is really huge, then I would be calling snowmobile. Snowmobile is not available in all the regions. All right, let's take this example, how things were before S3 was introduced. Two professionals are having a conversation, and one of them is finding it very difficult to sort of manage all the data in the organization. Well, if the data is small, it can be easily managed, but as company grow, and we are living in an era where data is everything. We want data to back up every idea. We want data to back up every proof of concept that we provide. So data is everything. So this era, it's all about collecting data, analyzing them, and saving, not losing logs, saving them, analyzing, stuff like that. So coming back to our discussion here, one person finds it very difficult to store and manage all the data that they have. So some of the data that this person is having problem storing is data that application use to running, and then data that get sent to the customers, and data that the websites require, the data that are because of the email backups, and a lot more other storages that an enterprise can have. And this person is having problem backing up all those data. And even if we think of increasing the local storage capacity, that's going to cost a fortune. And few things that make it sometimes impossible to increase the storage capacity in-house is we will have to go and pay heavy to buy hardware and software to run these storages, and we need to hire a team of experts for maintaining them, the hardware and the software. And anytime if there is a dynamic increase in the storage capacity, the on-premises or in-house hardwares won't be able to scale. And data security is very costly when it comes to building our own storage environment in-house and adding data security on top of it. So the other guy in the conversation was sort of quietly listening everything the manager was saying, and then he slowly introduced him to S3, because he knew that all the problem that this manager was worried about can be solved to S3. In other words, all the scalability, all the data security, all the not being able to provision hardware and software components are all available with S3. So that actually brings us to the discussion about what S3 is. S3 is simple storage service. It actually provides an object storage service. Let me talk to you about object and block storage. Object storage is where you can store things and retrieve. All right, you can't install anything in it, and this object storage can be accessed directly from the internet, whereas block storage is something that needs to be attached to an instance, and we can't directly access it, but we can install software in it. So that's a high level difference between object storage and block storage. And S3 is an object storage. What does that mean? We can store data from the internet, we can retrieve from the internet, but we can't install anything in S3. All right, so S3 is an object-based storage, and it's really built for storing and recovering or retrieving any amount of data or information from anywhere in the internet. Few other things you need to know about S3 is that this S3 is accessible through the web interface. The storage, one type of accessing or one way of accessing S3 is by dragging, dropping content into it, and another way of retrieving data from S3 is go to a browser, click on download. That's going to let you download any content, and the data can be 5 terabytes in size. Now we're talking about one file. You can have hundreds or thousands of files like that. One file can be as big as 5 terabytes in size. And S3 is basically designed for developers, where they can push logs into S3 or retrieve logs anytime they want instead of storing locally in the server. They can use S3 as code repositories, where they can save the code and have the applications read the code from there, and a lot more. If they want to safely share the code with another person with a lot of encryption and security added on top of it, that's possible as well. So there are a few things about S3, and on top of all this, S3 provides 11.9 durability and 4.9 availability. Meaning durability is, if I store the data, will it get lost? Amazon is like, no, it's not going to get lost. You're going to have the data because we provide 11.9 durability for the data. And availability is, if you want the data now, will you be able to show it? Amazon is like, yes, we will be able to show it. We have 99.99% availability, and when you request the data, we will be able to show the data to you. Alright, so let's talk about the benefits of S3. S3 is durable. As we saw, it provides 11.9 durability. S3 is low cost. Out of all the storage options in Amazon, S3 is the cheapest, and S3 is very scalable. Like we were saying, there's no required to pre-provision a storage capacity. If you need more, go ahead and use more. If you need even more, go ahead and use even more. And once you're done, some data needs to be removed, just remove the data. So that particular month you will be paying less. So it's very scalable in nature, and it's very available as well. S3 is a regional service. It's not based on one availability zone. So one availability zone going down within Amazon, the whole availability going down, it's not going to affect your ability to access S3 storage. And S3 is secure. A lot of security features like bucket policy, a lot of security features like encryption, and then MFA authentication are possible with S3 that actually adds a very good security layer on top of the data that we have stored in S3. And not only that, this S3 is very flexible in terms of cost, flexible in terms of where I want to store the data. In terms of cost, there are a lot of pricing tiers within S3. S3 itself is a cheap service. Now within that, we have a lot of pricing tiers depending on the durability. So I can always choose to put data on a different storage tier or storage option in S3. We're going to talk about it as you stick along. And in terms of flexibility in region, I can always choose any of the region available in the console or in the S3 console to put my data to. There is no restrictions on where I can or cannot put the data in the cloud, as long as there are regions available for me to move the data to. And data transferring with S3 is very simple. All I have to do is browse to the bucket, upload the data, and the data gets uploaded. And we can also upload data using CLI. Commands are very similar to Linux. Commands are very similar to what we would use in the run command prompt in Windows, and what we would use in the run command prompt in the PowerShell. Alright, let's talk about a basic building block of S3, which is bucket and objects. Now what's a bucket? What's an object? Object is the actual data, and bucket is the folder where the objects get stored. Let me give you a new definition for object. So object is the actual data plus some information that reference the data, like is it an JPEG file, the name of the file, and at what time it was added to. So they're called metadata. Alright, so object is actually data plus metadata, and bucket is actually a container that receives the data and safely stores in it. And when we add a data in a bucket, Amazon S3 creates an unique version ID and allocates it to the object so we can easily identify it at a later point. Let me show you a quick lab on S3. Alright, I'm in the S3 console. If you're wondering how I reached here, go to services, under storage, and S3 is right here. And let's create a bucket called Simplilearn. Now the bucket names will have to be unique. So I really doubt if Simplilearn will be available. Let's check it anyway. All right, it doesn't seem to be available. So let me pick another name, or let's call it simplylearn.samuel.com, and I'm going to put this in Mumbai, or I can choose Oregon. Let me choose Oregon. Yes, let me choose Oregon. And let me create a bucket. Sure enough, a bucket got created. Let me upload an object into the bucket. And you know, these objects can be as big as 5 terabytes. We talked about it, right? All right, let me upload an object. All right, so that's my object. So you get the relation, right? Here's my bucket. All right, here's my bucket, and within that is my object. Now, object is the actual file plus what type of file it is, and then the size of the file, the date in which it got added, and the storage class it is in at the moment. So if I have to access it, I can simply access it through the internet. So let's talk about how does this S3 bucket work anyway. Alright, so how does it work? A user creates a bucket. They will specify the region in which the bucket should be deployed. We had an option. We could have chosen to deploy in all the regions Amazon provides S3 service. You know, be it North Virginia, be it Mumbai, be it Tokyo, be it Sydney, be it Oregon. And we chose Oregon to be the destination region where we want to create a bucket and save our data there. And when we upload data into the bucket, we can specify 3 types of storage classes. In our case, we picked the default, which was S3 standard. As we saw on the object data, it was on S3 standard. So that's the basic thing. Later, once the object gets added, we can always add bucket policies. You know, policies define who access it and who should not access it. What can they access? Are we going to allow users only to read or to write as well? Stuff like that. So that's bucket policy. We're defining the life cycle or the lifespan of the data in the S3 bucket. Now, over the time, do you want the data to automatically move to a different storage tier? And at any point, do you want to sort of expire the data, you know, get the data flushed out of your account automatically? You know, those things can be configured in lifecycle policies. And version control is creating multiple versions. If you're going to use S3 for a code repository, creating multiple versions. Let's say if you want to roll back to whatever you had before a month, how are we going to do it if you kept updating the file and never took a version of it? So version control helps us to keep different versions, and it helps us to roll back to the older version anytime there is a need. So let's talk about the different storage classes in S3. The different storage classes in S3 begins with S3 standard. Now this is the default, and it's very suitable for use cases where you need less or low latency. For example, if you want to access the data of a student's attendance, you would retrieve them very quickly as much as possible. So that's a good use case to store data in S3. Let's understand the different storage classes in Amazon S3. Now let's take a school, for example, and the different data present in a school, and the features of those data, the validity of the data. Alright, so let's take this example, and there are different storage options in S3. Let's take S3 standard for example, and what would be the actual candidate data that can be stored in S3 standard. Let's talk about that. So S3 standard in general is suitable for use cases where the latency should be very low, and in here the good example or the good candidate file that can be stored in S3 is data that needs to be frequently accessed and that needs to be retrieved quickly. Something like students' attendance report or students' attendance sheet, which we access daily, and then it needs to be retrieved immediately as and when we need it. The other type of storage tier in S3 is infrequent access or infrequent data access. Just like the name says, the use case for that is less frequently accessed data. I mean, the candidate data that should go in infrequent access data is a student's academic record, which we don't need to access on a daily basis, but if there is a requirement, we might want to go and look at it, and that's going to be quick. So it's not a data that we would access on a daily basis, but it's data that needs to show up on your screen real quick. And the third option is Amazon Glacier. Now, Glacier is really an archival solution in the cloud. So for archives, high performance is not a requirement. So let's talk about some candidate data that can go into archives. Something like students' admission fee, and it's not critical also. Now, anytime if you want to look at the data, you can always wait to retrieve the data. So in other words, put it in the archive, and retrieving from the archival takes time. So students' old record are a good candidate to be put in the archives. The other options are one zone IA storage class, where the data is infrequently accessed and the data is stored in a single availability zone. For example, by default, Amazon stores data in multiple availability zones, and there is a charge for that. Now, it's not an option, but the charge includes storing data in multiple availability zones. But if your data requirement is you want to keep the charges low even further, you can choose a one zone IA storage class where it stores data in one availability zone. And the candidate data that can go in one zone infrequent access is student's report card. And the other option with Amazon S3 is standard reduced redundancy storage. It is suitable for cases where the data is not critical and the data can be reproduced quickly. For example, take a copy of the library book, take a copy of the PDF library book, for example. Now, we would have a source PDF and we would make copies of it, and then we make it available for the readers to read. The other option in S3 is reduced redundancy storage. Here the use case is data that's not critical and data can be reproduced quickly. For example, books in the library are not that critical and we always have a copy of the book. We're talking about PDF. So if the customer facing or the student facing book gets deleted, I can always copy the same PDF, put it in the destination folder and make it available for the users to read. That would be a very good use case for reduced redundancy storage. All right, let's summarize everything that we learned about different storage options in S3. So S3 standard, it's for frequently accessed data. It's the default storage. If you don't mention anything, the data gets stored in S3 standard. It can be used for cloud applications, content distribution, gaming applications, big data analytic, dynamic websites. They are a very good use case for S3 standard frequently accessed data. The other one, on the contrary, is S3 standard infrequently accessed data. Just like the name says, the use case is this is good for data that will be less frequently accessed, and then the use case are it's good for backups, it's good for disaster recovery, and it's good for lifelong storage of data. Glacier, on the other hand, is very suitable for archiving data which is infrequently accessed, and the vault lock feature is the security feature of the Glacier that also provides a long-term data storage in the cloud. This is the lowest storage tier within S3. The other options are one zone infrequent access storage class. Just like the name says, it's infrequently accessed and it is stored in just one availability zone. And use cases are any data that doesn't require any high level of security can be stored here in one zone. The fifth storage tier is reduced redundancy storage. This is good for data that's frequently accessed. It's good for data that is non-critical and that can be reproduced if it gets lost. And reduced redundancy storage, or RRS, is an highly available solution designed for sharing or storing data that can be reproduced quickly. Alright, let's compare and contrast a couple of other features that are available in S3. For example, durability, availability, SSL support, first byte latency, and lifecycle management. So in standard, the durability is 11.9 durability. It's the same for standard IA, one zone IA, Glacier, except for reduced redundancy, the durability is 11.9. And availability of all the storage classes is all the same, except for one zone IA, where the availability zone is 99.5%. All of these products support SSL connection, and the first byte latency of these products are, most of them provide access with millisecond latency, except for Glacier. It provides a retrieval time of couple of minutes to a maximum of hours, and all of them can be used for a lifecycle management, moving data from one storage tier to another storage tier. That's possible with all of these storage options. Alright, now that we've understood the different types of storage options available in S3, let's talk about some of the features that are available in S3. Lifecycle management. Now, lifecycle management is a service that helps us to define a set of rules that can be applied to an object or to the bucket itself. Lifecycle is actually moving the data from one storage tier to another storage tier and finally expiring it and completing the life cycle of the object. With lifecycle management, we can manage and store our objects in a very cost-effective way. It has two features basically: transition actions and expiration actions. Let's talk about transition actions. With transition action, we can choose to move the objects or move the data from one storage class to another storage class. With lifecycle management, we can configure S3 to move our data from one storage class to another storage class at a defined time interval or at a defined schedule. Let's talk about transition actions in more detail. Let's say we have our data in S3 at the moment and we haven't used the data for quite some time, and that's how it's going to be for the rest of the time. So that data is a very good candidate to move to the infrequent access, because S3 standard is a bit costlier and S3 infrequent access is a bit cheaper than S3 standard. So the kind of usage sort of fits very well for moving that data into infrequent access. So using lifecycle transition or lifecycle management, I can move the data to S3 infrequent access after 30 days. And let's say that the data stayed in infrequent access for 30 more days, and then now I realize that nobody is looking into the data. So I can find an appropriate storage tier for that particular data again, and I can move it to that particular storage tier, which is Glacier. So in this case, after 30 days or in a total of 60 days from the time the data got created, the data can be moved to Glacier. And what does this really help us with? The lifecycle management helps us to automatically migrate our data from one storage cost to another storage cost, and by that it really helps us to save the storage cost. Lifecycle management can also help us with object expiration, meaning deleting the object or flushing it out after a certain amount of time. Let's say that our compliance requirement requires that we keep the data for 7 years, and we have like thousands and thousands of data like that. It would be humanly impossible to check all those or keep track of all the dates and when they need to be deleted, stuff like that. But with lifecycle management, it is very much possible. I can simply create a data and set up lifecycle management for the data to expire after 7 years, and exactly after 7 years the data is going to expire, meaning it's going to be deleted automatically from the account. Alright, let me show you a lab on lifecycle management and let me explain to you how it's actually done. So I'm into the bucket that we have created, and here's our data into the bucket. Assume we have thousands and thousands of data in the bucket, and that requires to be put in a different storage tier over time, and that requires to be expired after 7 years, let's say. So the way I would create a lifecycle management is go to management from inside the bucket and click on lifecycle, and then add a lifecycle rule. just give it a name like expire. So all the objects that's present in this bucket, meaning the current version of it, set a transition for it. So the transition is, at the moment they are in S3. So here I would like to put them in infrequent access after 30 days. And then after it's been in infrequent access for 30 days, I would like to move it to Glacier. All right, plus 30 days. So how do you read it? So for the first 30 days, it's going to be in Glacier. So how do we actually read it? So after I put the data in S3, the data is going to get moved to standard IA, and then it's going to stay in standard IA, and after 60 days from the data creation, it's going to get moved to Glacier. So on the 31st day, it's going to move to standard IA. On the 61st day, it's going to move to Glacier. Let's say if I want to sort of delete the data, if I want the data to get deleted automatically after 7 years, being in a Glacier, how do I go about doing it? Let me open up a quick calculator. 365 into 7, that's 2,555 days. Right after that, the data is gonna get deleted. Pretty much, I have created a life cycle. So on the 31st day, it's going to get moved to infrequent access, and on the 61st day, Glacier, and after 7 years is over, any data that I put in the bucket, it's going to get deleted. All right, let's talk about bucket policies. Bucket policies are some permission files that we can attach to a bucket that allows or denies access to the bucket based on what's mentioned in the policy. So bucket policy is really an IAM policy where you can allow and deny permission to an S3 resource. With bucket policy, we can also define security rules that apply to more than one file in a bucket. Now, in this case, we can create an user, or let's say there's already a user called Simplilearn. We can allow or deny that user connection to the S3 bucket or connecting to the S3 bucket using bucket policy. And bucket policies are written in JSON script. And let's see how that's done. All right, there are tools available for us to help us create bucket policies. What you're looking at is a tool available online that helps us to create a bucket policy. So let's use this tool to create a bucket policy. I'm going to create a deny statement. I'm going to deny all actions to the S3 bucket. And what is the ARN to which we want to attach? The ARN of the resource is actually the name of the bucket, but it really expects us to give that key in a different format. So the ARN is available right here, copy bucket ARN. So this is actually going to deny everybody. Now we wanted to deny a user, just one user. Now look at that. Now we have a policy that has been created that's denying access to the bucket, and it's denying a user called Simplilearn. Pretty much done. So I can use the policy and go over to bucket policies. So once I save it, only the user called Simplilearn won't have access to the bucket, and the rest of them will have access to it. So once I save it, it gets added, and only the user Simplilearn will not have access to the bucket because we're denying them purposefully. The other features of S3 include data protection. We can protect our data in S3 with now one of which is bucket policy. I can also use encryptions to protect my data. I can also use IAM policy to protect my data. So Amazon S3 provides a durable storage. Not only that, it also gives us a protected and scalable infrastructure needed for any of our object storage requirements. So here the data is protected by two means. One is data encryption and the other one is data versioning. Data encryption is encrypting the data so others won't get access, or even if they get access to the file, they won't be able to access the data without the encryption key. And versioning is making multiple copies of the data. So let's talk about them in detail. What's data encryption? Now, data encryption refers to protecting the data while it is being transmitted and protecting the data while it is at rest. Now, data encryption can happen in two ways. One is client encryption, encryption at rest, and server-side encryption, encryption that's in motion. Client-side encryption refers to when client sends the data, they encrypt the data and send it across to Amazon. And server-side encryption is when the data is being transferred, they get encrypted and stay encrypted throughout the transfer. Versioning is another security feature. It helps us so our unintentional edits are not actually corrupting the data. For example, let's say you edited the data and now you realize that the data is incorrect and you want to roll back. Now, how do you roll back? Without versioning, it's not possible. In other words, only with versioning, it's possible. So versioning, it can be utilized to preserve, recovery, and restore any early versions of every object that we stored in our Amazon S3 bucket. Unintentional erases or overwrites of the object can be easily regained if we have versioning enabled. And it's possible only if we have one file with the same key name, and anytime we update the file, it keeps the file name but creates a different version ID. Take this bucket and data for example. Photo.pmg is a file that was initially stored. It attached a version ID to it, and then we edited it. Let's say we added some watermark, we added some graphic to it, and that's now the new version of it. When we store it with the same file name. It accepts the same file name but creates a new version ID and attaches it. Anytime we want to roll back, we can always go to the console, look at the old versions, pick the version ID, and roll back to the old version ID. All right, let's take this example. Now, I'm in a bucket that we've been using for a while, and let me upload an object. Now, before we actually upload an object, this bucket needs to be versioning enabled. So let me version enable this bucket. From this point onwards, this bucket is going to accept versioning. So let me upload an object, photo.jpg. Let me upload it. All right, it successfully got uploaded. Good enough. It's uploaded. Now, let me upload another object with the same file name. Now look at that. It was uploaded at 7:35 a.m. Let me upload another object with the same file name that I have it stored right here. That got uploaded but with the same name. Alright, so that's the other photo. Now what if I want to switch back? The way I would switch back is simply switch back to the older version. Look at that. This is the latest version and this is the old version that I have. I can simply switch back to the old version that was created at such and such time, and I can open it. That's going to open the old file. So in short, it creates different version of the data that I create as long as it's with the same name, and at any point I can go and roll back to the original data. This is a very good use case if you want to use S3 for storing our codes. Let's talk about other feature like cross-region replication. Now, cross-region replication is a very cool feature if you want to automatically keep a copy of the data in a totally different region for data durability, for any additional data durability, or if you want to serve data to your customers who live in another country or who are accessing your data from another country. If you want to serve the data with low latency, cross-region replication is a very cool feature that you can use and get benefited from. And let's see how that's done. So before we actually do a lab on cross-region replication, let's put together a proper definition for it. Cross-region replication is a feature that provides automatic copying of every object uploaded to our bucket or your bucket, source bucket, and it automatically copies the data to the destination bucket, which is in a different AWS region. As you see here in the picture, I put data only in region 1. It's going to copy the data to region 2. And for us to use cross-region replication, versioning must be turned on. So it creates versions and copies the versions as well. If tomorrow the original region goes down, let's say the other region will be active and it has the complete data that was present in the original region. Or at any point, if we want to simply cut the region replication and use the other bucket as a standalone bucket, it can be used as well, because it already has all the data that was present in the master or all the data that was present in the original replication bucket. Let's see how that's done. So there are two things needed. One is versioning and another one is role. When we transfer data from one bucket to another bucket, we need proper permissions to do so, and these roles, they give us proper permissions to transfer data from one bucket to another bucket. Let's see how that's done. Right, so here's my bucket, a bucket in US Oregon. Let's create another bucket in Mumbai. Call it .mumbai.com and put it in Mumbai, or create that bucket in Mumbai. There you go. We have one in Oregon, we have one in Mumbai. We're planning to replicate or create replication between these two, right? Create replication between these two buckets. So go to the first bucket, go to management and start a replication. Add a rule. So all content in this bucket is going to get replicated. This is my source bucket. It's quite simple. Select the destination bucket. Now my destination bucket is going to be simplylearn.samuel.mumbai.com. All right, it says, well, you have versioning enabled in your source bucket, but not on your destination bucket. Do you want to enable it now? Without which we won't be able to proceed further. So let's go ahead and enable versioning through the console. That shows up. And then, like I said, it's going to require permission to put data onto the other bucket. Now I can create different roles. These are different roles that are used for different other services. I can also choose to create a role that specifically gives permission only to move the data from one bucket to another bucket. Pretty much it's done. So if I go over to my source bucket and if I add some data to it, let's say index.html, assuming I'm adding some files to it, in theory they should move to the other region automatically. There you go. I'm in the Mumbai region and the datas, they got moved to the other region automatically. Let's talk about the other feature called transfer acceleration. Now it's a very handy and a helpful tool or a service to use if we are transferring data which is very long distance from us, meaning from the client to the S3 bucket. Let's say from my local machine, which is in India, if I transfer the data over to Oregon, let's say, it's a long distance. If it is going to go through the internet, it's going to go through high latency connections, and my transfer might get delayed. If it is an 1 gigabit file, it's okay. But if we're talking about anything that's 5 terabyte size, if you're talking about anything that's a 5 terabyte in size, then it's not going to be a pleasant experience. So in those cases, I can use transfer accelerator, which in a secure way, but in a fast way or a fastest way, transfers my data from the laptop or from client to the S3 bucket. And it makes use of a service called CloudFront to transfer or to enable the data acceleration. So the way it would do it is, instead of copying the data directly to the location, instead of copying the data directly to the destination bucket, it copies the data locally into a CloudFront location, which is available very local to whatever place we are in, and from there it copies the data directly to an S3 bucket, not going through the internet. It helps eliminate a lot of latency that could get added when transferring the data. So let's see how that's done. Right here, I'm in the S3 bucket, and under properties I can find transfer accelerator, and if I enable transfer accelerator, so I'm in another bucket. Let me go to properties and let me go to transfer accelerator and enable transfer accelerator. So now if I put data into this bucket, they're going to get copied to the local CloudFront location, and from there they're going to get copied to the S3 bucket from the CloudFront. Now if I need to compare how the speed is going to be compared to directly putting the data to the internet and using CloudFront, there is a tool available that actually runs for a while and then comes with a report that tells me how much will be the improved speed if I use transfer accelerator, and it shows for all the regions available in Amazon. So from the source to the destination, if you want to put what's the normal and what's the accelerated speed when you transfer the data, those results we will get in the screen. So at the moment this tool is going through its testing, like uploading some file through the internet and uploading some file using CloudFront, and it has come up with the calculation that if I'm uploading file to San Francisco, Compared to uploading through the internet and through CloudFront, it's 13 times faster. So similar way, it's going to calculate for all the regions available and it's going to give me a result. Growing company, there was discussion going on between two IT personnel. It was about the new role that his colleague Jessica has taken. Benjamin, the guy standing here, wants to know about it. And Jessica's job is new, different, and dynamic and interesting too. She scale and manage servers and operating systems and apply security patches onto them and monitor all of these at the same time to ensure the best quality for application is given to the users. And Benjamin was awestruck with the amount of work Jessica is doing and with the time it would take to complete all of them. But Jessica, being a very dynamic person, very suitable for the job, said it was easy for her to handle all of it and even more. But that easiness on the job did not last longer. As the environment grew more and more, it being a startup company, Jessica was getting drained and was not really happy about all her job as she used to be. Jessica's manual way of scaling an environment did not last long, and she was also finding out that she missed to scale down some of the resources and it's costing her a lot. She needs to pay for the service that she was not at all using. She sort of felt that she was at the end of the road and there was no way out from this manual task. She was very desperate. And that's when Benjamin suggested something, and that brought back the peace and joy Jessica initially had. Benjamin suggested about a service called Lambda that can ease the work that Jessica is doing at the moment. And Lambda, as happy as it looks like, it's a solution that solves the manual, repetitive work and lot more. And Lambda introduced itself as the problem solver and started to explain the following things, the very same thing that we're going to learn about in this series. So in this section, we're going to learn about the features of AWS Lambda, and we're going to talk about what Lambda is, and then we're going to talk about where Lambda is being used in the IT or in the cloud environment as we speak, and then we're going to talk about how Lambda works and some use cases of Lambda, and we're going to be particularly discussing about the use case about automatically backing up the data that's put in the cloud storage. Let's talk about Lambda in detail. Lambda automatically runs our code without requiring us to provision or manage servers. Just write the code and upload it to Lambda and Lambda will take care of it. That means that we don't require any server to run or to manage, and all you need to do is write the code and upload it to Lambda and Lambda will take care of it. Which also means that we can stop worrying about provisioning and managing servers. The only thing Lambda expects from you is a code that's working. AWS Lambda also automatically scales our application by running code in response to each trigger. Our code runs in parallel and processes each triggers individually, scaling precisely with the size of the workload. Scaling here is done automatically based on the size of the workload. Lambda can scale the application running the code in response to each and every trigger that it receives. Billing in Lambda is metered on the seconds. We only pay for the amount of time that our code is running, which means that we're not charged for any of the servers. The only payment required is for the amount of time the code is computed. With AWS Lambda, we are charged for every 100 milliseconds. We are actually charged for 100 milliseconds our code executes and the number of times our code is triggered, and we don't pay anything when the code is not running. Let's talk about what is AWS Lambda. Now, Lambda is one of the services that falls under the compute section or the compute domain of services that AWS provides. Along with EC2, EBS, Elastic Load Balancer, Lambda is also a service that comes under the bigger umbrella of compute services in AWS. And Lambda allows us to execute code for any type of application. With AWS Lambda, we can run code for virtually any type of application or backend services. All we need to do is supply our code in one of the languages that AWS Lambda supports. As we speak, the languages that are supported by AWS Lambda are Node.js, Java, C#, Go, and Python. And Lambda can be used to run code in response to certain events from other services. And based on the event, it can run functions, and those functions can be of Node.js, Java, C#, etc. Now let's talk about where is Lambda used. There are a huge number of use cases for Lambda, and there are many ways AWS Lambda is used specifically in the business world. Let's talk about some of them. One use case is AWS Lambda is used to process images when it is uploaded in an S3 bucket. Let's say the object gets uploaded in an S3 bucket in a format that we don't expect it to be, which means the file needs to be formatted. So it gets uploaded in a raw format, and AWS Lambda is triggered anytime a new object is added to the bucket, and the images are processed and converted into thumbnails based on the devices, the other end device that would be reading the data. It could be an PC, it could be an Apple machine, it could be an Android phone, it could be an Apple phone, it could be a tablet, whatnot. So based on the devices, different formats, Lambda can get triggered and convert the video or convert the picture into the different format that it requires. Another use case for Lambda is to analyze the social media data. Let's say we're collecting the hashtag trending data, and the data is received and it's added into the Kinesis stream to feed into the Amazon environment, and Lambda action get triggered and it receives the data, and then the data is stored into the database, which can be used by businesses for later analysis. And some of the companies that have gotten tremendous benefit using Lambda are Thomson Reuters, Benchlinks, Nordstorm, Coca-Cola, Robot are some of the companies to name at the moment that have received tremendous amount of benefit by using Lambda. Let's look at how Lambda works. In other words, let's look at how the complicated function behind the scenes work in a simple and in a seamless way. So here clients send data. Now clients send data to Lambda, and clients could be anyone who's sending request to AWS Lambda. It could be an application or other Amazon Web Services that's sending data to the Lambda. And Lambda receives the request, and depending on the size of the data or depending on the amount or volume of the data, it runs on the defined number of containers. If it is a single request or if it is less request, it runs on a single container. So the requests are given to the container to handle, and the container which contains the code the user has provided to satisfy the query would run. And if you're sort of new to containers, then let me pause here for a while and explain to you what container is. Now, container image is a lightweight, standalone, executable package of a piece of software that includes everything needs to run it, like the codes, the runtimes, the system tools, the system libraries, and any other settings needed. And it is at the moment available both on Linux and Windows based application, and containerized software will always run the same regardless of the environment it's running on. And containers isolate software from its surrounding. For example, there could be difference between a development and staging environment, so that's sort of isolated, and this helps in reducing the conflict between the teams running different software on the same infrastructure. Alright, now that we know containers needed to understand Lambda, so if there are few requests, it sends to a single container, but as and when the request grows, it actually creates multiple containers, shares the multiple requests to the different containers there. And depending on the volume, depending on the size, depending on the number of sessions, the more number of containers are provisioned so to handle those requests. And when the requests reduce, the number of containers reduce as well, and that helps in saving costs. We're not running any resources and paying for it when we're not using them. And in fact, we're not at all paying for the resources. We're only charged for the amount of time a function is running inside these containers. Now consider a situation where you have to set up a temporary storage and as a system to back up the data as soon as the data is uploaded, which is a near real-time backup. Now, a near real-time manual backups are nearly impossible, and they're not that efficient too. A near real-time manual backups, that's what the business demands, but that's not near real-time backup. That too a manual one, that's not at all efficient. Even if we come up with a solution of manually backing up close to near real time, that's not going to be efficient looking at the amount of data that will be put in and looking at the random times the data will be put into the source bucket. and there is no way we can do a manual backup and keep it as real as possible. But if that's still your requirement, we can use AWS Lambda and set things up so AWS Lambda manually handles the backup. In other words, for an impossible or a difficult situation like that, AWS Lambda comes for the rescue. And this is what we do. Create a two S3 bucket. One would be the source bucket where the data will be uploaded, and the other one is a destination bucket where the data will be backed up from the source bucket. And for these buckets to talk to themselves, it's going to require an IAM role. And then for the automatic copy, it's going to require an Lambda function to copy the files from the source bucket to the destination bucket. And what triggers the Lambda function? The Lambda function is triggered every time there's a change in the metadata for the bucket, and this data is then uploaded into the destination bucket. And after setting all this up, we can literally test it by putting a data in the source bucket that's going to automatically replicate, or that's going to automatically copy the data from the source bucket to the destination bucket. All right, let's see how we can replicate data between two buckets. Well, we have a feature to cross-region replicate in S3. That's a feature that comes along with S3. What if you want to replicate between two different buckets in two different accounts? In those cases, we can use Lambda to replicate the data between the buckets. So you put one data, or you put data in the source bucket, and that data gets replicated to the destination bucket. And let's see how that's done. The procedure here would be to have two buckets to begin with, and then create an IAM role that lets you access to pull data from the source bucket and put data on the destination bucket, and then create Lambda files or Lambda event or triggers to actually look for event in the source bucket, and anytime a new data gets added, Lambda gets triggered, copies the data from the source bucket and moves the data to the destination bucket, and it uses the IAM role and policy for the needed permissions. And in just a couple of clicks, we have set up a temporary backup system that can run seamlessly without any manual intervention, and that can be as near real time as possible. Alright, that's the concept, and let's see how it is done real time through this lab. So to begin with, we need two buckets. So I have here a source bucket and a destination bucket, and the source bucket as of now do not have any data in it, so as the destination bucket. Alright, so that's one down. The second would be to create an IAM role. Alright, so let me create an IAM role, and the role is going to have this policy in it. A policy that's allowing get object on the source bucket, and a policy that's allowing put object on the destination bucket. And here I'm going to use, or I'm going to paste my source and destination buckets ARN. Alright, go to services, go to S3, source bucket. Alright, click on the source bucket and copy the bucket ARN. So that would be the source bucket ARN. Right, on the destination bucket, copy the destination bucket ARN, and this is going to be my destination bucket ARN. So with this, I'm going to create a policy. All right, go to IAM and create a policy. Now I have already created a policy with the same information. All right, destination bucket ARN, and a policy is available with the name S3 bucket copy Lambda. Attach the policy to the role. Right, go to roles, create a role. Lambda is the service that's going to use it. In here, attach the policy that we have created. Right, give it a name, and then create a role. Now I have a role created as well. Right, copy Lambda, and that's having the policy that we have created sometime back. Now create a Lambda function. Right, so go to Lambda, create a function, give it a name like S3 bucket copy. Right, choose the role that we want to use. Right, that's the role that we want to use. Copy 1, 2, create a function. All right, and in here we're going to use Node.js code. Right, I have a sample code This can be used as template. In here, replace the source bucket with the name of the source bucket and the destination bucket with the name of the destination bucket. This is a Node.js code that gets run when an event gets triggered. Now, what's an event? Anytime there is a new object placed in the S3 bucket, it creates an event, and the event triggers Lambda, and Lambda checks the source S3 bucket, picks the data, puts it in the destination bucket. All right, paste it here. Paste it here and click on save. All right, now before you click on save, just ensure that you have the appropriate roles defined. That's all you got to do. Click on save. All right, now I already have created a Lambda function, all right, which is the same thing, same code, and the role is attached to it. Now it's running, it's active. Now let's put this to test. Go to S3, pick the source bucket, put some data in it, all right, and in theory those data should be present in the destination bucket as well. There you go. It's all done by Lambda.
Hi, this is the 4th lesson of the AWS Solutions Architect course. Migrating to the cloud doesn't mean that resources become completely separated from the local infrastructure. In fact, running applications in the cloud will be completely transparent to your end users. AWS offers a number of services to fully and seamlessly integrate your local resources with the cloud. One such service is the Amazon Virtual Private Cloud. This lesson talks about creating virtual networks that closely resemble the ones that operate in your own data centers, but with the added benefit of being able to take full advantage of AWS. So let's get started.
In this lesson, you'll learn all about virtual private clouds and understand their concept. You'll know the difference between public, private, and elastic IP addresses. You'll learn about what a public and private subnet is. And you'll understand what an internet gateway is and how it's used. You'll learn what route tables are and when they are used. You'll understand what a NAT gateway is. We'll take a look at security groups and their importance, and we'll take a look at network ACLs and how they're used in Amazon VPC. We'll also review the Amazon VPC best practices and also the costs associated with running a VPC in the Amazon cloud.
Welcome to the Amazon Virtual Private Cloud and Subnet section. In this section, we're going to have an overview of what Amazon VPC is and how you use it. And we're also going to have a demonstration of how to create your own custom virtual private cloud. We're going to look at IP addresses and the use of elastic IP addresses in AWS. And finally, we'll take a look at subnets, and there'll be a demonstration about how to create your own subnets in an Amazon VPC.
And here are some of the terms that are used in VPCs. There's subnets, route tables, elastic IP addresses, internet gateways, NAT gateways, network ACLs, and security groups. And in the next sections, we're going to take a look at each of these and build our own custom VPC that we'll use throughout this course. Amazon defines a VPC as a virtual private cloud that enables you to launch AWS resources into a virtual network that you've defined. This virtual network closely resembles a traditional network that you'd operate in your own data center, but with the benefits of using the scalable infrastructure of AWS. A VPC is your own virtual network in the Amazon cloud, which is used as the network layer for your EC2 resources. And this is a diagram of the default VPC. Now there's a lot going on here, so don't worry about that. What we're going to do is break down each of the individual items in this default VPC over the coming lesson. But what you need to know is that a VPC is a critical part of the exam. and you need to know all the concepts and how it differs from your own networks. Throughout this lesson, we're going to create our own VPC from scratch, which you'll need to replicate at the end of this so you can do well in the exam. Each VPC that you create is logically isolated from other virtual networks in the AWS cloud. It's fully customizable. You can select the IP address range, create subnets, configure route tables, set up network gateways, define security settings using security groups, and network access control lists. So each Amazon account comes with a default VPC that's pre-configured for you to start using straight away, so you can launch your EC2 instances without having to think about anything we mentioned in the opening section. A VPC can span multiple availability zones in a region. And here's a very basic diagram of a VPC. It isn't this simple in reality. And as we saw in the first section, here's the default Amazon VPC, which looks kind of complicated. But what we need to know at this stage is that the CIDR block for the default VPC is always a 16 subnet mask. So in this example, it's 172.31.0.0/16. What that means is this VPC will provide up to 65,536 private IP addresses. So in the coming sections, we'll take a look at all of these different items that you can see on this default VPC. But why wouldn't you just use the default VPC? Well, the default VPC is great for launching new instances when you're testing AWS. But creating a custom VPC allows you to make things more secure, and you can customize your virtual network as you can define your own IP address range. You can create your own subnets that are both private and public, and you can tighten down your security settings. By default, instances that you launch into a VPC can't communicate with your own network. So you can connect your VPCs to your existing data center using something called hardware VPN access, so that you can effectively extend your data center into the cloud and create a hybrid environment. Now to do this, you need a virtual private gateway, and this is the VPN concentrator on the Amazon side of the VPN connection. Then on your side, in your data center, you need a customer gateway, which is either a physical device or a software application that sits on your side of the VPN connection. So when you create a VPN connection, a VPN tunnel comes up when traffic is generated from your side of the connection. VPC peering is an important concept to understand. A peering connection can be made between your own VPCs or with a VPC in another AWS account, as long as it's in the same region. So what that means is, if you have instances in VPC A, they wouldn't be able to communicate with instances in VPC B or C unless you set up a peering connection. Peering is a one-to-one relationship. A VPC can have multiple peering connections to other VPCs, but, and this is important, transitive peering is not supported. In other words, VPC A can connect to B and C in this diagram, but C wouldn't be able to communicate with B unless they were directly peered. Also, VPCs with overlapping CIDRs cannot be peered. So in this diagram you can see they all have different IP ranges, which is fine, but if they had the same IP ranges, they wouldn't be able to be peered. And finally for this section, if you delete the default VPC, you have to contact AWS support to get it back again. So be careful with it and only delete it if you have good reason to do so and know what you're doing. This is a demonstration of how to create a custom VPC. So here we are, back at the Amazon Web Services Management Console. And this time we're going to go down to the bottom left where the networking section is. I'm going to click on VPC. And the VPC dashboard will load up. Now there's a couple of ways you can create a custom VPC. There's something called the VPC wizard, which will build VPCs on your behalf from a selection of different configurations. For example, a VPC with a single public subnet, or a VPC with public and private subnets. Now this is great because you click a button, type in a few details, and it does the work for you. However, you're not going to learn much or pass the exam if this is how you do it. So we'll cancel that and we'll go to your VPCs. and we'll click on Create a VPC. And we're presented with the Create a VPC window. So let's give our VPC a name. I'm going to call it Simplilearn_VPC. And this is the kind of naming convention I'll be using throughout this course. Next, we need to give it the CIDR block, or the classless interdomain routing block. So we're going to give it a very simple one, 10.0.0.0, and then we need to give it the subnet mask. So you're not allowed to go larger than 15. So if I try to put 15 in, it says no, not going to happen. For a reference, subnet mask of 15 would give you around 131,000 IP addresses, and subnet 16 will give you 65,536, which is probably more than enough for what we're going to do. Next, you get to choose the tenancy. There's two options, default and dedicated. If you select dedicated, then your EC2 instances will reside on hardware that's dedicated to you. So your performance is going to be great, but your cost is going to be significantly higher. So I'm going to stick with default, and we just click on yes, create. It'll take a couple of seconds, and then in our VPC dashboard we can see our Simplilearn VPC has been created. Now if we go down to the bottom here to see the information about our new VPC, we can see it has a route table associated with it, which is our default route table. So there it is, and we can see that it's only allowing local traffic at the moment. If we go back to the VPC again, we can see it's been given a default network ACL. And we'll click on that and have a look. And you can see this is very similar to what we looked at in the lesson. So it's allowing all traffic from all sources, inbound and outbound. Now if we go to the subnet section, and just widen the VPC area here, you can see there's no subnets associated with the VPC we've just created. So that means we won't be able to launch any instances into our VPC. And to prove it, I'll just show you. We'll go to the EC2 section. So this is a glimpse into your future. This is what we'll be looking at in the next lesson. And we'll just quickly try and launch an instance. We'll select any instance, it doesn't matter. Any size, not important. So here, the network section, if I try and select Simplilearn VPC, it's saying no subnets found, this is not going to work. So we basically need to create some subnets in our VPC, and that is what we're going to look at in the next lesson. Now, private IP addresses are IP addresses that are not reachable over the internet, and they're used for communication between instances in the same network. When you launch a new instance, it's given a private IP address and an internal DNS hostname that resolves to the private IP address of the instance. But if you want to connect to this from the internet, it's not going to work. So then you'd need a public IP address, which is reachable from the internet. You can use public IP addresses for communication between your instances and the internet. Each instance that receives a public IP address is also given an external DNS hostname. Public IP addresses are associated with your instances from the Amazon pool of public IP addresses. When you stop or terminate your instance, the public IP address is released and a new one is associated when the instance starts. So if you want your instance to retain its public IP address, you need to use something called an elastic IP address. An elastic IP address is a static or persistent public IP address that's allocated to your account and can be associated to and from your instances as required. An elastic IP address remains in your account until you choose to release it. There is a charge associated with an elastic IP address if it's in your account but not actually allocated to an instance. This is a demonstration of how to create an elastic IP address. So we're back at the Amazon Web Services Management Console. We're going to head back down to the networking VPC section, and we'll get to the VPC dashboard. On the left-hand side, we'll click on Elastic IPs. Now you'll see a list of any Elastic IPs that you have associated in your account. And remember, any Elastic IP address that you're using that isn't allocated to something, you'll be charged for. So I have one available, and that is allocated to an instance currently. So we want to allocate a new address, and it reminds you that there's a charge if you're not using it. I'm saying yes, allocate. And it takes a couple of seconds. And there's our new Elastic IP address. Now we'll be using this IP address to associate with the NAT gateway when we build that. AWS defines a subnet as a range of IP addresses in your VPC. You can launch AWS resources into a subnet that you select. You can use a public subnet for resources that must be connected to the internet, and a private subnet for resources that won't be connected to the internet. The net mask for the default subnet in your VPC is always 20, which provides up to 4,096 addresses per subnet, and a few of them are reserved for AWS use. A VPC can span multiple availability zones, but a subnet is always mapped to a single availability zone. This is important to know. So here's our basic diagram, which we're now going to start adding to. So we can see the virtual private cloud, and you can see the availability zones, and now inside each availability zone we've created a subnet. Now you won't be able to launch any instances unless there are subnets in your VPC. So it's good to spread them across availability zones for redundancy and failover purposes. There's two different types of subnet, public and private. You use a public subnet for resources that must be connected to the internet, for example web servers. A public subnet is made public because the main route table sends the subnet's traffic that is destined for the internet to the internet gateway, and we'll touch on internet gateways next. Private subnets are for resources that don't need an internet connection or that you want to protect from the internet, for example database instances. So in this demonstration we're going to create some subnets, a public and a private subnet, and we're going to put them in our custom VPC in different availability zones. So we'll head to Networking and VPC, wait for the VPC dashboard to load up. We'll click on Subnets, we'll go to Create Subnet, and I'm going to give the subnet a name. So it's good to give them meaningful names. So I'm going to call this first one for the public subnet 10.0.1.0, and I'm going to put this one in the US East 1B availability zone, and I'm going to call that Simplilearn public. So it's quite a long name, I understand, but at least it makes it clear for what's going on in this example. So we need to choose a VPC. So we obviously want to put it in our Simplilearn VPC. And I said I wanted to put it in US East 1B. I'm using the North Virginia region, by the way. So we click on that. Then we need to give it the CIDR block. Now, as I mentioned earlier, when I typed in the name, that's the range I want to use. And then we need to give it the subnet mask. And we're going to go with 24, which should give us 251 addresses in this range, which obviously is going to be more than enough. If I try and put a different value in that's unacceptable to Amazon, it's going to say, it's going to give me an error and tell me not to do that. Let's go back to 24 and click. I'm going to cut and paste this, by the way, just because I need to type something very similar for the next one. Click Create. And it takes a few seconds. Okay, so there's our new subnet, and I just widen this. You can see, so that's the IP range, that's the availability zone, it's for Simplilearn, and it's public. So now we want to create the private. So we put the name in. I'm going to give the private the IP address block of that. I'm going to put this one in US East 1C, and it's going to be the private subnet. Obviously I want it to be in the same VPC. availability zone of US East 1C, and we're going to give it 10.0.2.0/24, and we'll click Yes, Create. And again, it takes a few seconds. Okay, so let me sort by name. So there we are, we can see now we've got our private subnet and our public subnet. In fact, let me just type in Simplilearn, there we are. So now you can see them both there. And you can see they're both in the same VPC, Simplilearn VPC. Now if we go down to the bottom, you can see the route table associated with these VPCs. And you can see that they can communicate with each other internally, but there's no internet access. So that's what we need to do next. In the next lesson, you're going to learn about internet gateways and how we can make these subnets have internet access. Welcome to the networking section. In this section, we're going to take a look at internet gateways, route tables, and NAT devices. And we'll have a demonstration on how to create each of these AWS VPC items. So to allow your VPC the ability to connect to the internet, you need to attach an internet gateway. And you can only attach one internet gateway per VPC. So attaching an internet gateway is the first stage in permitting internet access to instances in your VPC. Now here's our diagram again, and now we've added the internet gateway, which is providing the connection to the internet to your VPC. But before you can configure internet correctly, there's a couple more steps. For an EC2 instance to be internet connected, you have to adhere to the following rules. Firstly, you have to attach an internet gateway to your VPC, which we just discussed. Then you need to ensure that your instances have public IP addresses or elastic IP addresses, so they're able to connect to the internet. Then you need to ensure that your subnet's route table points to the internet gateway, and you need to ensure that your network access control and security group rules allow relevant traffic to flow to and from your instance. So you need to allow the rules to let in the traffic you want, for example HTTP traffic. After the demonstration for this section, we're going to look at how route tables, access control lists, and security groups are used. In this demonstration, we're going to create an internet gateway and attach it to our custom VPC. So let's go to Networking VPC, bring up the VPC dashboard, and on the left hand side we click on Internet Gateways. So here's a couple of internet gateways I have already, but I need to create a new one. So create Internet Gateway. I'll give it a name, which is going to be Simplilearn Internet Gateway, IGW. And I'm going to click Create. So this is an internet gateway which will connect a VPC to the internet, because at the moment our custom VPC has no internet access. So there it's created, Simplilearn IGW, but its state is detached because it's not attached to anything. So let me try and attach it to a VPC, and it gives me an option of all the VPCs that have no internet gateway attached to them currently. So I only have one, which is Simplilearn VPC. Yes, attach. Now you can see our VPC has internet attached, and you can see that down here. So let's click on that, and it will take us to our VPC. But before any instances in our VPC can access the internet, we need to ensure that our subnet route table points to the internet gateway. and we don't want to change the main route table, we want to create a custom route table, and that's what you're going to learn about next. A route table determines where network traffic is directed. It does this by defining a set of rules. Every subnet has to be associated with a route table, and a subnet can only be associated with one route table. However, multiple subnets can be associated with the same route table. Every VPC has a default route table, and it's good practice to leave this in its original state and create a new route table to customize the network traffic routes associated with your VPC. So here's our example, and we've added two route tables, the main route table and the custom route table. The new route table, or the custom route table, will tell the Internet Gateway to direct Internet traffic to the public subnet. But the private subnet is still associated to the default route table, the main route table, which does not allow Internet traffic to it. All traffic inside the private subnet is just remaining local. In this demonstration, we're going to create a custom route table, associate it with our Internet Gateway, and associate our public subnet with it. So let's go to Networking and VPC. The dashboard will load, and we're going to go to Route Tables. Now our VPC only has its main route table at the moment, the default one it was given at the time it was created. So we want to create a new route table, and we want to give it a name. So we're going to call it Simplilearn. I'm going to call it route table, RTB for short. And then we get to pick which VPC we want to put it in. So obviously we want to use Simplilearn VPC. So we click Create. It'll take a couple of seconds, and here you are. Here's our new route table. So what we need to do now is change its route so that it points to the Internet Gateway. So if we go down here to routes, at the minute you can see it's just like our main route table, it just has local access. So we want to click on Edit, and we want to add another route. So the destination is the Internet, which is all the zeros, and our target, and we click on this, it gives us the option of our Internet Gateway, which we want to do. So now we have Internet access to this subnet, to this route table. And we click on Save. Save was successful. So now we can see that as well as local access, we have Internet access. Now at the moment, if we click on Subnet Associations, you do not have any subnet associations. So basically, both our subnets, the public and private subnets, are associated with the main route table, which doesn't have Internet access. So we want to change this. So we'll click on Edit, and we want our public subnet to be associated with this route table. So click on Save. So it's just saving that. So now we can see that our public subnet is associated with this route table, and this route table is associated with the Internet Gateway. So now anything we launch into the public subnet will have Internet access. But what if we wanted our instances in the private subnet to have Internet access? Well, there's a way of doing that with a NAT device, and that's what we're going to look at in the next lecture. You can use a NAT device to enable instances in a private subnet to connect to the Internet or other AWS services, but prevent the Internet from initiating connections with the instances in the private subnet. So we talked earlier about public and private subnets to protect your assets from being directly connected to the Internet. For example, your web server would sit in the public subnet, and your database in the private subnet, which has no Internet connectivity. However, your private subnet database instance might still need Internet access or the ability to connect to other AWS resources. If so, you can use a Network Address Translation device, or a NAT device, to do this. A NAT device forwards traffic from your private subnet to the Internet or other AWS services, and then sends the response back to the instances. When traffic goes to the internet, the source IP address of your instance is replaced with the NAT device address, and when the internet traffic comes back again, the NAT device translates the address to your instance's private IP address. So here's our diagram, which is getting ever more complicated, and if you look in the public subnet, you can see we've now added a NAT device, and you have to put NAT devices in the public subnet so that they get internet connectivity. AWS provides two kinds of NAT devices, a NAT gateway and a NAT instance. AWS recommends a NAT gateway as it's a managed service that provides better availability and bandwidth than NAT instances. Each NAT gateway is created in a specific availability zone and is implemented with redundancy in that zone. A NAT instance is launched from a NAT AMI, an Amazon Machine Image, and runs as an instance in your VPC, so it's something else you have to look after, whereas a NAT gateway, being a fully managed service, means once it's installed, you can pretty much forget about it. A NAT gateway must be launched into a public subnet because it needs internet connectivity. It also needs an elastic IP address, which you can select at the time of launch. Once created, you need to update the route table associated with your private subnet to point internet-bound traffic to the NAT gateway. This way, the instances in your private subnets can communicate with the internet. So if you remember back to the diagram when we had the custom route table, which was pointed to the internet gateway, now we're pointing our main route table to the NAT gateway, so that the private subnet also gets internet access, but in a more secure manner. Welcome to the Create a NAT Gateway demonstration, where we're going to create a NAT gateway so that the instances in our private subnet can get internet access. So we'll start by going to Networking and VPC. And the first thing we're going to do is take a look at our subnets, and you'll see why shortly. So here are our Simplilearn subnets. So this is the private subnet that we want to give internet access, but if you remember from the section, NAT gateways need to be placed in public subnets. So I'm just going to copy the name of this subnet ID for the public subnet, and you'll see why in a moment. So then we go to NAT gateways on the left hand side, and we want to create a new NAT gateway. So we have to put a subnet in there. So we want to choose our public subnet. Now, as you can see, it truncates a lot of the subnet names on this option, so it's a bit confusing. So we know that we want to put it in our Simplilearn VPC in the public subnet, but you can see it's truncated. So it's actually this one at the bottom, but what I'm going to do is just paste in the subnet ID, which I copied earlier, so there's no confusion. Then we need to give it an elastic IP address. Now, if you remember from the earlier demonstration, we created one, so let's select that. But if you hadn't allocated one, you could click on the Create New EIP button. So we'll do that. Okay, so it's telling me my NAT gateway has been created. And in order to use your NAT gateway, ensure that you edit your route table to include a route with a target of, and then our NAT gateway ID. So it's given us the option to click on our edit route tables. So we'll go straight there. Now here's our route tables. Now, here's the custom route table that we created earlier, and this is the default, the main route table, which was created when we created our VPC. So we should probably give this a name so that we know what it is. So let me just call this Simplilearn RTB main. So now we know that's our main route table. So if you take a look at the main route table and the subnet associations, you can see that our private subnet is associated with this table. So what we need to do is put a route in here that points to the NAT gateway. So if we click on routes and edit, and we want to add another route, and we want to say that all traffic can either go to the Simplilearn internet gateway, which we don't want to do. We want to point it to our NAT instance, which is this NAT ID here, and we click save. So now any instances launched in our private subnet will be able to get internet access via our NAT gateway. Welcome to the Using Security Groups and Network ACL section. In this section, we're going to take a look at security groups and network ACLs, and we're going to have a demonstration on how you create both of these items in the Amazon Web Services console. A security group acts as a virtual firewall that controls the traffic for one or more instances. You add rules to each security group that allow traffic to or from its associated instances. Basically, a security group controls the inbound and outbound traffic for one or more EC2 instances. Security groups can be found on both the EC2 and VPC dashboards in the AWS Web Management Console. We're going to cover them here in this section, and you'll see them crop up again in the EC2 lesson. And here is our diagram, and you can see we've now added security groups to it. And you can see that EC2 instances are sitting inside the security groups, and the security groups will control what traffic flows in and out. So let's take a look at some examples, and we'll start with a security group for a web server. Now obviously a web server needs HTTP and HTTPS traffic as a minimum to be able to access it. So here is an example of the security group table, and you can see we're allowing HTTP and HTTPS, the ports that are associated with those two, and the sources, and we're allowing it from the internet. We're basically allowing all traffic to those ports. And that means any other traffic that comes in on different ports would be unable to reach the security group and the instances inside it. Let's take a look at an example for a database server security group. Now imagine you have a SQL Server database, then you would need to open up the SQL Server port so that people can access it, which is port 1433 by default. So we've added that to the table and we've allowed the source to come from the internet. Now because it's a Windows machine, you might want RDP access so you can log on and do some administration. So we've also added RDP access to the security group. Now you could leave it open to the internet, but that would mean anyone could try and hack their way into your box. So in this example, we've added a source IP address of 10.0.0.0.0. So only IP ranges from that address can RDP to the instance. Now there's a few rules associated with security groups. By default, security groups allow all outbound traffic. So if you want to tighten that down, you can do so in a similar way to you can define the inbound traffic. Security group rules are always permissive. You can't create rules that deny access, so you're allowing access rather than denying it. Security groups are stateful, so if you send a request from your instance, the response traffic for that request is allowed to flow in regardless of the inbound security group rules. And you can modify the rules of a security group at any time, and the rules are applied immediately. Welcome to the Create Security Group demonstration, where we're going to create two security groups, one to host DB servers and one to host web servers. Now if you remember from the best practices section, it said it was always a good idea to tier your applications into security groups, and that's exactly what we're going to do. So if we go to networking and VPC to bring up the VPC dashboard, on the left hand side under security we click on security groups. Now you can also get to security groups from the EC2 dashboard as well. So here's a list of my existing security groups, but we want to create a new security group, and we're going to call it Simplilearn Web Server SG security group, and we'll give the group name as the same, and our description is going to be Simplilearn Web Servers Security Groups. Okay, and then we need to select our VPC. Now it defaults to the default VPC, but obviously we want to put it in our Simplilearn VPC. So we click Yes, Create. Takes a couple of seconds, and there it is. There's our new security group. Now if we go down to the rules, the inbound rules, you can see there are none. So by default, a new security group has no inbound rules. But what about outbound rules? If you remember from the lesson, a new security group by default allows all traffic to be outbound. And there you are, all traffic as destination of everywhere. So all traffic is allowed. But we want to add some rules. So let's click on inbound rules, click on edit. Now this is going to be a web server. So if we click on the drop down, we need to give it HTTP. So you can either choose custom TCP rule and type in your own port ranges, or you can just use the ones they have for you. So HTTP, this pre-populates the port range. And then here you can add the source. Now if I click on it, it's giving me the option of saying allow access from different security groups. So you could create a security group and say I only accept traffic from a different security group, which is a nice way of securing things down. You could also put in here just your IP address so that only you could do HTTP requests to the instance. But because it's a web server, we want people to be able to see our website, otherwise it's not going to be much use. So we're going to say all traffic, so all source traffic can access our instance on port HTTP 80. I want to add another rule because we also want to do HTTPS, which is hiding from me. There we are. And again, we want to do the same. And also, because this is going to be a Linux instance, we want to be able to connect to the Linux instance to do some work and configuration. So we need to give it SSH access. And again, it would be good practice to tie it down to your specific IP or an IP range, but we're just going to do all for now. And then we click on save, and there we are, there we have our ranges. So now we want to create our security group for our DB servers. So let's click create security group, and then we'll go through it and give it a similar name, Simplilearn DB servers SG. And the description is going to be Simplilearn DB servers security group. And our VPC is obviously going to be Simplilearn VPC. So let's click yes, create. We'll wait a few seconds. And here's our new security group. As you can see, it has no inbound rules by default, and outbound rules allow all traffic. So this is going to be a SQL Server database server. And so we need to allow SQL Server traffic into the instance. So we need to give it Microsoft SQL port access. Now the default port for Microsoft SQL Server is 1433. Now in reality, I'd probably change the port the SQL Server was running on to make it more secure, but we'll go with this for now. And then the source. So we could choose the IP ranges again, but what we want to do is place the DB server in the private subnet and allow the traffic to come from the web server. So the web server will accept traffic, and the web server will then go to the database to get the information it needs to display on its on the website. Or if people are entering information into the website, we want the information to be stored in our DB server. So basically, we want to say that the DB servers can only accept SQL Server traffic from the web server security group. So we can select the Simplilearn web server security group as the source traffic for Microsoft SQL Server data. So we'll select that. Now our SQL Server is obviously going to be a Windows instance, so from time to time we might need to log in and configure it. So we want to give RDP access. Now again, you would probably put a specific IP range in there. We're just going to do all traffic for now. Then we click save. And there we are. So now we have two security groups, DB servers and web servers. A network ACL is a network access control list, and it's an optional layer of security for your VPC that acts as a firewall for controlling traffic in and out of one or more of your subnets. You might set up network ACLs with rules similar to your security groups in order to add an additional layer of security to your VPC. Here is our network diagram, and we've added network ACLs to the mix. Now you can see they sit somewhere between the route tables and the subnets. This diagram makes it a little bit clearer, and you can see that a network ACL sits in between a route table and a subnet. And also you can see an example of the default network ACL, which is configured to allow all traffic to flow in and out of the subnets to which it's associated. Each network ACL includes a rule, whose rule number is an asterisk. This rule ensures that if a packet doesn't match any of the other numbered rules, it's denied. You can't modify or remove this rule. So if you take a look at this table, you can see on the inbound, some traffic would come in and it would look for the first rule, which is 100. And that's saying I'm allowing all traffic from all sources. So that's fine, the traffic comes in. If that rule 100 wasn't there, it would go to the asterisk rule. And the asterisk rule is saying traffic from all sources is denied. Let's take a look at the network ACL rules. Each subnet in your VPC must be associated with an ACL. If you don't assign it to a custom ACL, it will automatically be associated to your default ACL. A subnet can only be associated with one ACL. However, an ACL can be associated with multiple subnets. An ACL contains a list of numbered rules which are evaluated in order, starting with the lowest. As soon as a rule matches traffic, it's applied regardless of any higher numbered rules that may contradict it. AWS recommends incrementing your rules by a factor of 100, so there's plenty of room to implement new rules at a later date. Unlike security groups, ACLs are stateless. Responses to allowed inbound traffic are subject to the rules for outbound traffic. Welcome to the network ACL demonstration, where we're just going to have an overview of ACLs where they are in the dashboard. Now you don't need to know a huge amount about them for the exam, we just need to know how they work and where they are. So let's go to networking and VPC, and when the dashboard loads, on the left hand side under security there's network ACLs. So let's click on that. Now you can see some ACLs that are in my AWS account. So we want the one that's associated with our Simplilearn VPC. So if we extend this VPC column, that's our network ACL there, Simplilearn VPC. Now let's give it a name because it's not very clear to see otherwise. Also, I'm kind of an obsessive tagger, so let's call it Simplilearn ACL and click on the tick. So there we are. So now it's much easier to see. So we click on inbound rules. So this is exactly what we showed you in the lesson. The rule is 100, so that's the first rule that's going to get evaluated, and it's saying allow all traffic from all sources. And the outbound rules are the same. So if you wanted to tighten down the new rule, you could click edit, we would give it a new rule number, say which would be 200. So you should always increment them in 100. So that means if you had 99 more rules you needed to put in place, you'd have space to put them in between these two. And then you could do whatever you wanted. You could say, you know, we are allowing HTTP access from all traffic, and we're allowing, or you could say, actually, you know what, we're going to deny it. So this is the way of blacklisting traffic into your VPC. Now I'm not going to save that because we don't need it, but this is where network ACLs sit, and this is where you would make any changes. It's also worth having a look at the subnet associations with your ACL. So we have two subnets in our Simplilearn VPC, so we would expect to see both of them associated with this network ACL because it's the default. And there they are. There's both our public and our private subnets are associated. And you can also see up here on the dashboard, it says default. So this is telling us this is our default ACL. If you did want to create a new network ACL, you would click create network ACL. You'd give it a name, just say new ACL, and then you would associate it with your VPC. So we would say Simplilearn VPC. Takes a few seconds, and there we are. There we have our new one. Now you can see this one says default no because it obviously isn't the default ACL for our Simplilearn VPC, and it has no subnets associated with it. So let's just delete that because we don't need it. But there you are. There's a very brief overview of network ACLs. Welcome to the Amazon VPC Best Practices and Costs, where we're going to take a look at the best practices and the costs associated with the Amazon Virtual Private Cloud. Always use public and private subnets. You should use private subnets to secure resources that don't need to be available to the internet, such as database services. To provide secure internet access, to the instances that reside in your private subnets, you should provide a NAT device. When using NAT devices, you should use a NAT gateway over NAT instances because they're a managed service and require less administration effort. You should choose your CIDR blocks carefully. Amazon VPC can contain from 16 to 65,536 IP addresses, so you should choose your CIDR block according to how many instances you think you'll need. You should also create separate Amazon VPCs for development, staging, test and production, or create one Amazon VPC with separate subnets, with a subnet each for production, development, staging and test. You should understand the Amazon VPC limits. There are various limitations on the VPC components. For example, you're allowed 5 VPCs per region, 200 subnets per VPC, 200 route tables per VPC, 500 security groups per VPC, 50 in- and outbound rules per VPC. However, some of these rules can be increased by raising a ticket with AWS support. You should use security groups and network ACLs to secure the traffic coming in and out of your VPC. Amazon advises to use security groups for whitelisting traffic and network ACLs for blacklisting traffic. Amazon recommends tiering your security groups. You should create different security groups for different tiers of your infrastructure architecture inside VPC. If you have web tiers and DB tiers, you should create different security groups for each of them. Creating tier-wise security groups will increase the infrastructure security inside the Amazon VPC. So if you launch all your web servers in the web server security group, that means they'll automatically all have HTTP and HTTPS open. Conversely, the database security group will have SQL Server ports already open. You should also standardize your security group naming conventions. Following a security group naming convention allows Amazon VPC operation and management for large-scale deployments to become much easier. Always span your Amazon VPC across multiple subnets in multiple availability zones inside a region. This helps in architecting high availability inside your VPC. If you choose to create a hardware VPN connection to your VPC using Virtual Private Gateway, you are charged for each VPN connection hour that your VPN connection is provisioned and available. Each partial VPN connection hour consumed is billed as a full hour. You'll also incur standard AWS data transfer charges for all data transferred via the VPN connection. If you choose to create a NAT gateway in your VPC, you are charged for each NAT gateway hour that your NAT gateway is provisioned and available. Data processing charges apply for each gigabyte processed through the NAT gateway. Each partial NAT gateway hour consumed is billed as a full hour. This is the practice assignment for designing a custom VPC, where you'll create a custom VPC using the concepts learnt in this lesson. Using the concepts learnt in this lesson, recreate the custom VPC as shown in the demonstrations. The VPC name should be Simplilearn VPC. The CIDR block should be 10.0.0.0/16. There should be 2 subnets, one public with a range of 10.0.1.0 and one private with a range of 10.0.2.0, and they should be placed in separate availability zones. There should be one internet gateway and one NAT gateway, and also one custom route table for the public subnet. Also create 2 security groups, Simplilearn Web Server Security Group and Simplilearn DB Server Security Group.
In this section, we're going to learn about why we need a solution called CloudFormation, or why we need a product called CloudFormation. And we're going to talk in detail about what is CloudFormation, and then how CloudFormation works and the concepts involved in CloudFormation, like templates and stacks. There are some concepts involved in CloudFormation. We're going to talk about that. And how do we maintain access control over CloudFormation? We're going to talk about that as well in this video. And then we're going to go through a demo or a lab where we create an LAMP stack environment from a template. through CloudFormation. And then we're going to talk about some use cases, one of which include being able to create an redeployable template using CloudFormation. That's a very good use case. We're going to talk about that in this video. So let's talk about why CloudFormation. So when the number of products and services grow more, and managing them and maintaining them becomes an tedious work, and CloudFormation, it sort of eases that environment. Now, CloudFormation is really an infrastructure as a code, and it sort of solves all the problem that we discussed some time back. And with CloudFormation, we can actually create a perfect clone of the server configuration at any point in time. And we can also manage the configuration changes With CloudFormation, we can manage the configuration changes across the environment. And not only that, we can easily embed in the ad hoc changes to our existing environment. So one might ask, why use CloudFormation? Let's look at the current problem that we have. Creating and managing multiple AWS resources in the portal is a big task, especially when you need to replace some services. It becomes a bigger task. Now, CloudFormation eases that work. Let me explain it in detail. Now, at the moment, without the CloudFormation, or environments that don't use CloudFormation have this problem. That is, a lot of time is being spent on building the infrastructure, and less focus and less time at the moment is being given on developing that application that runs on that environment. That's because majority of the time is consumed by building the environment. And if we need to redeploy the same environment again and again, the same happens in a cycle. Again, in a new environment, we start from the scratch, build the environment, and then put application on top of it. Now, that can be avoided using CloudFormation. Now, without CloudFormation, it still is a problem, because the resource or the bandwidth that is needed for the application development is not provided, because that's taken by developing the infrastructure. And to solve that problem, we can use CloudFormation. Now, that leads to a discussion about what is CloudFormation. So let's talk about, or let's try understanding what CloudFormation is. CloudFormation is a service that provides users a simple way to create and manage a collection of AWS resources by provisioning and updating them in a very orderly and in a predictable way. If I need to expand explanation of CloudFormation, CloudFormation is a service that really helps us to model and set up our Amazon Web Services or resources, so we can spend less time on managing the resources and show more focus on the application that runs on top of it. We can simply create a template for an EC2 instance or for an RDS instance and upload it in the CloudFormation portal, and CloudFormation will provision and configure those resources based on the template that we define. We really don't have to sort out the complexities in dependency between those applications. Once the template is vetted and validated, CloudFormation takes the responsibility of handling the dependencies between the application in an orderly and a predictable way. It creates those services and makes it available for us once the template is fully run. So in short, the CloudFormation, it allows us to create and model our infrastructure and applications without we having to perform the manual action. For example, the well-known company called Expedia is able to easily manage and run its entire front and back-end resources they run on AWS in CloudFront. What does that mean? They are spending less time on managing the infrastructure and more time on the core business and the application that runs on top of it. And we're still talking about what CloudFormation is. With CloudFormation, it enables us to manage our complete infrastructure or AWS resource in a text file. Now, we're going to see that in a moment. It's either a JSON or an YAML file, and that file is called as the template to begin with. The resources the template provision is called the stack. All right, so the abstract of the code is called the template, and the resource that it provisions is called the stack. And this stack can be, it's going to run resources, obviously, and those resources can be updated as well. It's not like once you create a stack, it's done. If you need a change, you need to go create another resource. That's not needed. This stack is an updatable stack. Let's say if I'm including 2 more servers, if I'm sort of extending my environment, it's branching out to another application. Now I'm including another functionality in my environment. All those can be embedded in the update and can be updated. So like I said, the stack is an updatable one. Now let's talk about what the template can do, or some features and functionality of the template. Now, using a template, we can almost include all the application and resources that a user might require. Let's say, after the EC2 instance is provisioned, running an application on top of it, and you want to templatize that and include that in the template, that's possible as well. And these templates are portable ones, meaning I can use the template in one region and I can use the same template in another region, and that's going to build a very similar environment in another region. I can also share that with the customer, and when they run it, it's going to run an environment from the portable template in their account, in their environment. Of course, all the security is taken care. I'm just saying that if we need to build a resource, if we need to build an architecture, if we need to build an environment which looks very similar to the other environment, that is possible. And these templates are reusable by the use of some sections in the template, like the parameter section, the mapping section, the condition section within the template is what makes the templates reusable. And we will talk about parameters, mapping, and conditions down the line. We're still talking about how AWS CloudFormation works, and we're going to talk about how a template becomes an infrastructure. Right? So to begin with, one requires a template, and the template would be in JSON or YAML format. So one would develop a template based on the requirement, based on number of EC2 instances, based on whether they want a load balancer, based on whether they want a Windows server, based on whether they want an database server in that environment, and then based on the applications that will be running on top of it that can be templatized in the code itself. So one creates a code, and then the code is saved locally, or they can be put in an S3 bucket from which the CloudFormation will call the template and provision the resource. Right. So we use CloudFormation to create a stack or create the resource defined in the template. And CloudFormation analyzes the template first, validates the template, and then it identifies the dependencies between them, and then it starts provisioning the resource one after the other. For example, if you need 5 servers in a new VPC, obviously it's going to create the VPC first and servers second, and stack. All right, let's understand the two major components in CloudFormation. By now you might have guessed it. The two major components are the template and the stack. Together they aid or they complement CloudFormation, and that's how the resources are provisioned, that's how the resources are managed, and that eases the job of the administrator who's managing the environment. So let's talk about template first. A template in CloudFormation is an text file or a formatted text file in JSON or YAML language, and that the code or the template or the text file that actually describes how your infrastructure looks like or will look like once provisioned. And for us to create the template, or for us to modify an existing template, we can use a tool available called CloudFormation Designer from the console, or any text editing tool that's available. But I would recommend the CloudFormation Designer though, that has rich graphics in it. And these templates are built off, or they consist of 9 main objects. The first of which is the format version, and this really identifies the capabilities of the template based on the version number. And then the second object in a template would be description, and this helps us to include any arbitrary comments about the template. For what reason are we building this template? What's the purpose of it? Stuff like that. And then we have the object called metadata in a template, and that includes details about the template, details of the resources in the template. And then we have the optional parameters section. This really helps us to customize our template. Now, parameters enable us to input custom values to our template each time we create or update and stack. And the mapping object, it helps us to match a key to a corresponding set of named values. For example, if you want to set a value based on region, then we get to create a mapping that uses region name as the key, and then the value that we want to specify for each specific regions. And then we have conditions object. This is again an optional object. With this, we can include statements that define when a resource is created or when a property is defined. For example, we can compare whether a value is equal to another value, and based on the result of that condition, we can conditionally create additional resources. And then the object called transform. It's an optional object as well, And this transforms section specifies one or more transforms that we can use in our CloudFormation template. For example, AWS CloudFormation transforms helps simplify template authoring by condensing the expression of the AWS infrastructure as a code or the CloudFormation template, and it enables reuse of template components. For example, we can condense multiple line resources, declaring it into a single line in our template. Now we will talk about all these examples in the upcoming slides. And then we have the required section called resource that declares the AWS resource that you want to include in the stack. For example, if you want to include an EC2 instance, if you want to include an S3 bucket, we would be using the resource object in our stack. And then we have object called output. This output object, it's an optional object in the template, and it helps us to sort of declare the outputs that we can import into other stacks, or we can actually show it on the CloudFormation console. For example, if you want the output of the name of the S3 bucket that got created in response to a CloudFormation template, now we can have that outputted into an output section in the CloudFormation console itself. So it's sort of easy for us to identify the resources that the template provisioned. So with all of those objects put together, this is how a full-blown CloudFormation template with all the objects included is going to look like. Now this includes optional and mandatory objects. Let's talk about those objects in detail in the upcoming section. Alright, let's now discuss each and every object of this template structure. And let's begin our discussion with the format version. The format version, it really defines the capabilities of the template. The latest version, format version as of now, is the one that was updated on 2010. Now the value of the template format version, it has to be an string, and if we really don't specify the format version, CloudFormation automatically assumes the latest version. Talking about descriptions are really any comments that help ourselves that we want to embed in the template itself. That can be a description, and this description in a template, it has to be an string. The length of the string can be between 0 to 124 bytes in length. The metadata are really used in the template to provide any additional information using the JSON and YAML objects. And metadata holds some implementation details of a specific resource. And parameters are really a way to customize the template. Each time we create or update our stack, these parameters are the ones that helps us to give some custom value to the template during runtime. In the example shown below, the parameter named instance type parameter, it lets us to specify the EC2 instance type for the stacks to use when creating or updating the stack. By default, as we see, it's picking T2 micro, and this is the value that will get picked if we don't provision another value to it. And mapping really enables us to map a key to a corresponding named value that we specify in a conditional parameter. And also we can retrieve the map or retrieve the values in the map using the function findInMapInStrict function. Let's take this example. Let's say based on a region, if we want to set values in a template, we can create a mapping that uses a key and holds the value that you want to specify for each region. And the object conditions can be used when we want to reuse the templates by creating resources in a totally different context. For example, in a template, during stack creation, all the conditions that we mention in the template are evaluated, and any resources that are associated and that come up to be true are created, and any condition that fails or invalid are kind of ignored automatically, and the check moves forward to the next condition. And conditional is an optional object, and it includes statements that define when a resource is created or when a property is actually defined. For example, you can you can compare whether a value is equal to another value, and based on the result of that condition, we can conditionally create resources. If you have multiple conditions, then they are generally separated with commas. Sometimes conditions are very helpful when we want to create templates and we want to reuse those templates which was created for one environment to another environment. For example, if you want to use a template that was created in a test environment in a dev environment, conditions would be helpful. For example, in a production environment, we might want to include instances with certain capabilities, and in a test environment, we might want to include instances with some reduced capability in them for saving money. And condition helps us to create resources based on the environment it will be used in. We can also use intrinsic functions to define conditions like equals. We can also use OR conditions. We can use NOT functions, intrinsic functions in a condition. And when put together, the syntax is going to look like the one that you see on the screen. Now, the optional object called transform, it specifies one or more transforms that the CloudFormation uses to process our template. Now, these transform sections are built on a simple declarative language of AWS CloudFormation with a powerful macro system that helps us to reuse the templates or the template components. And they really help us to condense or simplify our codes by enabling reuse of the template components. For example, condense a multiple line resource declaration into a single line in our template. The resource section, it really declares the AWS resource that you want to include in the stack, such as EC2 instance, such as S3 bucket. And some of the resource fields are the logical ID, the resource type, and the properties. Let's talk about them in brief. The logical ID is unique within the template, and the logical ID name, it actually references the resource in other parts of the template. In this case, it's my bucket. For example, if we want to map an elastic block store volume, or if we want to map an name of the bucket in another place in the template, then we would use the logical ID. And again, in this case, it is my bucket. A logical name has the physical ID with which we actually assign the resource. For example, in this case, my S3 bucket was named as my bucket to begin with. And the resource type in the template, it identifies that the type of the resource is an S3 bucket. And the properties are the additional optional information that we can specify to our resource. For example, if it is an EC2 instance, let's say we would like to know which AMI it used, then property section really defines the AMI that was used, or AMI as the property of the instance. So this section describes the output value that needs to be imported to other stacks, or the output value that needs to be shown in the console for the user to easily navigate to the resource that are being created. For example, for a S3 bucket name, we can declare an output, and once the bucket is created, we can actually declare the output and import the name of the bucket in a different place in the console, so it's easy to view instead of the user getting confused and going to S3 and searching for the bucket name. This can be made available in the CloudFormation console itself. And the output fields, it can include some of these followings, like the logical ID. It's actually the identifier of the current output, and it's very unique within the template. And it can also include a description. Description is really a string type that describes the output value, and it can also include value, and value is the property that was returned by the AWS CloudFormation describe stacks command. All right, let's talk about the template resource attribute. In this section, we're going to talk about attributes that you can add to a resource to control additional behavior and relationships. So let's talk. There are many resource attributes available, out of which we have, if we need to name them, we have a creation policy, and then we have deletion policy. It depends on metadata attribute, update policy attribute. Let's talk about each of them separately. When we associate the create policy attribute with the resource, it actually delays the resource configuration actions before proceeding with the stack creation. The attribute stack creation is delayed till the time the CloudFormation receives some number of success signals back. This is a very good use case when we do auto scaling. And this creation policy can be used only with a limited number of services like autoscaling and EC2 instances. Some of the use cases would be if you want to install a software application on an EC2 instance, you might want the applications to be running before it proceeds further. So in this case, we would use the creation policy attribute to the instance and then send the success signal after the applications are installed and configured. Then CloudFormation goes to the next step. here in the syntax that we're looking at, the auto-scaling creation policy and the minimum successful instance percentage, it's actually a number of signals that it will have to reply back before it can move forward. Using deletion policy, it preserves backing up of resources when the stack is getting deleted. And by default, if you don't have a delete policy, the data gets deleted just like that. But if we use an deletion policy, we would be able to preserve the data by taking a snapshot of it, or just letting the resource and moving on with deleting the other resources in the stack. And we specify the delete policy attribute for each resource specifically that we want to control. And if there are no deletion policy mentioned for a particular resource, the CloudFormation simply deletes the resources as that's its default behavior. And if you want to keep the resource when the stack is deleted, we mention retain in the delete policy, and that simply retains the resource from getting deleted. So in this example, we're actually retaining an DynamoDB table. Rest of the resources in the stack will get deleted. And using the depends on attribute, we actually create an order in which the resource gets deleted. For example, if I map one resource to another resource and say that this resource depends on the other resource gets created first, then followed by this instance or this resource. So with the depends on attribute, we can specify that the creation of specific resource is actually followed by another. When we add the depends on attribute to a resource, the resource is created only after the creation of the resource specified by the depends on attribute. Let's take this example. In this example, we're saying that the resource X depends on Y. We've said that X depends on Y. So in this case, when CloudFormation is executing, it's going to deploy Y first because it has some resources that depends on it. So it's going to create Y first, and then it's going to create the resource called X. On the same context, let's say in the template, we say that an EC2 is going to depend on S3, and when the CloudFormation is executing, it's going to create an S3 bucket first, and then the EC2 instance. That's probably because the codes needed for the EC2 instance are stored in the S3 bucket. And what we're looking at is the syntax of how the depends on template resource attribute will look like. This is how it actually will look like when we put it in the CloudFormation. The instance depends on the bucket. The other template resource attribute is metadata. Metadatas are the one that really helps us to associate our resources with the structured data. And by including this attribute in our template, or by including this attribute to a resource, we can specify the data in JSON or in YAML language. For example, in this section of the template, we're creating a VPC, and the metadata explains, or metadata defines, that the VPC is part of the region US East 1. And the update policy template resource attribute in CloudFormation, we can manage and replace the updates of the instance in an auto-scaling group. For example, you're looking at this sample where it says that the update policy, will it replace the instance in an auto-scaling group or not? So depending on what the value is for the will replace section, whether it's true or false, depending on that, the update policy will replace the instance or will replace the auto-scaling group itself when it's doing a rolling deployment. Now that we've discussed about templates, let's talk about AWS stacks as well. Now we know that AWS stacks are the actual resources that gets generated or that gets created because we ran a template. Right? So stack is a collection of AWS resources that we can manage in a single unit. In other words, we can create a stack, update a stack, or delete a stack, and that would actually create, update, delete the collection of resources within the stack. And all the resources in the stack are really defined by the CloudFormation template. And a stack, for instance, can include all the resources required to run a web application, such as a web server, a database server, and some networking rules that come along with it. All that gets embedded in a stack. And let's say if we want to delete all the resources that were created by template, that is in a a separate stack, we can simply delete the stack, and that would sort of delete all the resources that is in the stack. So it sort of helps us to manage all the resources in a single unit or as a single unit. So to summarize, stack is a collection of AWS resource and it can be managed as a single unit, and the CloudFormations template defines a stack in which the resource can be created, deleted or updated in a very predictable way. And a stack can have all the resources like web server, database server, VPC, the network and the security configurations in a VPC, all that is required to run a web or a database application. Now, stack could be nested as well. With CloudFormation, we can actually nest a stack with another stack, and that's going to create a hierarchy of the stacks. For example, this is a very good picture that explains how the stacks are nested in a hierarchical way. Let's say stack P is the root stack, and that could be a parent stack for the stack called R and the stack called Q. And the same way, the stack called R is a parent stack for the stack S, and the stack S is the parent stack for T and Q. You get that, right? So stacks can always be nested. It's possible. CloudFormation allows us to create a Microsoft Windows stack based on Amazon EC2 Windows AMIs, and provide us with the ability to install software and use remote desktop to access our stack and update the configuration of our stack. And these stacks can be run on Windows Server instances. There are a number of pre-configured templates available, and it's directly available to use from the AWS website itself. To name a few, we have templates available for SharePoint running on an Windows Server 2008 R2. We also have templates that create a single server installation of Active Directory running on a Windows Server. And in fact, we have templates available for Elastic Beanstalk and some sample applications that runs from an Windows Server 2008 R2. Let's talk about stack sets. Stack sets actually has taken the stack level implementation to the next level. Using the AWS CloudFormation template, we can define a stack set that lets us to create stack in AWS account across the globe by using just a single template. And after we create the stack, or after the stack set is defined, creating, updating or deleting the stack in the target account and the regions can also be specified by us. So the stack set, it really extends the functionality of the stacks by allowing us to create, update and delete stack across multiple accounts, regions in just a single operation. And using an administrator account, we can define and manage an AWS CloudFormation template and use the template as the basis for provisioning stacks into, some selected target accounts across a specified region. Let's talk about CloudFormation access control. With IAM, I can specify the list of users or list of privileged users who would have access to the CloudFormation template, who can create, update and delete stacks. So that's how IAM helps me with having or putting a layer of control over the CloudFormation service. And we can also use service roles. Service roles are the one that allows AWS CloudFormation to make a call to a resource in a stack on the user's behalf. And I can also have stack policies, and these stack policies are applied to the users who already have access to the CloudFormation service. And these policies are the ones that help the users who attempt to update the stack. All right, let's do a quick lab on creating an LAMP stack on an EC2 instance with a local MySQL database for storage. Now, we can do the other way as well. I can pick an EC2 instance and install the servers one top of the other. That can be done as well, but that's going to take a lot of time. Now, we're talking about automating it. We're talking about, provisioning an infrastructure using a code, and CloudFormation helps us to do that. So this is what we're going to do. We're going to create, or we have a CloudFormation template already, and we're going to use that template to provision a web instance, and that is going to have, look at that, that's going to have MySQL installed in it, that's going to have PHP, that's going to have HTTPD service installed in it and running. And it's also going to have a PHP website running from it. So that's going to receive information from the website, and that's going to store that information in the database that's very local to it. This is the template that defines that environment. All right, this is a very simple provisioning. So let's provision this environment. Let's create a stack. We're going to give a stack name and a database password. Right, and which region is it? This is in California, is it? All right. Now let me do one thing. Let me switch to the Mumbai region, or let me switch to North Virginia region. North Virginia, and from here, actually, let me switch to Mumbai region. Right, just to be sure, it's the same template that we are provisioning. Right, that's the same template that we are provisioning. Right, let's give this name. So it can be great. This could be Simplilearn Lamb stack, and what could be the DB password and DB root password, and what could be the DB user. I'm going to keep the rest as defaults, and I'm going to launch. Alright, so there's an issue with the password. Password should only have alpha numeric characters. Get that? So let's go back and create a new password. Right, it also needs to have 8 characters. So what can be our password? Look at that. The template is actually creating the resources. And here on the screen, we can see the template that we used to deploy the environment. If you remember, we discussed about instant types in parameters, right? The default instance type is T2 small, but these are also allowed to run. Right, parameter section is the one that was used to receive information from us, like the DB name, the DB password, the DB root password, DB user instance type, key name, and the SSH locations. All right, now this resource section is showing us the resource that it actually created. Right, looks like it's rolling back. Why would that be? Give me a moment. Alright, this is one live example. Anytime it could not provision, or if there is an interruption that it could not proceed, it would simply roll back and delete all the resources that it had provisioned, and that's what it did. Now let me fix this. Alright, as a fix, I have switched the region because I had some issue with the VPC. That's going to take time for me to analyze and fix it. So here we're going to understand about CloudFormation. So I thought I'll run the CloudFormation from another VPC that I know is working fine. That's in North Virginia. Alright, let's provision a LAMP server which is running out of Linux, which has Apache installed in it, which has PHP and MySQL already installed in it. So one server going to act as web and DB server. Right, so I'm going to create a stack, and from here I'm going to pick a sample stack. Now if we look at it in the designer, it's going to provision one LAMP server and a security group attached to it. There you go. Right, so let's go ahead and create a stack. All right, parameters are used to receive input from us. What could be the DB password and the DB user, and let's select the key name. Right, I'm going to keep the rest as defaults, and I'm going to create a stack. Alright, so our stack that we ran from the template, at the moment it's getting created, it's in progress. From here I can watch the events as to what is getting created at the moment. Like I said, a lot of these would have already sorted out their dependencies, which one needs to get created first, which one needs to get created second. All that is sorted out by CloudFormation itself. And parameters are the values that we have inputted, and resource tab is a section where we can find what resources are being provisioned at the moment. So to begin with, it created a security group. At the moment it's creating an instance, and output, it's empty as of now. We're going to come back and see it. Now output is where we can get outputs of a finished job. Let's say here I wanted an URL of the server that got created. So instead of me going to a couple of other places within the console and find the output of the URL or the output of the resource that was created, I can simply get it from here. Well, this needs to be defined in the templates first. Once we define it in the template, it's going to be made available like here, right? So I can open it up, and so there you go. So it already has a database locally installed, and it's connected to it. If I launch an application on top of it, that will get connected to the database, which is very local, and my single server with web and database in it is ready for production. Now, while we're talking about a LAMP server, a single LAMP server, let's talk about creating an environment like this, which has Elastic Load Balancer, a VPC, a server running in an auto-scaling group, and putting some restrictions that nobody will be able to access the EC2 instance directly, but they should be able to access the EC2 instance or the data only through the Elastic Load Balancer. This is a bit complicated than the environment that we've already created. Let's see how this is done. All right, in this lab, we're going to create Elastic Load Balanced auto-scaling group, which is going to create a load balancer and an auto-scaling group, and that auto-scaling group receives traffic only from the load balancer. So here's the template, and here's the architecture that we're going to provision. Let me call it right, and the key pair it's going to use is Simplilearn key pair. Now this is where the problem was. Now we were selecting few subnets. So now if I provision it, now this is going to take its short time to provision the resources. So through parameters, we can see the values that we have inputted, and the events look good. No rollback, no deletes, and the resource section shows the resource that it is creating. So previously created a target group, now it's creating the application load balancer itself. All right, so it created a load balancer, and then it created a security group. It created a launch configuration. At the moment it's creating a web server group. And the events look good with all green and yellow. Green ones are completed, yellow ones are in progress. We don't have any red delete or rollback errors, so it looks good. All right, it took a while, and the resources have been created. Some of them show that they are in progress, but the status of the stack is complete. All resources have been created, and we do have an output to access the URL. There you go. And remember, there was another feature of the CloudFormation that was it should restrict access, direct access to EC2 instance. Let's see if that has been done. If I try to access using the load balancer, it lets me access. But if I try to access it using the EC2 instance IP or the DNS name, my connection won't go through because it's blocked through the security group, but direct access through the load balancer is allowed, and that's what we wanted to achieve through that. Here in this section, we're going to talk about what is security in AWS, and then we're going to slowly or gradually move on to the other topics like types of security available in AWS. Out of all the services, why IAM is the most preferred one, and then we're going to talk about what is IAM in general, how it works, the building blocks or components in IAM, and the features, the attractive features that it provides that makes IAM stand out from the rest of the services available. We're going to talk about that, and then we're going to end today's session with a demo about how IAM gets well interacted with other services in Amazon and help create a secure environment in the cloud. Let's talk about AWS security. Now, cloud security is the highest priority in AWS. And when we host our environment in the cloud, we can be rest assured that we are hosting our environment in a data center or in a network architecture that's really built to meet the requirement of the most security sensitive organization. And this high level of security is available to us on a pay-as-you-go type, meaning there is really no upfront cost that we need to pay. And the cost for using the service is a lot cheaper than what it is in an on-premises environment. So AWS Cloud provides a secure virtual platform where we can deploy our application. Now, compared to the on-premises, with AWS, the security level is very high, and the cost involved in using or attaching that type of security to our application is very low compared to on-premises. There's really no upfront cost, and the cost is very lower. Whatever cost that we pay is very lower than what it would be in on-premises, and all this contributes to the secure environment we can get through IAM in AWS Cloud. There are really many types of security services available in AWS. To name a few, or to name the familiar ones, IAM stands first, followed by Key Management System, KMS, and then we have Cognito, that's another service, and Web Access Firewall, WAF, is another security service in AWS. Now let's start our discussion by talking about IAM, and that's what this whole series is about. Now, IAM, or Identity and Access Management, it really enables us to manage access to AWS services and AWS resources in a very secure manner. With IAM, we can create groups. We can actually allow those users or groups to access some service, or we can sort of deny them to access the service, whichever we want. That's all possible through identity and access management. And this feature comes with no additional charge. Now let's talk about how things were before AWS. Before AWS, or before IAM in general, it was not that safe in a corporate to share the password over the phone or through the email. That was the practice that existed at that time. Now, we all can remember the days when we need to switch to a different account, or we had just one admin password commonly stored in a location, or one person would reset it and maintain it, and anytime we need to log in, we call the person, ask for the admin password over the phone, and then we try logging in. Now, that was not secure at all back then. Somebody could walk by and sort of eavesdrop, get the password. Now they walk away with the password with them. So they're all possible when we share the password over the phone and through the internet or email. Now with AWS, a lot of options are available that I'm not sharing password over the unsecure medium. Now Slack is a third-party product available with AWS. It's not an AWS product, but Slack is a third-party application that's hosted on AWS. And it's really a communication tool that helps people to share documents. So now we're not sharing the password over the phone, rather through the applications, and no eavesdrop person can really catch the password and try it in their system to access our environment. That's not possible. So you see the difference now. Back then, sharing password was only through phone and email, and you would write it on a paper and you give it to somebody. But now technology is providing provisions enough for us to share the password in a secure way. We're still talking about IAM. IAM is an web service for securely controlling access to the AWS resource. Now it really helps us to authenticate or sort of limit access to a certain set of users accessing the AWS account or certain set of users accessing a certain set of resources in AWS account. Now you see this picture, we have an IAM administrator who's trying to allocate permissions to different group of people. So we have group 1 on the top and group 2 in the middle and group 3 towards the end. The administrator using IAM or IAM empowers the administrator, allow access to certain group to certain resources. That's what IAM is all about. Now let's talk about the building blocks, or let's talk about the elements that make and complete IAM. So the elements are categorized into 6 different elements. We have the principal in IAM, the authentication, the request, the actual request coming in, the authorization, allowing, denying access, actions, what are the scope of actions can be taken, and on what resource. Is it EC2, is it RDS, is it S3 bucket? So what resource these actions are applied to. So they are the basic elements of an IAM workflow. Let's talk about principal, for example. An action on AWS resource can only be performed by a principal. An individual user, they can be a principal. A role in AWS IAM, it can be a principal as well. In other words, a principal is an entity that can take an action on an AWS resource. You know, a principal can be an user, a principal can be a role, a principal can be an application that's trying to access the AWS environment. Secondly, authentication. Now, authentication is a process of confirming the identity of the principal trying to access the AWS environment. Now, how do we get authenticated, or how does a user get authenticated? By providing credentials or the required keys to validate that this is what he or she is as per what's in the record. So all principal must be authenticated, and we get authenticated using the username and password to log into the console. If it is CLI, or we get authenticated using the access key and the secret access key. The other component that makes up IAM is request. When a principal tries to use the AWS Management Console, what the principal is doing, or what the user is doing, is sending a request to the AWS environment. And the request will have the principal actually wants to perform. Is it a put request, or is it a get request, or is it a delete request, stuff like that. And it's also going to carry information about on which resource the action needs to be done. Is it on EC2 1? Is it on S3 bucket Simplilearn.com? Stuff like that. So it has a specific action that it wants to perform and the resource on which it wants to perform, and also some information about from where the request is originating from. Is it within an AWS environment, or is it with another cloud service provider, or is it with on-premises, stuff like that. So these information will be present in the request. Authorization. Now this IAM uses information from the request context to check for matching policies, and it takes a decision whether to allow or to deny the request. Now here it has a logic. By default, all the resources are denied, and IAM authorizes your request only if every part of the request is allowed by a matching policy. So there is an evaluation logic that says by default all requests are denied, and if there is an explicit allow, then it overrides the default deny. And if you are explicitly denying a service, then all the allow statements gets overridden, and all the other statements gets overwritten, and this explicit deny stands. By default, only the AWS account root user has access to all the resources in that account. So if you're not signed in as a root user, then we must be specifically granted permission through a policy. In other words, we need to be authorized through the policy. Now let's talk about action. Now after authenticating and authorizing the request, AWS approves the action that we are about to take. Now using action, we can view the content, we can create a content, or create a bucket, or create an EC2 instance. I can edit content, or even I can delete a resource. That's all based on the action that I'm allowed to do. Now that was about actions. Now where is the action performed? The action is performed on the resources. A set of actions can be performed on a resource, and anything that's not mentioned in the action, or anything that's not tagged with the action and the resource, they don't get to complete. For example, let's say if you attempt to delete an IAM role, and you also request to access the EC2 instance for that role, then the request gets denied. Now let's talk about some of the other components of IAM. So the other components of IAM are the basic building block is an user, and then many users together, they form a group. And then policies are the engines that allows or denies a connection. Based on policy, one gets to access or gets no access to a resource. And then roles are another component. Roles are temporary credentials, I would say, that can get assumed to an instance as and when needed. Right, let's talk about this component called user in an IAM. With IAM, we can securely manage access to AWS services, and we can create an IAM user anytime there is a new employee joining our corporate. So it's a one-to-one mapping. One user or one employee gets a username directly attached to them. And a username or a user is an account-specific thing. It's very local to that AWS account that we are using. So in detail, an IAM user is an entity that we create in an AWS environment to represent a person or a service that interacts with AWS environment. And this user is going to have some credentials attached to them. And by default, they do not have a password, and they do not have any access key or secret access key attached to them. In fact, literally no credentials of any kind. Now we must create an user, and we must create the type of credential that gets attached to the user. Do they want to access CLI? So based on that, we would be adding credentials to them. A user by default is not authorized to perform any action in AWS. And the advantage of having one-to-one user is that we can assign permissions individually to that user. For example, we might want to assign administrative permissions to few users who can administer our AWS environment, and users are entity within an AWS account. Users don't have to pay separately. They start using the servers, and that get bills under the account they are attached to. So separate users doesn't mean that separate payment for those users. They are just users in our account, and the whole account gets to pay for the resources that they provision. Again, the IAM user does not always represent a person. An IAM user is really just an identity with associated credential and permissions attached to it. It could be an actual person who is a user, and it could be an application also who is a user. Next, we'll talk about groups. Talking about groups or understanding group is very easy. A collection of user forms an IAM group, and we can use IAM group to specify permission for multiple users, so that any permission that's applied to the group is also applied to the users who are add to that group. Now, there are a few things you might want to know about group. A group can have many users, and a user, they can belong to many groups, but groups can't be nested, meaning group can only have users. A group cannot have a group inside a group. That's not possible. And there's nothing called a default group that sort of automatically includes all users in the AWS account. If you want to have a group, then we will have to create a group. Now let's take this diagram for example. Now this is a diagram of a small company. Now the company owner creates an admin group for users to create and manage other users as the company expands every day. And the admin group creates a developer group and a test group. Each of these groups consists of users who are people, users who are applications that interact with AWS environment. So the different types of users we have are Jim is a user, Brad is a user, and Dev App 1 is a user, and so on. So each users have an individual set of security credential. Like I said, it's 1-to-1. And the 10 users that we see on screen are shared between, or they belong to multiple groups in the account. And managing group is quite easy. We set permission to the group, and that permission gets applied to all the users automatically in the group. And after we applied the policy, if I add another user to the group, the new user will automatically inherit all the policies, all the permissions that's already mentioned in that group. So administrative burden is sort of taken away. Administrative burden about user privilege or user permission management is sort of taken out with IAM. Alright, the next thing we will want to discuss is policy. A policy sets permission and controls the access to AWS resource. And the policies, these permissions and controls, are stored in JSON format. A policy is a very clear document. It defines who has access to a resource and what are all the actions they can perform. So in other words, policy is an entity in AWS that when a policy gets attached to an identity or a resource, it really defines the permission, what they can and cannot do. And AWS, it evaluates these policies when a principal, such as a user, makes an request. And the permission statement in the policy, it really defines whether the user is allowed to access a service or is he denied to access a service. Alright, let's take this example. Now we have a task. The task is to give Paul, who is a developer, access to Amazon S3 environment. And what you're looking at is a snippet of what a policy would look like. So these are some questions we will have to answer, or these are some questions the policy tries to answer. And once it found an answer, then it becomes a complete policy. So who wants access to the service? It's Paul who wants access to the service. And what action do Paul want? Now Paul wants to download, or Paul wants to upload objects in S3. In JSON language, it's otherwise called Paul wants to get information, Paul wants to put information. Otherwise, Paul wants to get object, Paul wants to put object in S3. And which resource does he want? Now, in this case, every bucket. The star symbol represents all buckets in S3. So, which resource? It's all bucket in S3. So, we can start reading already from the data present here. So, who wants access? Paul wants access. What action does he want? He wants to get, he wants to put. And what's the resource that he's trying to access, or you want to give him access? It's all the bucket in AWS. And when does he want? These are additional statement that goes in a policy. So since when does he want that access? He wants access till March 2nd, 2019. So all this who, all this action, all this resource, till the time all this gets allowed. So this is the statement that really defines. Now, does this all refer to an allow statement, or does this all refer to a deny statement? If we had deny here, it's the direct opposite of what we discussed, but we have allow. That means Paul is allowed to get and put access in an S3 bucket, and all the buckets in S3 till March 2nd, 2019, he's allowed to access the resources. So if we put all the information that we have gathered, or all the answers that we have so far, if we put together in a JSON format, this is how it's going to look like. So the effect is allow or deny. Here it's allowing, and the principal is any. Who can access it? It's any. And action, it's any bucket in S3. Any action in S3, put get request, and the resource is any bucket in S3. So that's how a basic policy would look like, or that's how a basic policy is formed, by answering those basic questions. So let's talk about the types of policies. So we have two broad categories: managed policy and inline policy. Now, managed policy, it's the default policy that we attach to multiple entries, be it users, be it groups, and be it roles in our AWS account. On the other hand, inline policy are the policies that we create and manage them. And these policies are embedded directly into a single user, group, or a role. So if I need to brief it a little bit more, then managed policies are standalone identity-based policies that we can attach to multiple users, groups, and roles in our AWS account. We can use two types of managed policies. In other words, managed policies, they themselves have two categories. One is AWS managed policies, which is created and managed by AWS. And the other one is customer managed policies. Just like the name says, it's managed by the customer. Now we can create and edit an IAM policy in Visual Editor, or simply create a JSON policy document directly and upload it in the console and start using them. So that's managed policy. On the other hand, inline policies are policies that we create and manage, and that are embedded directly into a single user, group, or role. Let's talk about this next component called role. Now this role is very similar to everything that we discussed so far. It's a set of permission that defines what actions are allowed and denied by an entity in an AWS console. The role is very similar to an user. I said very similar. I didn't say it's the same as the user, but I said it's very similar to the user. And the difference is that user is hard-coded. User permissions are hard-coded. but the role permissions are accessed by any entity, be it a user or be it an AWS service, and moreover, the role permissions are temporary. On the other hand, user permissions are permanent and the role permissions are temporary. So in detail, a role is very similar to a user in that it's an AWS entity with permission policies that determines what the identity can and cannot do in AWS. Now, instead of it being uniquely associated with one person, a role is intended to be assumable by anyone who needs it. Roles generally do not have a long-term credential, password or access keys associated with it. It does not have long-term credentials. It only has temporary credentials created dynamically and provided to the user as and when the user assumes a role and wants to access any service. Roles can be assumed by users, roles can be assumed by applications, roles can be assumed by services that normally don't have access to AWS resources. For example, you might want to grant a user in your AWS account access to your resource that they do not normally have, or grant users in one AWS account access to resource in another AWS account. Now this is something that we don't have by default, and this is something we may not need all the time. Or you might want to allow a mobile app to use AWS resource, but you do not want to save the key or save the credential or save the passwords in the mobile app. Or sometimes you might want to give access to resources who already have identities defined outside of AWS, like a user who's already an Google or Facebook authenticator. If you want to give them some service, or if you want to let them to access some of the resources in your account, we can use roles for that purpose. Or you also might want to grant access to your account to a third party, a consultant or an auditor, so they can for some time get some temporary access to audit our AWS resources. Remember, they're not permanent users, just temporary users. They want some temporary access to our environment till the audit is over. So for those cases, roles are a very good use case. So let's take this example. Let's see where role sits, and let's see how roles give permission to other services. So here is a scenario where an EC2 instance wants access to an S3 bucket. By default, though both of them were created by the same username or the same admin, they do not have access by default. So by default, they don't have access. And I also do not want to give permanent access, one-on-one hard-coded permanent access. Instead, I would like to create and share access. So that's possible through role. So coming back to the discussion, the scenario here is that an EC2 instance wants to access data in an S3 bucket. So the first thing is to create a role or a permission. We saw how that's done, right? Using policies. Roles use policies. Policy is the actual working engine for any permission related actions, right? So create a role with an appropriate policy that gives access to S3's bucket, and then launch an EC2 instance with the role attached to it. We said roles are assumed by any entity, right? It could be user, it could be an application, it could be a service, it could be another resource in AWS account. So here it's another resource in AWS account, right? So we create a role and we attach it to an EC2 instance. So now the EC2 instance can assume the role. Now the same role can be attached to another EC2 instance. The same role can be attached to another user. The same role can be attached to another database service. We get the idea, right? Roles can be assumed by anyone. So when the EC2 instance wants to communicate with S3, it contacts the role, and then the role gives this EC2 instance some temporary username and password that expires after 1 hour, let's say. So it's a temporary username and password. Now with that temporary username and password, the EC2 instance can access the S3 bucket and access the file with the credential that it already has. And that credential is a temporary one. And the credential will expire after 1 hour, or how much ever time the admin sets it to be. And then the next time when an EC2 instance wants to contact S3, it will have to contact the role, and the role will propose a new access key and secret access key. In other words, a new credential. With that new credential, the second time the EC2 instance will be able to contact the S3 bucket and get the information. So the password is not a permanent or a one-time or a hard-coded password. It keeps rotating. It's a token. It's a secure token that an EC2 instance or any application that uses the role gets to access the resources on the other end. Well, let's talk about the features of IAM. The main feature of IAM is that I can create separate username and password for individual users or resources, and I can delegate access. Now, those days where we had just one username and password for admin and we need to call the other person to get the username and password over the phone, if it gets compromised, the whole account gets compromised, stuff like that, those issues are gone. I can create separate username and password for all 1,000 users in my account. No more username and password sharing. I can manage access to all those 1,000 accounts in a very simple and an easy way. So IAM provides shared access for all the 1,000 users in my account. It provides shared access to the AWS environment. And the permissions that can be given through IAM are very granular. Now, we saw how restrictions can be put on GET requests. We can allow a user to download information and not update an information. So that's possible through the IAM policies that we looked at some time back. And with the use of roles, we're authenticating an EC2 instance instead of the application running on top of it. So if there are like 10 or 20 applications running on top of an EC2 instance, instead of creating a separate username and password for all those 20 instances, I can create a role and assign that role to the EC2 instance, and all the applications running on the EC2 instance get a secure access to the other resources, use the role credential that's provided to that EC2 instance. Now, besides username and password, IAM also supports multi-factor authentication, where we provide a credential, the username and password, plus an OTP from our phone or an randomly generated number that gets displayed in our phone before Amazon console or before Amazon CLI would authenticate and lets us access some of the service in the account. So it's called multi-factor authentication. It's username and password plus something else from what you have. IAM also provides identity federation. If a user is already authenticated with a corporate AD or Facebook or Google, IAM can be made to trust that authentication method and then allow access based on that authentication. Now, without federation, what would happen is the users will have to remember two passwords, one for on-premises and one for cloud. Anytime they work on on-premises, they'll have to use one set of password, and anytime they switch to the cloud, which is going to be very frequent in every day. So anytime they switch to the cloud, they will have to again type in the cloud username and password. Now, with identity federation, we can sort of federate, or we can connect both the authentication systems, both on-premises and IAM. So users can just use one username and password for both on-premises and cloud environments. And all that we saw so far, it's free to use. There is no additional charge for IAM security. There is no additional charge for creating additional users, groups, or policies. It's a free service, comes along with any account. IAM is an PCI DSS compliant product. IAM comes with password policy where we can reset the password remotely or rotate the passwords remotely. And we can set rules like how a user should pick and password. It should not be the one that was used in the past, any of the past 3 times, stuff like that. So you get the idea, right? How the features of IAM help us to build an secure authentication and authorization system in or for our AWS account. All right, it's time to do a quick lab. Let's put all the knowledge that we have earned so far together and apply it and try a lab and solve the problem. So here's a problem statement. We need to create an S3 bucket for a company where users can read or write the data only if they are multi-factor authenticated. So there could be like 20 users in an account, but a user is allowed to read or write a data in an S3 bucket only if the user is multi-factor authenticated. This is a very good use case if we have sensitive data in an S3 bucket and you only want privileged or MFA authenticated users to do changes to those buckets. And for those privileged users, you would enable multi-factor authentication. So let's see how that's done. Before that, let me talk to you a bit more about multi-factor authentication. Now, multi-factor authentication is that additional level of security process. It's provided by AWS. Here, the user's identity is confirmed only after the user proposes or the user passes two-level of verification. Now, one being the username and password, and another being an OTP that gets generated. In this case, it's the mobile phone. It could also be an RSA token key that generates the one-time password. That's possible as well. But in this case, it's the mobile phone. Now, that's going to be very similar to how we log in to our Gmail account sometimes. When we log into a Gmail account and if you have the proper setting enabled, it's going to send an one-time password to the mobile phone, and only after we put that information, it's going to let us log in. Let's see how all this is done in an AWS account. So the first thing is to log in to the AWS account, create a user, and attach the user to the virtual MFA device. Now we're going to use Google Authenticator here, and we're going to attach the user to Google Authenticator and make the user use the Google Authenticator one-time password every time he logs in to the account. Now this is in addition to the username and password that he or she already has, right? So the first thing is to log into the account, connect or sync the virtual appliance with the AWS username and password. Now when we sync, there will be an one-time password that gets shown in the phone. Type in the password in the AWS console, and then the phone and the username comes to sync. And from that point onwards, the user, anytime they log in, they will have to propose their username and password, which is the first step of security. And then once they typed in the username and password, type in the MFA code that gets generated on the phone. That would be the second step of security, or the last step of security. Once that is done, the account is going to let them log in and access the AWS resources. Alright, so in order to test IAM, MFA, S3 together, this is what we're going to do. So we're going to create a bucket, and we're going to have two users, and we're going to allow or deny access to the S3 bucket to those two users based on whether they are MFA authenticated or not. And on purpose, we're going to assign MFA to one user and no MFA to the other user. Like you might have guessed by now, the user with MFA will have access to the bucket, and the user with no MFA attached will not have access to the bucket. Both of them are going to have full S3 services, but MFA, like I said, is one layer above the other permissions. MFA stands at all time. So irrespective of whether the underlying policy says whether they have full access to the S3 bucket, they're not going to, because MFA stands on top of it. Let's see how that's done. To begin with, firstly, we need a bucket. So let's create a bucket. So I'm in my AWS console. So let me go to S3. And in here, create a bucket. Call that bucket as Simplilearn MFA bucket. And let me put it in North Virginia and create. Alright, so that's done. Now I'm going to put a separate folder in here. I'm going to create another folder in here, and the name of the folder is tax documents. Now this is where I'm planning to keep my tax files, and I only want my privileged users to be able to upload and download information from the tax document. So on the bucket side, it's partially done, or on the S3 side, it's partially done. So let's go back to IAM, and here we're going to create two users, one a junior employee and another one an senior employee. The senior employee is the one who's going to have MFA access and more access to the S3 bucket, and the junior employee is the one who's not going to have access to that particular bucket. So let's get started. Let's create an user under IAM. Click on users, and let's create a user. Call this user junior . Right, so he's a junior user, and for the password, set a password. The user does not need to create a new password at sign in, because it's a test environment, and the user who creates the username and the user are the same person. So let's keep it simple. Username, password, management console access, and this user is going to have full S3 bucket access. Alright, this is really the policy. We should be familiar with this JSON document by now. It says effect is allow, and what action, any action in S3, and what resource, anybody who's attached to it. Review and create a user. So this user is having S3 full access. Now let's create another user, call them as senior employee. All right, attach a policy to the user. From the surface level, both of them have the same permissions. Both of them have S3 full access. All right, so both of them have S3 full access, as we see. There's one thing different we're going to do to this senior employee. Now we're going to attach MFA to this employee. So the way we would do it is under the summary section of that particular user, click on security credential, and see, here's a place we can attach an MFA to this user. So let's attach MFA to this user. For MFA, I can use both virtual MFA or hardware MFA. This being a lab environment, we're going to use virtual MFA. Now, that is an application. There are a lot of applications available, but there is one application that I'm using at the moment called Google Authenticator. So once we have installed the application, once it is running, so I can go to virtual MFA device, and once it is running, I can scan the code using the Google Authenticator in my mobile phone. Once you turn on the application and once you do scan the barcode that is showing right here, now that's going to give us codes that we can use. And we will have to put in those codes here twice. We'll have to wait for some time and it would generate a second set of key that we can put. So my first set of key is 402351. Right, I'll have to wait for some time. And then it would throw me a second set of key. It's like validating twice right here. So let me put in my second set of key. So this user is now MFA authenticated user. So anytime this user logs in, it's going to ask for MFA. Anytime this user proposes something, it's going to attach the MFA key along with it. Alright, so we're done with the IAM. What have we done with IAM? We have created two users. Both of them have S3 full access, but one of them have MFA access and the other one does not have MFA access. And based on whether the user is having MFA or not, we're identifying privileged users by this MFA. Alright, so based on whether the user has MFA or not, we're going to allow deny access in the S3 bucket. So we already have a bucket, we already have a folder, and this is a very privileged folder path. Here I would like to restrict access based on whether the user is having MFA or not. So let me create a bucket policy here. Now here's a policy that I have written. The policy says that, under tags document folder, give access only if the user is MFA authenticated, right? If the user is not MFA authenticated, simply deny the access to that user. So as you might guess right now, the user 1 will not have access, or the junior employee will not have access because it's a privileged, and junior employee might tend to delete them unknowingly, and only privileged users get access to the tax document because it's confidential, because it's privileged, because if it gets deleted, we won't be able to get it back for those reasons, right? So apply the bucket policy. Now try logging in as the different users and see how the permissions are applied on both the users. All right, so let's make a note of the IAM URL. And then the two usernames and password. Let's log in. So let me log in as the privileged user. Sure enough, I'm being asked for an MFA code. Let me put my MFA code. So let's directly navigate to the S3 bucket. Right, here's my privileged path. Let me try uploading some content. Claim forms. Sure enough, I'm able to upload content into it. Will I be able to delete? Yes, I'm able to delete as well. Now let's see what's the situation for the other user. So let's log in as the other user. Navigate to the S3 bucket. If you noticed, when logging in, it did not ask for an MFA code because the user is not set up for MFA. So navigate to the folder which we want to test. Now try adding some files. As you see, it's failing to add content to this bucket. It shows error because the bucket policy is requiring MFA and this user is not MFA, and we did that in IAM or under IAM. But still, as you see, they will be able to view the content in the bucket. They can do all that. We have specifically restricted access to upload and download content from the bucket, and that's exactly this user is now denied with.
So what's a part of this tutorial and demo? What's in store for you? At our offset, I would like to cover the basics of orchestration tools. As most of you would know, Kubernetes is one of the most popular orchestration tools in recent times, specifically for applications which are cloud native and deployed on some or the other types of containers. But what are these orchestration tools? Why would one need to use orchestration tools? What are the facilities or features provided by these orchestration tools? That's the first thing that I'm going to cover. After that, I will pick two orchestration tools specific to container management, Docker Swarm versus Kubernetes. I'm going to compare them with regard to the features that they provide, the use cases that they cover, what facilities that they provide, and when to use what. After that, I will get into a little bit details of the Kubernetes architecture, what exactly is required for setting up a Kubernetes cluster, what runs in a control plane or a master node, what runs as a part of the worker node. After that, I will end the tutorial by running you through a demo by setting up a 3-node Kubernetes cluster on AWS platform. I will use something called as COPS, which is one of the admin tools for setting up production grade Kubernetes cluster. So I will use this to set up a 3-node cluster on AWS. Alright, now that we set the context right, let me get started. So what are orchestration tools? The application development and the lifecycle management from the time the application is developed, connecting the source code to your continuous integration, to testing them all along your development process, and eventually moving it down to production, managing your production servers, the dependencies that your software has, the requirement that it has in terms of the hardware, the features of fault tolerance, self-healing capabilities, auto-scaling, all this has complicated over the last few years. As a part of DevOps, one thing that everyone is interested in is managing all this application dependency or lifecycle management using some or the other kind of a tool. So that's where these orchestration tools have become very, very popular. So what kind of features that they provide is you'll have to just let them know what are the kinds of tool sets that is required, what are the fault tolerance mechanisms that it has to be adopted to, what kind of a self-healing capabilities that application will have to need, and if at all there is any auto-scaling features that is required. If at all you can bake in all these specific parameters into your tool, your orchestration tool becomes a one-stop shop for all your deployment and configuration management needs. That's where these orchestration tools have become a very, very popular and relevant, specifically these days when people are more and more interested in adopting DevOps practices. Alright, so having said that about orchestration tools, let's concentrate on two of these orchestration tools specifically for container management: Docker, Swarm, and Kubernetes. Many of the applications that are written for these kind of containers are called or kind of fall into a category of cloud native, where the application need not know much about the underlying infrastructure or the platform where these applications are running. So these two, along with Apache Mesos, there are many other container management systems, but I'm going to pick Docker, Swarm, and Kubernetes for comparing the features that is provided by these two frameworks. For the sake of comparison, I picked up Docker, Swarm, and Kubernetes just because of the reason that both of them operate in the space of container management. They do something very, very similar to containers. That's the similarity that exists between these two orchestration tools. However, there's a big difference that exists when it comes to the types of containers that both of them cater to, and also the capacity of workloads they can be used for. Docker Swarm is a cluster management solution that is provided by Docker Container. Docker is one of the very, very popular containers of recent times, and in case you have your applications that is totally powered by only Docker containers, if you have a need where you want to run a cluster of servers which are running only Docker containers, Docker Swarm should be your choice for your orchestration tool. Kubernetes, on the other hand, can cater to any other types of containers other than Docker, and including Docker as well. So in case you have your applications which have got Docker in them, which have got RKT in them, which they have got LX in them, or any other type of container, Kubernetes should be your choice of orchestration tool. A Docker Swarm can manage up to 40, 50, or 60 max nodes. So in case your application is totally written in Docker containers and the load or the expected cluster size is about 50, 60 nodes, Docker Swarm should be your choice of orchestration tool. On the other hand, Kubernetes is something that was open sourced by Google, and the scale of operations that Kubernetes can cater to is Google scale. So if in case your applications are more than 1,000 nodes, that is where Kubernetes comes into play. That's the big difference that exists between Docker Swarm and Kubernetes. Putting those differences aside, let me compare Docker Swarm and Kubernetes based upon other features which are similar in nature. The first and important feature that Kubernetes provides is something called as auto-scaling. If at all the load on your cluster is too high and your application is experiencing more load, so Kubernetes can add new nodes to your cluster. Of course, you'll have to configure Kubernetes in order to have those capabilities where it can spin up new VMs or new nodes. If at all you do that configuration correctly, Kubernetes has got the capacity, or it has got the feature where it can bring up a new node and add it to the cluster on the fly based upon the load that exists at that moment. On similar lines, if at all the load is not too high, it can identify a few of those nodes which have got less number of replicas or less number of application containers running on it. It can move them to some other node and also scale down by deleting few nodes from your cluster. So that is the powerfulness of auto scaling which is provided by Kubernetes, and this unfortunately does not exist in Docker Swarm. The other feature of load balancing, specifically application load balancing. So Docker Swarm gives you an application level auto load balancing. However, Kubernetes gives you the flexibility of manually configuring any other type of load balancer of your choice for application load balancing. Installation. As I mentioned earlier, Docker Swarm is a loose cluster of containers which are running on nodes. It is very easy to spin up a new node and then connect them to a swarm. And this can be done in a very, very loosely coupled way where you can create swarms of your choice. Nodes are allowed to connect to swarms and quit or leave the swarms on the fly. So in and all, the installation is pretty easy and fast. Kubernetes, on the other hand, the configuration of Kubernetes, the way to spin up a big cluster specifying the size of the node, how many master nodes, how many config planes that you want, how many nodes that you want. It's a pretty tough thing to bring up a Kubernetes. Scalability. Kubernetes strength is very, very strong. They are very tightly coupled, and even they have the capability where on the cluster size, things or the nodes can be increased on the fly based upon the requirement. On a Docker Swarm, the cluster strength is weak as compared to Kubernetes. Worker nodes can be added to a swarm. Worker nodes can be asked to leave a swarm or can be taken out of a swarm based upon the requirement. So this is kind of a loosely coupled architecture for Docker Swarm, while Kubernetes, the cluster is very tightly coupled. Since Docker Swarm runs only Docker containers, containers find it very easy to share data and a lot of other things with each other because they all have the same signature. They are all from the same family. So it's very easy for them to share not just volumes, but a lot of other things. However, for Kubernetes, since it manages containers of different types, if your application has to share some data across different containers, there's a little bit of a complexity in how you would want your containers to share data. Also, when it comes to Kubernetes, Kubernetes groups containers in something called as pods, while a pod can have either one container, that's the preferred choice, or multiple containers. And the idea of pod is like each pod can run in any other node. It's not guaranteed that you would want to have 2 or 3 pods to be running on the same node. That makes data sharing a little bit of a different thing compared to Docker Swarm. GUI. So there's not a good enough UI tool in Docker Swarm, at least the CE edition of it, which will allow you to get to know what is running on your containers, what is the size of the containers, what is the volume of the containers, and all that stuff. There are some free and open source tools like Portainer, which gives you a good visibility into your running Docker containers. However, there's nothing at a swarm level that is provided by Docker. Kubernetes gives you an out-of-the-box dashboard, which is easy to configure and set up. You can also club it with some metrics services, and you can also get information about the size of the cluster that is running, what is the load on the nodes, and stuff like that. All this across your cluster in a very beautiful dashboard perspective. So that way, this is a little bit of a good UI for Kubernetes, while for Docker Swarm, there isn't anything that is provided out of the box. Let me spend some time in explaining a little bit about the Kubernetes architecture, what comprises of the Kubernetes cluster, what resides in a master or a control plane, and what resides in a worker node. This is a very high level depiction of a Kubernetes cluster. So this is the master node, which has got something called as a cluster store, a controller, a scheduler component, and an API server. And these are the bunch of nodes that are connected or administered by the master node. The master node can be 1, 3, 5, typically an odd number. This is as per the typical cluster management thing where you would need the master nodes to be in odd numbers so that whenever there's any contention in terms of what needs to be deployed where or where to give the job to whom and stuff like that, all the masters would cast their vote and they would decide on the outcome. So that's the master node, and there are a bunch of nodes which can be connected and administered by the master node. kubectl, or the command from using which anybody can assign some workloads to the cluster, can also be run either on the same node or on a separate node. So kubectl is the command line tool that we will be installing and using in order to fire up our commands to our cluster. So if at all I have to put up a job on our cluster, if I have to give out any specific commands to my cluster, all this is done using kubectl. There's a bunch of REST APIs which is used by kubectl, and kubectl will talk to the API server and fire up the commands specific to my cluster. What runs in the master node? Master node, without saying, it's the most important component of any of the cluster. If at all you're running cluster with only one master node, if your master node goes down, there's no other way that you can, or any user can talk to the different nodes in the cluster. So master node is the most vital component responsible for the complete Kubernetes cluster. There's always one node that should be running as a master node. That's the bare minimal requirement for your cluster. So what are the other components in the master node? The most important one is called etcd. So this is nothing but a data store, a value of key value pair, which is stored, which contains all information about your cluster. So all the configuration details, which node is up, which worker node is down, all this information is stored in the cluster store. So all the managers would access this cluster store before they go ahead and decide any other work item or anything else that has to be done specific to your cluster. What's in the controller? As the name says, controller is something, it's like a daemon server that is running in a continuous loop. All the time it is responsible for controlling the set of replicas, the kind of workloads that is running based upon the configuration that the user has set in. So if at all, if you are aware of something called as replication controllers, endpoint controllers, namespace controllers, all these controllers are managed by the controller component. If any user asked for some 3 replicas of a particular pod or a service to be running, and if at all any of the nodes goes down or the pod goes down for whatever reason, the controller is the one who wakes up and assigns this particular job or the pod to some other available node by looking up for the details using in the cluster store. That's the importance of the control manager or the controller. The scheduler assigns the tasks based upon whoever is asked for any job to be scheduled based upon a time frame or based upon some criteria. It also tracks the working load as to what exactly is the load, who is running what in the cluster, and places the workload on whoever is the available resource at that time. Alright, API server. This is one other important component in our Kubernetes cluster, where how would the end user deploy or give out any sort of a workload onto your cluster? All the requests come to the API server. So this is an entry point for all your requests that come into your cluster. Anybody wants to deploy something, anybody wants to scale up a controller, anybody wants to bring down few services, anybody wants to put in a service, all this will have to come in as a part of a REST API endpoint. And API server is the entry point. In case you don't want somebody to access your cluster, in case you want only specific people or specific users to be running some specific workloads, you can set all those role-based access control for this API server. So this is the entry point for anyone who wants to submit any job to your cluster. So that's a quick overview about the master node. What are the important components of a master node? Now let's go over to what runs in a worker or a slave node. As I mentioned earlier, slave nodes are something where the job that is submitted to your cluster is eventually run as a pod, as a service, as a container. So in Kubernetes world, there is something called as a pod. A pod is nothing but a combination of a container. It is a wrapper around your running containers. So slave nodes or the worker nodes typically run these pods. So that is where the whole workload typically gets run. But there are a bunch of other components in the node which also manages what runs in the pod, who has to have access to the pod, what is the state of the pod, is it in a running state, is it going down for some reason, and all that stuff. So let's quickly go over those components that is there in the slave node. The most important component, in my opinion, that should be on the node should be the container runtime. As I mentioned earlier, Kubernetes can run any different types of containers, not just Docker. So in case you want to have a node which wants to have Docker running on it, RKT running on it, LKC running on it, or any other container environment that is running on it, you have to ensure that the specific container runtime environment is available on that specific node, so that whenever a job is submitted, a description of what needs to be run as a part of the pod, what should be the image with which it should be powered, and what kind of a container to spin up. So that's what, when the job is finally assigned to this particular node, it would definitely need a container runtime to be up and running. So that exists only if at all the container runtime is installed and running on your Kubernetes worker node. Okay, now that we know what our Kubernetes node can run, how would somebody assign a job to our node? That is using something called as a kubelet. As the name says, kubelet is a small subset which talks to the kube API server. So any node which has to run any kind of a pod, all these instructions are passed around by the kube API server to the kubelet. And kubelet is capable of processing whatever job that is assigned to it and ensuring that so many pods and so many services are spun up based upon the requirement. The last component that exists in the worker node is the kube proxy or Kubernetes proxy. This plays a very, very important role, acting as a load balancer and a network proxy. So what typically happens is whenever the pods are running in nodes, the pods can be typically running in any node. There is no affinity towards any node on which these pods are running, because pods or containers are something called as ephemeral. They can run anywhere. So how would somebody reach out to these applications that is running in some pod, which is running in one container now and running in probably another container, another node altogether tomorrow? So that is where your Kubernetes proxy comes into the picture, and this component will ensure that any container that is spun up or any pod that is spun up, it keeps track of all these pods and kind of connects the endpoints or acts like a DNS server, so that it knows when somebody is trying to reach out to this particular service, which is the pod on which the service is typically running. So that plays a very, very important role by acting as a load balancer and a network proxy. Now that at a very high level we know what are all the components that make up of our Kubernetes cluster, let's go ahead and create a small cluster. We'll spin up this cluster on AWS platform. Finally, we get to the demo section of my tutorial. Now that you guys are aware as to what is Kubernetes, what is the use of Kubernetes, you also know at a very, very high level what are the components of a cluster. What is a master node or a control plane? What are the components of a master node, and what should be existing in a worker node? You're probably thinking that it's maybe pretty hard to kind of set this up. So let me demystify that by running you with a quick demo of how to set up a simple 3-node Kubernetes cluster using a tool called kops. And I will be doing this whole setup on my AWS cloud. Okay, so what is kops? Kops is nothing but a simple tool. This is an admin tool that allows you to bring up production grade Kubernetes environments. As I said, setting up a Kubernetes cluster on a bare metal is a little challenging. So that is why I would use something called as a kops, and I will use this on my cluster, which I will spin up on my AWS instance. So I have an AWS account, and what I will do first is I will first spin up an EC2 server. I will power this with one of the Linux AMIs, and I will install kops on it. Now this will be my starting point from where I'm going to trigger running up a big cluster. In our case, I'll try to keep it a little small. I don't want too many nodes in my cluster. I'm going to have one master node and 2 worker nodes. This whole operation would be done programmatically by installing this kops admin tool. So as you may know, AWS, it's a little hard for me to programmatically run other components or rather bring up servers. It's not pretty simple. So what I would do is I will create an IAM role which will attach to my EC2 server, so that my EC2 server gets powered with all the required role, so that it can go ahead and spin up cluster based upon my configuration that I'm going to specify. Alright, so once I have my cluster set up, I will also install kubectl, which you would probably know by now is nothing but a command line utility using which I can kind of connect to my cluster, give out some jobs, put some pods and stuff like that. So I will use kubectl. I will also have a pair of SSH keys, so that from this machine I would be able to successfully get onto the master node and submit jobs on my behalf. So let me begin by first logging into my AWS account. All the steps that I will be following to bring up my AWS cluster, Kubernetes cluster, will be documented, and I'll be sharing you this document in a GitHub repository, so that in case anybody wants to try, you'll be more than happy to find all the required instructions in one place. Okay, now the first thing that I would need is to launch an AWS EC2 instance. Now this is an instance where I'm going to install kops, and I will use it as a base server from where I'm going to fire some commands which will bring up my Kubernetes cluster. So let me log into my AWS account, and let me stick to one particular region, and let me bring up one EC2 instance. Alright, so let me launch my instance. Let me choose, doesn't matter either ways, but in case you want to try it on your free tier, I would recommend choose free tier only and choose an AMI of your choice. Let me choose this instance. I will make it T2 micro. That is good for me. Configuration, instance details. All right, I don't want to change anything here. That looks good. Maybe I will change this 30 gig. That's good for me. Let me add a tag to my instance. I will name this as my kops server. Alright, I would need a bunch of ports to be opened up. So what I will do is I will create a new security group called open to the word. I would not recommend that you do this, since I don't want to, it'll take a long time for me to specifically pick and choose the ports that has to be open for running my cluster. I don't want to do that. I will open up all the HTTP and HTTPS ports so that it's quicker. So I will say all TCP. I would say from anywhere, just to be on the safer side. I also open HTTP and HTTPS, and I will make this anywhere and anywhere. This is good for me. I will say review and launch. Alright, so I chose a T2 micro instance. Just for the sake of easiness, I've opened up all the ports, and the instance details are, you've seen what is that I've chosen. Alright, now important part is like I would need a key pair. I need to create a new key pair. I will call this as Simplilearn keys. I will download this key pair and then I will launch the instance. It will take some time for my EC2 instance to come up. In the meanwhile, what I'll do is I will convert. I have this PEM file, which is the pair of keys, the SSH keys with which I need to log into my EC2 instance. So I'll need to convert this because I'm trying to connect from a Windows box. I would need to convert this into a PPK file. So I have puttigen. I'm going to load my set of keys here and convert that key into a PPK key. All right, open. All right, I would say save. Hang on, save private key. Yes, I would say Simplilearn or Simplilearn private key. I'll save this here. Done that. That's all. So this is my public key, which is the PEM file, and this is my PPK or my private key. Now using the private key, I will log into my EC2 instance. Okay, now my EC2 instance is up and running. It is running in this Ohio region, and this is the IP address of my public IP address of my machine. So let me connect to it. So I use MOBA Xterm, which is nothing but an SSH emulator. You can use PuTTY or any of these sessions which allow you to do an SSH. This is my IP address of my machine, and since I've spun up an Amazon AMI, the user, this is the default user. I would need to specify the private keys for my session, and this is the private key for my session. Say okay. I am in my Amazon EC2 instance. So let me look at what are the other things that I need to do. Alright, so as I said, I just brought up my EC2 instance, but I would need my EC2 instance to run few things on my behalf so that it can spin up other EC2 instances. It can also talk to an S3 bucket where I'm going to store the instance state of my Kubernetes cluster. Also some sort of an auto scaling group because I want to spin up more and more instances. I also want to have a private hosted zone using my Route 53. So I would need my EC2 instance to have all these sort of permissions for my server. So what I would do is I will go and create a permission, a role in the EC2, or rather in the AWS IAM role, and I will attach this IAM role to my EC2 instance. Alright, so let me go to my IAM, which is nothing but the identity and access management. I will create a role called as possibly COPS role. I will create a role. This role will be used by my EC2. So I'm going to click on EC2. I will say next permissions. They would need a lot of permissions, specific permissions to be very honest. And the permissions are all listed out here. S3, EC2 and all this stuff. Just to keep it pretty simple, what I would do is I will create a role with the administrative access. Alright, so I don't want any tags. I will review. I'll create a role name. I will say COPS role for EC2. Alright, so I'm going to create a role which has got administrative access role. So I'm going to create a role. So this would ensure that my EC2 instance from which I'm going to run my cluster would have all the prerequisite permissions so that it can go and spin up instances, talk to S3 buckets and all that stuff. Alright, now let us have our running instance get powered by this role. So I will connect this role to my running instance. Alright, so this is my EC2 instance that is running. I will say action, attach, replace IAM roles. So there is no role as of now. I would want my COPS role for EC2. This is the role that I created. So I want this new role to be assigned to my EC2. Alright, great. Now my EC2 instance, which is my COPS server, has got all the required permissions so that he can create a cluster on my behalf. Great. Now before this, let me do a sudo yum update-y so that any of the, because this is a newly provisioned VM, I just want to ensure that all my system libraries are all updated so that when I do install COP and kubectl and all those things, none of them will fail because of some dependency or package issues. So I'm just running a sudo update-y so that all the libraries are updated. Okay, looks like it is done. So let me go ahead and install kops. Kops is a pretty simple installation. It is available in a particular location. I have to just copy this and ensure that I do a curl and I install this particular stuff. All right, so it is fetching the kops tool. It's installing for me. Once it is copied down, let me change the mode so that I can execute it, and then also let me move it to my user local bin so that it is available for me in my path. Okay, that's pretty much the kops installation. Let me also do one other thing. Let me install something called as kubectl. So this is what would be, a tool using which I'm going to be firing my commands to my Kubernetes cluster once it comes up. Right, this is a pretty smaller executable. So kubectl. All right, so I have kubectl as well as kops installed on my EC2 server now. Okay, now what I'll do next is I'm going to create an S3 bucket in AWS so that the Kubernetes cluster state is persisted in this bucket. So let me create a simple bucket with this name, S3 bucket with this name. So let me go to S3 and let me create a simple bucket with this name. I will just say create a bucket. Okay, so the Simplilearn.Kubernetes is the bucket that I created. So this bucket will store all information about my cluster. Let me now go and create a DNS entry or a DNS zone or a AWS Route 53 hosted zone for my cluster. So this is required so that I can give a cluster name for my Kubernetes cluster that I'm coming up. So I will create a private hosted zone and possibly I will call this as Simplilearn.in. So this will be my name of my private hosted zone. In case you already have any other public hosted zones in your name, you can always put a Route 53 hosted zone specific for your domain name. Since I don't have anyone, I'm just going to create a simple private hosted zone. So let me head down to Route 53, click on any of these and you'll get these hosted zones out here. So I'm going to create a hosted zone here. I'm going to create a hosted zone. Click on create hosted zone. This would be Simplilearn.in. I want to create a public. No, I don't want a public. I want a private hosted zone, and I'm going to associate my VPC ID for this hosted zone. Since I'm going to try out all my exercises in the Ohio region, I will associate the VPC of the Ohio region for this. Alright, so this is the one that is specific to the Ohio region. So I will say this one, I'll say create a hosted zone. Great. Now let me come back to my EC2 box. My EC2 is all powered with whatever it needs in order to go ahead with the installation of my cluster. Only a few things that I need to take care of is that, now that I put a name for my cluster, I also have an S3 bucket that I've configured for my cluster. I will have to ensure that I need to put in these two configurations as a part of my cluster building activity. So I will open my bash rc file and I'm going to export these two variables. If at all you remember well, these two variables are nothing but the cluster name, which is nothing but the the private hosted zone that I created, and the S3 bucket where I'm going to create, or rather I'm going to store my cluster state. So let me copy these two and open up my bash rc file. Alright, so I will just add these two and copy these and export them out as my variable. I'm going to save this here. Now let me ensure that this gets picked up. Alright, I've got these two that I've configured, and I've also ensured that these environment variables are set. Now let me create a pair of SSH keys. This is to ensure that I can log into the box that I'm going to be provisioning as a part of my cluster. SSH-keygen. I don't want to give any parameters. Let it go to the home directory with the default name and without any passphrase. Alright, so I created a bunch of my key pair. Now I'm all set to go ahead and run my kops. Now kops will ensure that this will take some time for the cluster to come up, but this is exactly how I would define my kops command. I already have it copied here. So kops create cluster, the state of the cluster will be stored in this particular variable, which is what I have exported out. The number of node count is 2. Node count is the worker node count. If at all I don't specify, there's a configuration for specifying the master or the control plane as well. If I don't specify that, the default one is 1. So I'm going to create one primary or the master node and 2 worker nodes. Size of my master, node size of the worker nodes, what are the zones where I want this to be created, and where do I store the cluster information. And okay, I've already added this master count. This is actually not required, but this is the command that I'm going to fire off so that I bring up my cluster. All right, that went off very fast, but this actually did not create a cluster. It is just the definition of a cluster, and that's why this came out very fast. Now that everything looks good with whatever configuration that I specified, now let me go ahead and create the cluster by saying corps update cluster -a. Yes. Now this will take some time, a good 5 to 10 minutes for it to, because this will actually start provisioning the servers. And as I mentioned earlier, based upon my configuration, I'm going to come up with 1 master server and 2 nodes, or the worker nodes. All right, so this is the command for me to validate the cluster. Then I'm going to try it out first. I'm pretty sure that it will fail because all my servers are not up yet. It is taking some time. The validation, everything failed. But let me try to look at my EC2 instances and see how many servers do I have running as of now. If you see, I had only 1 server that I had started, which was my COP server, and automatically the other 3 instances, one is called nodes.simply.in. These 2 are the nodes, and this is the master node. So these 3 got automatically provisioned by the COPS command that I ran. Alright, so this may take a while for it to get validated, a good 5 to 10 minutes. So what I'll do is I'll pause the video now and I'll come back once the cluster is up and running. It's been a good 8 to 9 minutes since I started my cluster. So let me validate now. Okay, seems good. So there's a master node, minimum 1, max 1, some nodes which are nothing but the slave nodes or the worker nodes. There are 2 of them, T2 micro, subnet. So my clusters seem to be up and running, and my cluster name is Simplilearn.in. So what I would want to do is now let me just log into the master and see if I can run some pods. So let me get back to my installation steps here. The validation cluster is done. So let me log into since my cluster name is Simplilearn.in, this is the way to log into my box. So let me get into my box. So if you see here, this is the host name of the machine that I'm currently in. If you see this is nothing but this COP server. This is a server. Now from here, I'm trying to get into the master box. Alright, so if you see, the IP address has changed. I was in a different box. I'm in a different box now. If I see host name, you'll find a different host name. So this is 153, which is nothing but the master node. Yep, it's 153. This is the particular host. So I'm getting into this machine now. So I started the cluster from my COP server here. It ran and brought up 3 nodes. So I'm actually getting into my master node and see if I can run some pods on it. Alright, so let me try kubectl get cluster info. Try kubectl get nodes. Alright, so there are 3 nodes here, master node and 1 master node and 2 worker nodes. So let me see if I have some pods here. Kubectl get pods. So there's no pod as of now. So what I'll try to do is let me just spin up a very simple pod just to check if my connections everything is correct or not correct. I have a simple Node.js application that I've built and I've got a container for that. This is already pushed to the Docker Hub registry. It is called Simplilearn Docker Hub, and the image name that I have here is called my node app, and I will use this image to power one of my pods that I will run. So this is the way in which I'm going to launch my pod. Let me show you these commands. Kubectl run, the name for my deployment that I'm going to run, -- image, and this is the image that is going to be powering my container. So this is Simplilearn Docker Hub / my node app -- replicas equal to I want 2 replicas to be running, and the port that I want to expose this particular pod is on 8080. So let me run this. As soon as this is run, it creates something called as a deployment. Alright, now let me just say I'm not really interested in the deployment. I'm interested in checking if at all the pods are up and running. So I will say kubectl get pod. Alright, so that was pretty fast. So I have 2 pods that are running here. These are 2 replicas because I asked for 2 replicas. These pods are running, so I can run kubectl describe pod pickup. Alright, I can pick up any of the pod name and see what is the pod, what is the information does it contain, from what is the image that is pulling, what is the image name, ID. This is actually running my pod, which is actually spinning up a container. Great. So far so good. So in Kubernetes, the pods are ephemeral. So they can be there at any time, cannot be at any time. If I need to expose my pod outside, I will have to create a service for my pod. So what I'll do is I'll create a very simple service by exposing this particular deployment. Before that, let me check kubectl get deployment. So there's a deployment that is created. The deployment name is Simplilearn app. So I will expose my deployment Simplilearn app as I'll just expose this. Let me see. All right, I'm not specifying what type and all. I don't want to get into the complications of what are the different types of exposing this service and all that stuff. So if I don't specify anything, it gives me something called a cluster IP. So this is where my pod is actually exposed. So let me just check if at all this pod is up and running. I'll just try a simple curl command. Curl http : this is my cluster IP and the port is 8080. If at all I hit this, it's actually hitting my application and giving me whatever. I put a simple sys.out kind of a thing where I'm just printing the container ID of whatever pod is serving being served out of. So I'm actually hitting my container and I'm getting this output from the container. So everything looks good. My container is up and running. So let me just go and clean it up. I'll say kubectl delete deployment Simplilearn app. This should get rid of all the pods that I created. kubectl get pod. Alright, these pods are interminating things. Let me just check kubectl get services. There's one service. I don't want this service. Let me delete that. kubectl delete service. I want this. Alright, that sounds good. So let me come back to my host, my COP server from where I'm running. So I managed to successfully verify this pod, see if everything is up and running. So what I'll do is I'll just go ahead and complete this demo by going and getting rid of my cluster. So cops delete cluster -es. Alright, so this will ensure that it will clean up my complete cluster that I created. So I had 3 or 4 running instances. If you see that, all the 3 are shutting down because the COP server, which had COPS installed on it, is now got a mandate to go ahead and shut down and clean up the whole instances and all those things that I've created as a part of.
So this was the end of the first part of AWS full course. If you like this video, then please give it a thumbs up and share it with your friends. Also, if you have any questions related to this video, then please feel free to ask away in the comment section. Our team will reach out to you as soon as possible. Also, do check out the second part of AWS full course coming up tomorrow. Thank you and keep learning.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.